Hello, guys. Good morning, Miami. By a show of hands, who was here last year? I can't see any of your hands, so that's a bad idea. Well, we've come a long way from last year. Last year, we were in a little tent. We called it the Foss Dome. It was more of a tent than a dome. But it was very active, and we had a lot of people there, and people were very excited about it. So this year, it was important for us to do it bigger. Might have overshot it a little bit. It was pretty huge. But at the end of the day, I hope we fill up this stage every day. We're going to have it today, tomorrow, Friday. Really fantastic lineup. Absolute all-star developers, open source contributors joining us. I imagine since most of you are here bright and early on the first day, that you understand the importance of open source. I was going to ask you how many of you are open source contributors to raise your hand, but I'm not going to be able to see your hands. So I just wanted to say that I really do appreciate all the work that all of our contributors do in this space. They are what makes this movement possible. Open source, has obviously two main benefits to society. One being that we don't have to trust the code we run, that we can verify it ourselves, that it's independent of any corporation or entity that's in control of it, and that at the end of the day, this code can often be modified, distributed, improved, and will outlive any of the individual creators. It's very viral in nature. And I just am absolutely moved by everyone who continues to work in the space, work in open source, oftentimes for very little compensation when they could have, a big paying job with some major corporation that is KYCing you and trying to control everything you do and lock you into a system. I also want to say just a huge thanks to the Bitcoin Magazine team for putting this together and really trying to make this a first-class experience for open source. We have obviously the largest Bitcoin event in history happening in this venue today and over the next few days. But this room, I believe there's about 1,100 chairs in here, is larger than most conferences on its own. And we cannot have the largest Bitcoin event in history without the largest focus on open source in history. So I'm really grateful for them to make it happen. This has been months in the process. Big thank you to Cash App for actually sponsoring it, because this was a very expensive room to book. And I appreciate you all for showing up, because this is a movement of people. Without people, the code is just words, right? We need the people to actually run it, build it, use it, support it. And that's what makes this movement great. I love you all. This is a very big moment. We're going to have a lot of fun together. We have some really great programming today. Today is going to be more technical focused. The next 2 days will be a little bit more accessible, a little bit more mainstream focused, but we have some really all-star open source contributors that will be on panels today. And I'm looking forward to it, and I hope you're looking forward to it as well. I got this big screen that's just me in front of me. It's just kind of weird. I have 5 more minutes. But I don't think I'm just going to walk on stage and just keep talking. We're running a little bit behind, which is natural for these types of things right in the beginning. So we're going to get started and keep on building. I appreciate you all. Thanks, guys.
Hello, everybody. Welcome to the open source stage. Matt did a great job stalling an opening for us, doing this thing. Welcome, everybody. Let's do quick intros for the people of the audience. specifically, and you, the viewer. Yes. I'm just so happy to be here with everyone. João, do you want to maybe say your name correctly and also give a quick intro? Let's maybe, we have a little bit of time, but maybe keep intros short so we can get to the good stuff.
I'm João. I work at OpenNode. We basically do payments in the Bitcoin space. One of the first to do Lightning, and happy to be here.
Cool. I'm Lisa, also known as niftynei. I work at Blackstream on Core Lightning, recently renamed.
I'm Roy. I'm building Breeze. Breeze is a Lightning wallet and a platform to interact with the Lightning economy.
And I'm Ryan Gentry. I do business development at Lightning Labs, where we develop LND and liquidity services, which is the topic of the panel.
Perfect. I'm glad you're able to make it.
No, absolutely. Thank you for having me.
And I'm Michael Tidwell, moderating this great panel of candidates here, panelists. I run infrastructure at Zebedee, a gaming platform company. So let's jump into it. And I think the first thing I want to do is let's maybe talk about a little bit of history of LSPs. I have no idea what an LSP is, being fairly new to Lightning myself. Maybe someone on the panel, maybe Roy, can break down what is an LSP? Who even made up this term? What is this?
That's a good question. I don't know. Someone came up with a term. LSP is a Lightning Service Provider. It's kind of the way that everyone can plug into the Lightning Network. Similarly to the way that you have an ISP and you plug your router in your home and you're plugged into the internet, the same way we need an infrastructure in Lightning that allows you to be connected to the network as seamlessly as possible. So that's why, I remember I coined the term LSP. Oh. Yeah, so that's why I came up with this concept of a Lightning Service Provider, and that's the service that facilitates this connectivity to the Lightning Network.
Great, and I just want to say, it seems, I feel like we could talk about this stuff maybe for like an hour and a half, because we're all doing pretty different things with Lightning and LSPs and whatnot. Like for instance, Zebedee is doing custodial LSP stuff, and Breeze, on the other hand, non-custodial, and we have a lot of cool things in between. I mean, there's so much to dig into.
Yeah.
I kind of want to, maybe we can kind of piecemeal this and kind of see where it goes, but because these topics, because within LSPs, there's so many different kind of, I guess you can say, use cases and implementations, I guess you could say. Maybe we start with non-custodial Breeze route and then kind of work our way to what everyone else is doing?
Yeah, yeah, sure. Not to shit on custodial solutions, but the only way that you can do Lightning is in a non-custodial fashion. Lightning is the extension of Bitcoin. Bitcoin, all the properties of Bitcoin of being censorship resistant, open, borderless, etc. We need to bring that to the Lightning Network. So the only way that you can do Lightning is in a non-custodial fashion, and the function of an LSP in that topology is how do you, as a user, how do you connect to the network? You actually need to run a node, right? The node is the entity that facilitates your participant in the network. So let's say you were able to run a node, and in Breeze, for example, we allow you to run a node on your mobile device. A node can do anything inside the Lightning Network without the ability to plug into the network. So the LSP is the bridge between the network and the end user node. And the way that the LSP needs to connect the user to the Lightning Network is by opening a channel. There's an entity in Lightning Network which is called the payment channel. The LSP needs to open a payment channel and provide liquidity to the end user.
So for the other panelists here, does anyone have a different take? Like for instance, the thing that Roy just described, does it scale? Does anyone have any maybe counter objection or slightly different angle that they would want to talk about here? Or does everyone just 100% agree with Roy? I'm just curious. Any?
I think the key thing that Roy said that I definitely agree with is, when we think about Lightning, we think about there's the core of the network, which is largely service provider nodes, big nodes that are doing routing, and then there's the edges of the network, right, which is generally the users, right? And so some users will be, operating on a custodial node, some will be on non-custodial, but that function of connecting the core to the edge, that is the service that's provided, is connecting you to the broader Lightning network, which, I particularly work with a bunch of, like a cross-section of a bunch of different LSPs, like everybody on the stage, Lisa aside. There's all sorts of different use cases and different things that people are doing on Lightning, from, sending funds to, emerging markets, from, playing games, from paying podcasters, et cetera. And the function of making that connection seamless, of making sure that you can get from sats from the edge of the network through the core to some other destination, like that function at its core is what the Lightning service provider does.
And,
I would say it depends on the end user too, If you're talking of a big company, publicly traded company, they might not at this time be ready to run a non-custodial, infrastructure. They need some compliance stuff, the stuff we don't like, but that is necessary. So they might come, in this case, to us, because that's what they need to show to the regulators to like, oh, we're legit. We're running a service that complies to all the stuff that you need. So at the end of the day, it really depends on the end user, right? For me, from my perspective, obviously I would want this to be all non-custodial. But sometimes, if you're like McDonald's, they cannot run a non-custodial service today because they don't have an MTL, for instance. They're in the food business or real estate business, maybe. They're not in the finance business. So it really depends on where your goals as a company. Like, do you want to waste time pursuing that license, or do you just want to get a quick shortcut and get plugged into the Bitcoin network? So I feel like there's service for everything.
Lisa, did you want to, or niftynei, did you want to chime in on anything here?
When we're talking about liquidity, I think one thing, maybe be interesting to kind of talk a little more broadly about like what is liquidity on Lightning.
Before we jump into that, let me ask a quick follow-up for João.
Got it.
Which I still don't recognize you, even though I've known you for years. The hair's throwing me off. So do you feel like companies will probably, even long-term, will probably be non-custodial, and then maybe like your end users, like your actual non-business users are going to be non-custodial, or do you not see it that way?
I feel like there is a transition phase, right? Right now, they need to go through these services like what we do. But like eventually, long-term, the goal is to be able for the business to be self-serve, right? And ideally, the utopia is like every business runs their own infrastructure, they're in control of their money. But the reality is, I don't see that happening very soon.
So like 2 weeks, 2 years, 20 years?
I don't want to give a timeline. That's like asking what's the price of Bitcoin in 2 years.
Well, I was going to ask that next. Okay. Well, maybe we jump into the other L, the liquidity.
Oh, yeah.
Totally. Why don't you tee that off?
Yeah, totally. So I think one thing that's useful to understand when you're talking about liquidity service providers is exactly what service they're providing, right? Like, what is that liquidity that the L in liquidity service provider stands for? And it kind of goes back to how the Lightning Network is set up and what when we're talking about liquidity, we're literally talking about Bitcoin that's being committed to Lightning channels, right? And there's kind of this inherent problem with moving money over Lightning Network, and that is who and where is that Bitcoin that's been committed to Lightning channels locked up? Who's got it? Who's got the ability to use that locked up Bitcoin to pay someone else, right? This is becomes a kind of complicated problem, right? There's only so much Bitcoin in the world. What is it? Did we hit 18? Is it 19 million? 19 million was the thing. So there's only 19 million Bitcoin. A lot of that Bitcoin lives in cold storage or exchanges or people's wallets at home, whatever. And then there's even a smaller part of that ends up getting locked into Lightning channels, right? So I think one thing is like, okay, there's only so much Bitcoin available to be used on Lightning, et cetera. Okay, so then you've got the amount of Bitcoin that's locked into Lightning channels. Then in order, like, once you're operating on the Lightning network, your ability to send and receive payments, sending payments is like, I want to say a little bit easier. You can buy some Bitcoin, lock it into a Lightning channel, and then send it. So that's kind of like sending Bitcoin, sending Lightning over Bitcoin to some extent is bring your own sats. Like, you've got some money and you're probably gonna like put it in and send it out somewhere else. The harder problem is receiving money on Lightning. This is like tends to be, and you guys should definitely correct me if I'm wrong, this tends to be kind of the gap. The liquidity service providers fill in for that edge network that Ryan was talking about earlier. So the work of figuring out like, okay, we only have so much Bitcoin locked into channels, or like as a liquidity service provider, you know, if someone wants to receive a payment, the liquidity service provider has to figure out how to get Bitcoin to them from whatever channels, et cetera, they've got Bitcoin locked into already, et cetera. So we call this problem of like getting the ability to receive Bitcoin over Lightning, we call that inbound liquidity. Inbound liquidity is like kind of a valuable, difficult thing to get on Lightning. Part of the reason for this is you have to convince someone else to make that Bitcoin available to you before you can receive payments. So LSPs help solve this problem, and again, please like help correct me if I'm wrong here. You guys have a lot more hands-on experience with this than I do. But LSPs are the service that provides basically the ability to receive and send, but the receive part is the really difficult part of payments over Lightning. So some of the work that goes into that is like, okay, where do you have all this Bitcoin available? So like, you have to get Bitcoin available such that you can then pay it out to people, right? Someone else is going to pay you on the other end, but I think another, like, this is a little bit of a tangent, but sort of similar. Another thing about Bitcoin liquidity on Lightning is that I would call Lightning a over-collateralized network. If you want to send a Bitcoin from your node to 3 hops away, because Lightning is routed, you need 3 Bitcoin of Bitcoin already locked into Lightning before you can send 1 Bitcoin 3 hops away. So every payment that's made over Lightning requires a multiple of Bitcoin to already be committed to the Lightning network. So liquidity management and how do you, so you know, you kind of step back a little bit. It's okay, like we need a lot more Bitcoin on the network in order to make payments work than the actual volume of the payments that are going through the network currently as it stands. Maybe we'll come up with some really fancy ways to do rehypothecation on Lightning.
We don't like that word in Bitcoin.
But today,
So you mean there will be 22 million Bitcoin?
yeah. I mean, maybe we'll expand the Bitcoin supply, but like there's this, anyways, this is like the like sort of philosophical problem about liquidity on Lightning. So like then, you know, you're doing liquidity, it's like, okay, you're providing liquidity to people, like how much Bitcoin do you have? How do you attract more people that have Bitcoin that isn't on Lightning to bring their Bitcoin into the Lightning network such that we can use it as payment rails to move, you know, value around between people, et cetera. That's a long talk. Sorry.
So you made it pretty clear. Inbound liquidity is one of the biggest challenges right now for onboarding new people. It's one of the biggest challenges right now, and I'm curious. Maybe we can talk about how is this challenge being addressed, the inbound liquidity challenge, you know, and what are we doing to, you know, tackle this problem? Because there's a couple different ways, right? So
one thing that I think was really interesting last week when Kraken, you know, finally turned on their node and joined the Lightning Network. Their node, like last I looked, they had like rocketed up to something like number 10 in total capacity on the network.
everyone here is probably guilty of helping that.
Probably, yeah. But I think what's really interesting is like the inbound liquidity problem is generally absolutely agreed with Lisa that it is like the scarce resource and the hard thing to acquire. But then you have an entity like Kraken where people are like, you know, hey, we want them to succeed. We think there's going to be a ton of fees to be earned by routing payments to the Kraken node. Like, let's allocate a ton of capital to them, or they don't even have to pay for it. We'll just kind of like optimistically think that that's where we're going to earn a return from.
It's like,
right?
it's like if you're so cool and popular, it's like life is easy for you. You know what I mean?
I know. I don't know anything about that, but that must be nice. So I think that's been like a really interesting thing. And we've seen that a couple times where there are like new services that pop up on Lightning, and they ask, like, how can I go and get connected to the network? And we're just still in these early days where like kind of the best solution still is like put up the bat signal on Twitter and say like, hey, we have a new node. Can you please connect to us? And the community will generally open the channels to you. As it matures and the network gets bigger, I think it's fundamentally a market problem, right? It's as Lisa said, you're trying to convince somebody to allocate capital to your direction, and like, what's the best way to do that? Well, you just pay them, right?
I agree, because right now I feel like for Lightning companies or Lightning service providers, there's almost kind of like right now an excess of capital where it's like, I don't want to just deploy this randomly, but when I see a Kraken, I suddenly have plenty of capital to deploy, and I think we're kind of past like the 2019, 2020, 2021 where we just want to open up random channels to everyone. We want to be a little bit more thoughtful on that. So
it definitely has matured for sure.
I would say there are two different issues, like connecting to routing nodes to other hubs in the network and onboarding end user.
Yes.
These are two completely separate problems.
Would you think that that's like the core and edge distinction?
Yeah. And an end user can be like a service like OpenNode as well. So let's say an edge, onboarding edges and connecting to other nodes in the network. These are completely two separate problems. And I don't know if it's easy to send in the Lightning Network right now, because in order to send, you need to first receive, and then before you're able to send, you need to receive, and to solve the inbound liquidity problem. So I think what's cool about the inbound liquidity problem that it's being solved for end users at least. Like we don't have enough tools to manage liquidity efficiently currently in the Lightning Network, but at least to onboard users, there are a set of solutions that were put into place in order to facilitate this out-of-the-box inbound liquidity issue. One of the solutions is what we're doing at Breeze, opening zero confirmation channels. So we actually utilizing the liquidity of the end user in order to open liquidity, to allocate liquidity to the user end. So we open a channel and we push liquidity, the same liquidity that the user used to top up the wallet, we use it in order to provide inbound liquidity. That's one solution. Another solution is Pool. Solution like Pool from Lightning Labs is the ability to lease liquidity and to open a channel which is leased for, by default, a month, 2 weeks? What's the default?
There's a duration for 2 weeks, a month, 3 months, and a year now, I believe.
That's very cool. And the third solution from Lisa, I think, worked on it. It's liquidity ads where nodes can announce that they are willing to rent you liquidity for such and such price.
So we have Pool, we have Breeze with the model where if I download the Breeze wallet, I get inbound liquidity kind of by being a user of Breeze. Yeah, liquidity. I'm actually a little bit unfamiliar. Would you like to?
Yeah, I can talk about them a bit. So liquidity ads is a proposal that I wrote for the Lightning spec, so it's specified. That means that we are working with other Lightning implementations so that hopefully it'll be supported by every node on the Lightning network. It's basically a way to, I call it like a billboard system of advertising that you've got liquidity that you're looking to deploy. This billboard ad that you can put up, you can put in like how much you're looking to get for the capital that you have available. So you set your own rate of how much that your available capital is worth to you, and you can set that. You put it into a little advertisement. Those advertisements go into something in Lightning we call the gossip network, which every node on the network sends and receives. So you can advertise, you put a little bit of information, this little kind of like classified ad, called liquidity ads, into your gossip, goes out to every node on the network. So if you're running a node right now, you're currently getting all of the liquidity ad data, it's on your node. Whether or not your node exposes that to you is a different question, but if you're on core Lightning, you can see them. They're also available to see on lnrouter.app. which is like there's a little dashboard. You can go look at all the liquidity ads that are currently available. Anyway, so this is the way you advertise, like, hey, I've got some capital, I'd like to deploy it, here's how much I want you to pay for me. And then you can, if you're trying to buy or get inbound liquidity, you can go look at all the nodes that are offering liquidity, where they are in the network, whether it's worth what they're offering to you or not, and then decide whether or not to take them up on their ad. So it's super decentralized. I have no information for you. It's been out for maybe like 7 months now. I have no information for you about how many people have used it or how much capital has been allocated using that market, because that data only exists between the buyer and seller. You can go look at, I think the number of ads is like, we're close to like 15, 20 these days. So it's like small but growing. Yeah.
I want to talk a little bit custodial with you, but before I do that, I want to jump and wrap up maybe some pool, because we didn't really talk about pool much.
Yep.
Where do you see the leasing liquidity industry, the leasing channel market? What is it like now? What was it before? What's it going to become? Maybe you can talk a little bit about that since you're familiar.
Sure. So what it was previously was like before we had channel leases as like a formal kind of financial product on Lightning. It was all handshake agreements between people on the stage, right? Saying like, hey, message you on Telegram, hey, can you please open one Bitcoin channel to me? Like, we're expecting a lot of volume this weekend or something like that, right? That obviously doesn't scale if we think the Lightning Network is going to be tens to hundreds of thousands of nodes, businesses being able to interact. So turning that kind of interaction into more of a market interaction, saying, I will pay you X amount or X percent of the capital that you commit to me, as long as you keep that channel open for, say, a 3-month period, right? And I think the cool thing that both Pool and the liquidity ads construction does is that lease term is actually secured by Bitcoin script, right? So if the channel is opened, it actually, those funds can't be decommitted from that channel. Bitcoin itself will not allow that channel to be closed until the duration is up, which I think is a really cool construction.
So it's like I can either use like something like Pool or like a competitor or whatever to get like inbound liquidity, or I can just start an exchange and get really popular and get a bunch of users and they get free inbound liquidity.
Yeah,
or just like a bunch of Twitter users and just say, hey, I need inbound liquidity.
Or we can download Breeze and like,
or you can down. So I guess
the final thing that I want to say on that though, which is really interesting, is we've seen in Pool the lease rates are public. If you're running a node, you can download all the data and read through all the history. And so we've seen over the last couple months so far this year that demand is really starting to pick up. Rates are starting to get pretty sustainably high, which means that there is now while maybe in the early days there was an overabundance of supply, demand is starting to kind of pick up and push prices up, which should, in theory, then induce kind of more supply coming onto the network. Because if you can earn, 6% annualized on your Bitcoin for opening a channel to a node that wants it, that's a pretty good deal.
Or you can trust all your money with a custodial, I'm not going to name names, kind of like, hey, we magically give you 6%, and they take. This is this might be the only thing I can think of that's non-custodial, actually providing a service where you can get a little bit of income on your Bitcoin potentially, right?
Absolutely, and
And that's key. We need to break a myth here. There's a misconception that Lightning is free.
Yes.
And in order for Lightning to be successful, the routing fees need to go higher, and Lightning needs, basically the entire thing about liquidity is why would people allocate liquidity, going back to what Lisa said. What's the reason that people will put their liquidity in Lightning? They want to generate yield, right? So if people put liquidity in Lightning and they are able to generate yield, then people will put more liquidity in Lightning. Yep. So there's a circle here of traffic brings liquidity, liquidity provides yield, yield provides more traffic, traffic provides more liquidity. So we need to start thinking about Lightning as an economical tool, and Lightning, long term, if we all want Bitcoin and Lightning to be successful, it can't be as cheap as it is now.
Thank you. Can you scoot forward just a little bit?
What's that?
Just scoot forward a little bit. I need to tell you, these guys think non-custodial Lightning will scale. And I just want to talk like real between Zebedee and OpenNode right now about how like Lightning will actually work in the future.
I actually have a cool story about liquidity. There were a trending that we're seeing. So we're working with like pretty big digital wallets that today in our world. And what we're doing is they actually are connecting to us saying, yo, we need to connect before launching our product. Let's do some private channels because they don't want to announce first their node on the network because they don't want to get attacked like the US. And then so we actually signed contracts, like legal contracts about channels.
Like not smart contracts, dumb real contracts?
Paper contracts, yeah.
Okay.
Like real contracts. So it's a trend we're seeing, like we're actually like signing contracts about opening channels to these service providers.
That's good. That's a sign of maturity of Lightning.
Yeah. And I think we're going to see that more often in the future.
One thing on the fees, which you're absolutely right on, but I just happened to be looking at the numbers last week. So Visa, MasterCard kind of average rates that they charge for domestic payments is like, and you would know this better than me probably, is 1.29% plus 5 cents for per payment. I looked at like the top 5 biggest nodes on the Lightning Network, and it just so happens that the average fee rate across those 5 nodes is like exactly 90% of that. So it's the 10x difference. It was like 13 bips or something.
Okay.
Which I think is just like a very interesting way that this free market decentralized ecosystem has kind of coalesced at a rate that is typical venture capital wisdom is in order for something to a new network to disrupt the incumbent, it has to be 10x better in fees. And so I thought that was just interesting that is kind of where the rates are right now.
And it happens very naturally because fees are your only tool currently within the Lightning Network to say like how do I want the liquidity flow to be. Like if I want the liquidity to flow from one end to another, I need to have lower fees. And if I wanted the liquidity to flow in the other way from B to A, if I don't want the liquidity to flow from B to A, I need to set high fees. So it's basically represent like the opportunity cost of the liquidity. So and fees are the only way to control the how Bitcoins are flowing within this Lightning Network.
When I analogize Lightning to normies, I talk about how the channels are like roads and your fees are like your traffic lights.
Okay.
Right, where it's like if you don't want traffic to flow down this way, you got to hike the rate, which is like turning the light red.
Nice.
And if you want traffic to flow, you lower the rate and make the light green, which I think is accurate.
Yeah.
Nice. I love that analogy.
Really good.
Yeah.
He runs red lights.
Yeah, much better than my beads on a string analogy.
Well, but it takes all kinds.
Yeah. I did want to talk a little bit. I want to involve this gentleman right here, and say what do you think the challenges are? We talked a bit about non-custodial liquidity, Lightning service provider challenges. Although it doesn't fit Roy's definition to a T, we can maybe caveat it with the custodial Lightning providers. What do you think the challenges are for people like you and I, stuff like that?
I think the risk of custodying Bitcoin is the biggest challenge. I would say there's a huge risk to like hold Bitcoin. It's something that you don't want to do. And once you're holding Bitcoin from someone else, there is compliance risks. There is all certain of legal stuff that you have to go through, especially if your company is in the United States. That's why a lot of people do not make their company in the United States. But I would say the biggest challenge is definitely the user onboarding today. Obviously, custodial makes it easier, it makes it simple. Is it the solution? I don't think so. It is. I think you guys are doing a really good job on that. But so far, we're still in a transition period, right? And if you want to involve certain parties in this economy, we need to make tools that are somehow easy enough for them. And it's a transition period. I would say, obviously, long term, the idea is to everything to make a trustless system, non-custodial. But right now, we still have to go through this transition phase. Like people still need the dollars,
What about hot wallet, cold wallet kind of concern? Does that concern you?
That's what I was saying. It's about the
Because
risk.
when you look, just to explain the audience that when you lock liquidity in Lightning, it's being locked in a hot wallet currently.
Yes, there's definitely, so yeah, it's basically a hot wallet where your Bitcoins are exposed somehow to like, they're online, right? They're exposed to the internet, to the outside world. While when you're doing cold storage, you know, the Bitcoin, your secret, your seed, your password was never like interacted maybe with the computer. So there is no way for anyone to know that password. And so when you're locking up funds in Lightning, those funds are somehow exposed, or there is a chance that eventually they might get stolen or not, depending on security practices, right? But I think we're coming up with tools like the remote signing, you know, things that are improving. You know, the software is going through another phase now where like, okay, things are being pretty risky now. Let's decouple the stuff and try to make the signing stuff like a cold storage offline, where you like, because every time you do a transaction on Lightning, you have to update the channel. And to update the channel, you need to sign a transaction. So eventually, that software needs to have access to the signer. The problem here is the signer, right? You don't want to expose that entity to the internet, because then you have a threat. If you expose your password, or you're not exposing your password, but there is a way that eventually someone, if they know enough about you, might be able to get that password. And when you do cold storage, that information is not accessible anywhere. But with the remote signing tools, I think we're
getting there.
Yeah, we're getting there. Not there yet, but we'll get there.
We're getting there. On the hot wallet risk, one interesting thing. So we have a liquidity service we provide called Loop, not to be confused with Pool.
It's just you spell it
We
backwards.
just spelled it backwards, yeah.
Simple.
And so Loop is a submarine swap provider where it's a bridge between on-chain Bitcoin and off-chain Bitcoin, where if you need more inbound liquidity, you send funds to Lightning Labs, and then in a non-custodial way, we return the funds to you on-chain. One interesting use case for that, more so than just needing to acquire inbound liquidity, is actually risk management. Right? If you want to make sure that the amount of capital that you have on your node stays low, that's on your side of the channels, one thing that we're seeing a lot of folks do is just continually make sure to loop out, to send funds out of their custody and return it back to their on-chain wallet, which I think is an interesting thing that, you know, as the network has grown, has become something that, yeah, like, you know, all of a sudden certain providers say, man, we have like 100 Bitcoin in this node. Like, we got to be careful. We got to like
Start looping out
and start using some risk management practices, which I think is very interesting.
Cool, and we talked about a couple things. We remote signing, and in terms of the future of LSPs and things to look forward to, what kind of, like, I know we have Nifty here at Blockstream, we have Ryan, Lightning Labs that are working on implementations of Lightning that kind of help enable some of these things. What can
I'll tell you from a user, like from a
he's
guy.
going to tell y'all what he needs, and then y'all can build it. Yeah.
Exactly. As a
Great.
guy that's
Perfect.
running an LSP, what I need better control of my liquidity. I need better flexibility to manage my liquidity. So I think in that regard, I'm looking forward to splicing. Splicing is the ability to change the capacity of the channel dynamically without closing the channel. And basically, if you, let's say, I'll give you a very simple use case. Let's say we have a user. The user is using Breeze to get inbound liquidity. So we open a one BTC channel to the end user. The Bitcoin are on the user side. The user used the entire BTC to pay for stuff. And now I got one BTC locked in the channel on my end of the channel. And the user stopped using Breeze for some reason. I don't know why. It's a great product, but they stopped using Breeze. And now I got liquidity locked on my end of the channel as an LSP. And I need to reallocate this liquidity because I want to onboard new user using this BTC, or I want to put this liquidity somewhere else where it generates much better yield than the user that doesn't use Breeze anymore. So in order to take this liquidity out of the channel, I need a way to splice out. I need a way to dynamically configure the channel to have a lower capacity, so I'll be able to reallocate this liquidity someplace else.
So any implementation that doesn't support splicing obviously hates Bitcoin. So what are we going to do to fix this problem?
Core Lightning is working on splicing. The great news so the cool thing about the liquidity ad stuff is a lot of the background work we had to do to make liquidity ads happen lends itself real easily to making splicing happen. So we are actively working on making splicing happen. Hopefully that will come out at some point.
In 2 weeks.
2 weeks, yeah.
2 weeks.
We'll look for it in 2 weeks. It'll be great, yeah. So, yeah, we hear this, and I'm like, man, it's so much fun to think through all the ways that splicing lets you do wild stuff with your channels when you get it going. Yeah, the way that we wrote like some of the precursor stuff we had to do before we could get liquidity ads is this thing that I'm calling collaborative channel opens. It used to be called dual funding, but that got a little, let's say the namespace collision started happening, so we're calling it collaborative channel opens now. Anyway, so all that work that we did to make that happen, you can do this cool stuff where you can splice across multiple channels all in the same transaction with multiple peers, on Lightning, decentralized, it's like cool stuff. So we're hoping to bring that to splicing real soon. That's the plan.
Thank you, Lisa. Bryan?
Yeah, same, 2 weeks. It's like another side of this, and as an infrastructure guy, I imagine you have thoughts on this. One really funny thing that happened like a year ago is I remember talking with a bunch of Lightning companies about kind of like what they wanted from L&D in the year 2021. And it was the first time that instead of it being new features and new techniques and new cool bells and whistles, it was can we have accounting software?
Yeah.
Can we have, like a more scalable database, right? It's like very like adult requests instead. And so I think that's like the other lens of this is running the infrastructure and scaling like your back end and, like the Postgres stuff that we're working on, that kind of making sure that just your nodes stay online, that they're, easy to manage, that you have all the data that you need as well, like, data that you need for reporting requirements and, accounting stuff. Like all of those kind of boring tools as well is something that, is increasingly more in demand as Lightning companies get bigger, succeed, raise money, and get more kind of.
That's Ryan
more
Wait
requirements.
saying me wait.
So
I said 2 weeks.
Okay.
Yeah.
I am curious though, maybe this is something that anyone can talk about. Does Bolt 12 or Taproot affect LSPs, and if so, what way? What's better? Because I know, like for instance, LMD is a little bit more, or sorry, not LMD. Lightning Labs is a little bit more focused on supporting Taproot, and I was just curious. Maybe we can talk about that a little bit. How in its relation to providing service like LSP.
Well, so I think Taproot, just from like a fundamental level, just opens up like a much bigger design space for what can be done on Lightning. I think it enables a lot more use cases, just kind of upgrading the channel commitment types and things like that to supporting Taproot. It's more of like kind of like a platform upgrade, so to speak, to think of, right? And I think that's kind of like a little bit of a longer term thing where you can think of for instance, I know one thing that Roast Beef is working on is the concept of dynamic commitments, where like right now, if you wanted to upgrade a channel that's a normal pre-Taproot channel, you would need to close the channel and then reopen a new Taproot one and spend to a new Taproot output. Working on a proposal to be able to allow that. If you think about that at scale, right, there's something like 80,000 channels on the network right now, public channels, like 80,000 Bitcoin transactions, closing channels, and then reopening would be like pretty heavy. But with dynamic commitments, being able to do that kind of on the fly and upgrading your commitment output without changing the channel is a cool thing that then allows for wacky things like our proposal yesterday, Taro, which leverages, it will be Taproot channels where you can send assets that aren't Bitcoin. Say a fiat-backed stablecoin or something like that, you could send those over the Lightning Network. Those channels require Taproot outputs, right? So things like that.
And that proposal actually increased the demand of liquidity inside the network because these assets move between one node to the other. They're being Bitcoinized.
Bitcoinizing the dollar.
Yeah, exactly.
That's the meme.
So you need more Bitcoin collateral in order to facilitate new assets. that will increase the demand of having more liquidity in the Lightning Network.
Yep.
Nifty or John, did you want to chime in on?
I would say privacy, right? I think it's the big one here. It's the basic one. Taproot will bring privacy to Lightning, because today you can literally look at on-chain and see what channels were closed and kind of figure out the liquidity and what's happening. And with Taproot, it's just going to look like another transaction. So I think that's a big win.
With
We're going to talk about privacy more on Friday. I'm doing a privacy panel. We'll get way into that. I'm going to push back and say that just upgrading the Taproot outputs isn't actually going to solve the privacy problem. I think the biggest thing is moving to blinded routes in Bolt 12. Right now, no one cares about on-chain footprint. If you're handing them an invoice, it tells you where the payment's going, what you're paying for, how much it's for. Like, you don't even have to look at the chain if you give someone an invoice. So I think Taproot's cool. I think Lightning's gonna get to Taproot soon. Upgrading it, doing dynamic commitments is an awesome thing. Miners might not like it so much as the people running the channels, but that's fine. But yeah, anyways, Taproot's cool. It's coming. I'm really excited about the novel engineering that Labs is doing with Taproot stuff, and excited to see how that goes. But yeah.
Okay, we have a few minutes left. Do you want to do closing thoughts? Do you want to maybe start with João?
No, I want to ask
Oh.
LN URL versus Bolt 12.
Oh, okay. Well, let's rephrase the question real quick. Instead of doing closing thoughts, let's just do LN URL versus Bolt 12. Let's get into it. I'll sit right here. Y'all go for it.
Yeah, I'm just from a service provider. There's a lot of demand for this type of stuff. So I know Lightning Labs as a position, C Lightning as the other position. So I'm just curious to hear both your thoughts about why you want to invest in Bolt 12 and why you don't want to invest in Bolt 12 right now. Just curious. I'm the moderator now.
So Lalu published his thoughts on this, and I think he stated it well. It's we're a small team. We have something like 26 people. There's only so many engineers, and the priority is doing Taproot stuff. And I think in particular, one thing that we've talked a lot about is responding to the developers in particular that are building on our stuff. And we haven't had a bunch of developers beating down our door saying this is wrong. We need you to focus on Bolt 12 instead, right? Because they're kind of happy with LN URL, right? And it's bad business to tell your customers that they're wrong. And so that's we're focused on Taproot, and I think that's kind of it. I want to be clear. I don't think we think Bolt 12 is necessarily a bad proposal. I think blinded routes are great. I think the static invoice is great. There's a bunch of good stuff in there. It's just not the priority for this quarter.
I think we need both. I think we need Bolt 12 facilitate payments between peers in the network without the need to have an HTTP web server. And LN URL is great for custodial services that have online presence, and it's great for merchants that have a web presence. So whenever you have a web server, you can definitely build on LN URL, but it doesn't solve the problem of the ability to send payments to other users in the network without creating an invoice first. And for that, we need Bolt 12.
But you still do have to generate an invoice, right, with Bolt 12. You have the static part, but you still need to go and actually fetch.
You need a pointer. You need a pointer to begin with, but the pointer doesn't need to be an HTTP server, right?
Yeah.
It's like AMP. What's the difference between the essential core difference between Bolt 12 and AMP? It's the ability to have proof of payment. That's for me the big difference between both. And you guys have AMP, and you don't have Bolt 12.
Well, but I think it is a little bit different because you still do need to do invoice fetching with Bolt 12, right? You still do need to get a secret to pay. Whereas with AMP, it's actually static. There is no interaction required. You can just pay to a pub key.
Okay, but you need to receive the pub key from somewhere. You need a pointer.
Hey, not to interrupt the family conversation here, because I love this, and I feel we should have a Bolt 12 LN URL pay kind of discussion maybe.
Fight.
We need fiat. We need fiat Jeff though.
We need we should like WWE people start sliding in, bringing in chairs and stuff. But we're out of time. I just want to give everyone a few seconds just to do like a closing. How do people know about you? If you want to show your Twitter, if you want to let people know how to follow you, whatever it might be.
Yeah,
Yeah.
you can find us opennode.com or openit on Twitter. You can find me João Almeida. It's a hard name, so you're not gonna find it. Yeah, you can find me on Twitter.
Yeah, I'm niftynei, so NIFTYNEI, if you want to follow my Twitter. I also work with Core Lightning, so core_LN is our Lightning node implementation. I work at Blockstream, who obviously is also on Twitter.
Yeah, you can find me on the Breeze various handles, Twitter, Breeze_tech, Breeze.technology, that's our website. You can join our Telegram group, Breeze.
Breeze spelled BREEZ.
Without an E at the end, yeah.
Yeah, I'm Ryan Gentry, Ryan the Gentry on Twitter. Follow us on Twitter as well at Lightning. And the website is lightning.engineering. Thank you, Michael, for such a well-moderated
How
panel.
can we find you, Michael?
Yeah, how can we find you? That's the real question.
I'm Mike 20 spelled out with a 1 on the end. It's so obvious. And I'm not that popular, but for some reason I have tons of scammers. I'm not giving away free Bitcoin.
And when's TapConf, the next TapConf?
Well, not to shill too much because we're at a conference, but TabConf is a technical focused conference in Atlanta, Georgia. It's going to be in October. TabConf, TABCONF, tabconf.com. Yeah, thanks for helping me shill that, I guess. Yeah.
You're welcome.
Yeah. Well, all right. Thank you, everybody. Thanks
Thank
for
you.
coming.
All right. So this is the Future of Lightning Development panel. Sadly, we lost our illustrious moderator who couldn't make it to Miami in time. So instead, I get to moderate these two lovely folks. So why don't we start with Hannah, and we can do quick intros of who you are and what you work on, and then we'll dive right in.
Cool. I'm Hannah Rosenberg. I work as a developer advocate at Lightning Labs, and I've been, in the Bitcoin space a while and obsessed with Lightning since it came out. So delighted to be here talking about it.
Yeah, hi, I'm Chris. I've been in this space for a long time, 2009. And my hobby became my job, so now I'm working for Blockstream on Core Lightning.
And I'm Matt. Sadly, Christian predates me a little bit, but I did get into Bitcoin in 2011. I have the illustrious claim to fame of I actually wrote the first payments channel implementation anywhere long before Lightning and before we had routing or in fact, bidirectional payment channels. And I don't think anyone ever used it, but
No, I
that's
did.
okay. Oh,
Yeah.
that's good. You're the only one.
We had a student project working on it, so
Oh, all right. Well, good.
yeah. It was usable, so good job.
Thanks. I might have tested it once. So we're gonna talk very briefly about kind of the history of Lightning and how it's grown, and then we're gonna get into how we see it maturing and going from there. So I don't know who wants to start with. Hannah, you want to start
I'd
with
love
how
this one. I think the past year, just since I was at this conference last year and then till now, like just watching the explosion in Lightning, and it's been really interesting to me to watch Lightning progress from, just a proof of concept where everyone was like, is this even going to work? To, then being very much in the hobbyist, enthusiast territory, where you're on the command line and, only people that are, nerdy enough to be on the command line can use it, to then we get much more user-friendly stuff going on. And then now it's moved from hobbyists more into businesses really attempting to use this in their products and services, and just been this huge explosion, and it's been really amazing to watch and to think about where it might go from here.
Yeah, and I would go further and say it's specializing, right? So it's gone from hobbyists, but they still exist. They're still there. They're still running PlubNet, and it's still routing a lot of payments. And we have I now work for for, I guess, Block is now our name, not on Cash App, but Cash App now deployed Lightning, and that's a whole different world. And then we just had the LSP panel and the mobile Lightning world, and the LSPs also need a whole different set of things. So let's kind of split up the future of Lightning development by those categories, and then kind of dive in from there. So let's start with mobile. So we just had a bunch of discussion about LSPs and what they need, but maybe let's look more towards the future and talk about what do these mobile clients themselves need.
Yeah. Yeah, and LDK is a fabulous tool for mobile. That's really cool. And we were also talking about the problems with mobile payments in Lightning, sort of an app having to be on, to
Right.
receive a payment, which is a big issue at the moment, and then just trying to shove a Lightning node into a mobile application is certainly quite a challenge. But that's why, all the time, it's like, sorry, I'm just gonna go off on this tangent, but it's like, I love that, I've spent so much time being obsessed with Lightning, and it's only been in the past year that when people come up to me and they ask me, hey, Hannah, can you do X, Y, and Z on Lightning? I don't have to tell them, theoretically, yes. I can tell them, yes, you can, and here's the library you should use to do that. And so
Right.
that's been a really amazing change in the past year, but there's still this big issue with mobile payments that I don't know if any want to dive into that a little bit, but essentially I think one of the problems there is just getting an app to, because you have to be online to
Right.
have payments. And one of the issues there is just how do you get that app to be online to receive payments? And how do you solve that problem? And then shoving a node into a mobile application is another problem.
Yeah.
Yeah, I think we do see a lot of experimentation going on, especially now with regards to how do we want to integrate Lightning into mobile apps, into web apps, into whatever. And the experimentation we're seeing right now is going in the direction of, do we really want to shove a full node into a mobile app, potentially segmenting your funds across a multitude of apps, basically locking in the users into an individual app, so making it hard to experiment. Or do we want to have a more centralized node that is still operated and run by you, and where we just remote into it? And I think those are the trade-offs we're currently seeing explored, and we will see how these work out in the future.
Yeah, and we also see, we were talking about the online requirements. I mean, obviously, if I guess I can say this, Cash App's, almost all of their payment failures are just the app wasn't open. It was being sent to a mobile client, the app wasn't open, and they didn't get the payment because the app wasn't open. So having better logic there, and then enabling more, we've kind of seen this first generation of mobile wallets that all kind of have this simple, we took a Lightning node, or at least a payment channel, and we put it in an app, and we shipped it, and it works pretty well, and we have this LSP, and we route payments through it, and whatever. But, we haven't gone down the route of okay, well, what if we have a more server-assisted Lightning node, like Greenlight, and some of the other things Core Lightning is working on, and do we have better protocols for papering over this on-chain requirement, right? So I had that proposal, 6 months ago, and we're still long ways from implementing it, to use Onion messages as a base for doing payments, such that you can kind of hide the fact that the nodes have to be online synchronously to receive the payment, and you can actually do offline kind of payments, but it goes out and it sits pending, and then you can actually receive it without it sitting pending across an entire route across the Lightning network, and holding that capacity for potentially hours or days until the user opens their phone. So there's still, we finally have Lightning on phones, but we still have a lot to go to actually fix a lot of these UX issues that we've run into.
So I say that Lightning is now usable, in production, in real services, but just barely.
Yeah, it's definitely not smooth, and
Yeah.
There is a lot of infrastructure that we are working on, and I'm speaking for all implementations here, of course, not just Core Lightning. That where we are learning from the experience of operating Lightning nodes, of basically providing users with the ability to make more of their Lightning nodes. And these experiences will flow back into the spec process as well, and inform where the directions are going to go in the future.
And that you know, it is going to continue to be interesting, you know, as the amount of resources required to kind of maintain a Lightning node will only continue to grow as we have multiple different, completely divergent use cases for Lightning. We have, you know, whether it's people trying to run it in enterprise and who want, you know, features that might help them, people trying to run it on mobile, and then you want to add like onion messages and like onion message mailboxes so that you can do, you know, be offline all the time. All of a sudden you have all of these new features coming in that all the Lightning implementations, or at least kind of mostly need to support, or at least look at it and add chunks of it so that things can be interoperable. Just the amount of resources required to maintain a Lightning node is only going to continue to increase. It's already whatever, I think all the major implementations have at least 3 or 4 engineers full-time on it, and that presumably will only continue to grow.
Absolutely. So there is definitely a scaling up of the engineering side of things. But I do think that by us, basically, as Lightning implementations, concentrating on a common kernel that sort of builds the basis for all of the applications that we build on top. And I've been often asked what sort of is the coolest thing you can imagine doing with Lightning, and I usually say that I'm not the right one to ask. I'm the kernel guy. I'm not the cool fancy UI guy. So. But I think that keeping that kernel small will help us basically provide a basis for whatever comes next, and whatever maybe these guys will build here. So
Yeah.
So let's talk a little bit about, we talked a little bit about mobile. Let's talk about kind of LSPs. Obviously, we just had an LSP panel, but what features in the Lightning protocol might be needed for looking towards LSPs, and what the future of development that we have to do on a lower level might be needed for those services over the next few years?
I think very much of the groundwork is already started with the liquidity ads, which is a way for you to signal the availability of funds and the readiness of allocating those funds to a channel that somebody would like to open. And I think that is sort of the direction that I would like to see things going forward, where we have an open marketplace where everybody can participate, where there is no mediator, where we can just exchange our interest in opening or closing channels, and what the state of costs are for that.
I mean, I guess that divides LSPs a little bit even further, right? From service providers who might be providing service to hobbyist nodes or plebnet nodes or always online nodes, versus service providers who might be providing services to mobile, where some people might expect a user experience where your client accepts a zero-conf thing, right? Where suddenly you need to actually know who your counterparty is. You can't just go to a liquidity ad and select whoever. You do actually have to have some counterparty you have some amount of trust in.
But I mean, that's very much part of the signaling, right? Zero-conf channels are basically just a feature that you can signal. Having an identity attached to a liquidity ad is something that you can use to basically make a decision of, hey, is this provider well connected in the network? Do I trust him to be a good counterparty for my channel? And that is basically just additional information that we have to convey to whoever might take you up on the offer. So I don't think that different protocols here are the solution.
Yeah, so I think it is ultimately up to the people building the user experiences and building the apps what kind of UX they want there. Obviously, exposing different possible trust relationships to users tends to be a pretty poor user experience. Hey, you can pick between these nodes, and here's some information about whether you should trust them. PGP Web of Trust kind of failed for a reason. PGP is great, but the Web of Trust part never went anywhere.
Well, the average user, at least I think going forward in the future, right, the average user doesn't, want to know anything
Right.
about what's going on underneath. So it's important to abstract that away for people as the Lightning Network continues to grow in use. But also with the different ways to do liquidity, again, there's different use cases and different users are going to have different, things they care about in gathering liquidity, and why do you need the liquidity? Is this a business that's accepting incoming payments? Is it a routing node? Like, what's the use case? So it's just, things are getting just bigger and bigger. So it's,
Right.
Now we get little pockets and different use cases here and there.
Yeah, and I mean, I think in the medium term and definitely in the long term, one thing I'm really looking forward to the most is a proliferation of more different Lightning apps and different Lightning user experiences. And I think, certainly that's kind of our pitch, right? I mean, speaking from the LDK end, it's kind of our pitch of like, look, we're gonna like do all the hard parts for you, and then you focus on how do you want to build a user experience around Lightning? How do you want to, do you want to have zero conf with which nodes, and do you want to use liquidity ads, and do you want to use this or that and whatever? And so, maybe I'm a little biased, but like I'm looking forward to a world where we have like, some apps and some desktop clients or browser extensions or mobile clients or whatever that use Greenlight, and some of them that let you choose which node to connect to and expose this whole like marketplace of liquidity ads, and some that like abstract a lot of that away, and then some that like just always connect to your predetermined LSP or whatever.
Right.
And kind of this Cambrian explosion, I hope, is coming eventually, where we can have a lot of different options and we can kind of see what succeeds in the marketplace while all still having, this common base of, one of these Lightning implementations that's robust and tested and implements a lot of these features so that users can pick and choose kind of which ones they want.
Yeah.
Kind of developers can pick and choose which ones they want.
And the more tools that are out there, the better to fit different use cases and all of this stuff. And it's, I also foresee sort of this explosion where I just imagine, 5-10 years from now, we'll be using Lightning, on the back end of quite a lot of different services, whether it's, buying things online, streaming things, authenticating for services, et cetera. So.
Yeah, definitely. So I definitely do share your sentiment that we sort of will have a common core that we can pick and choose from. With Greenlight, we chose to take a bit of a different cut where you guys are doing API level composition, basically. The thing that we want to do is basically provide a core node, hence the name, and allow users to basically then connect to it and experiment with different use cases. So we are going back to basically this topic of specialization, where we as the Lightning developers are sort of in charge of operating a Lightning node, the stuff that we do best, and freeing developers from actually having to even learn all of the intricacies of building both a beautiful UI and UX and managing a Lightning node that has to be bundled with your app. So, and hopefully by basically removing this need to bundle a Lightning node with your app, you're also freeing the user to basically experiment and jump from one front-end application to another one. And whereas if you bundle the node with the app itself, trying out a new app means setting up a full new node. So,
yeah, I mean that's always that kind of highlights that debate that's been around forever in the Lightning world of like, do you have, where do you put the node, right? Do you have kind of I would say the earliest designs and the earliest focus was kind of everyone would host their own node at home on a Raspberry Pi, and everyone would give kind of partial remote control access to that node to every app or whatever via, there's L&D has the macaroon system, and Core Lightning has some similar stuff. Now you can do it over Onion messages too. And you have kind of that world, and then you have this kind of movement towards, well, people actually seem to really like this UX of having a node, or at least having payment channels locally in Moon or Breeze or Phoenix, or maybe there's a few others. And then kind of maybe moving back, like kind of the Core Lightning, the Greenlight design is a little bit in between, right? It's like hosted, but some of the signing is local, so there's less trust in the server. Yeah. Or, you keep it all hosted locally and do it. So I think, as much as there's value in there being a standard and everyone doing the same thing. I think we're just gonna see different experiments. We're gonna see different things. You know, we're gonna see people use Greenlight, and it's gonna be great, and then we're gonna see people who continue to have the channels on the phone, and that's gonna be great for those. And so, you know, we'll.
And we have by no means seen all of the possible combinations, right?
No.
A Lightning node is very complex. It has very, very many components. And you can basically distribute these components however you want.
Right.
With Greenlight, we chose to have the node itself on a hosted system and the signer and the front end on a different device. Maybe some other combination makes more sense.
Yep.
And we're just starting to see how these different deployment strategies can work out. And I'm very much looking forward to seeing how all of this works out.
Yeah. So we spent a little time talking about mobile and then a little bit of time talking about LSPs and getting into this kind of mobile and server-assisted model. Let's switch gears and talk a little bit about like what future designs and what future things have to come for the kind of enthusiasts, the plebnet nodes, this world. You know, what do we need to add to make that an even better experience, and where does that world go in the next year or three?
Yeah, plebnet is awesome, especially I think because they're just enthusiasts that like test things out for us, everyone, you know? Like they're just trying all the things and then they report back, you know, I go in the Telegram groups, you know, and see what people are having trouble with, and it's fabulous, you know, to have this group of enthusiasts that test things out. I think there's a lot of tools, you know, for those enthusiasts, you know, things like Umbrel and, you know, MyNode and all those sorts of things. And I think a lot of them want to, you know, they get to sort of build with Lightning, right? And so when you make things that are really reliable, that they can just reliably use this to run their node or to manage their node and have these tools for liquidity, and then they get to experiment with building things on top of that. And that's really, really valuable, I think, to have that constant experimentation and testing in the space.
Yeah, I think there is a point to be made that we definitely need more tooling to surface some of the information about your node as well, to really have an objective measure on what works and what doesn't. For the longest time, we have heard that rebalancings work, rebalancings don't work. How much do you spend on rebalancing? Should we make rebalancings free? How much privacy do we leak with that? Do we even care about leaking some privacy if it's not our own payments? Or do we use rebalancings to provide cover traffic for really private transfers? So all of these kinds of details that we want to surface to the user to help them make an informed decision about whether something is for them or not is something that we definitely need to work on and make available to users in the future to help them make their own experiments, basically.
Cool, yeah, I don't think I have very much to add here because this is the one market that LDK just, you know, I think LND, Core Lightning work great for this market, so we don't really focus on it.
Focus on your market.
Yeah. So let's talk, we don't have a ton of time left, but let's talk really briefly about enterprise, and then we'll see if we can talk a little bit about spec in the future too. So what are we, you know, we have a little bit of experience on the Cash App side, but you know, what do we need for enterprises? You know, as we just saw Kraken launch, Cash App only launched whatever a few months ago. As these enterprises, big enterprises, start really coming online in a big way, you know, what do we need for the next year for them?
This is, sorry, I'll jump in quickly with that. But I love this one because this has been the past year of my life. I've seen a lot of this where people are asking me like, okay, you get businesses that, you know, need a really reliable service. Like, okay, we want to use Lightning, but we need something really reliable, and you know, we are expecting this volume or that, and we need it to be scalable. And then just like, you know, the amount of times I've had to explain to why you can't use Amazon Web Services horizontal scaling on like a Lightning node, you know, like these sorts of things. Or you just, I think scaling that infrastructure for some of these use cases is going to be something that'll be important in the next year or two as, you know, bigger businesses take this on. And then just, you know, reliability. You know, if you're tinkering with something and it works 90% of the time, you know, that's awesome. If you're a business and it only works 90% of the time, that's a big problem. So right. I think, you know, reliability and scalability are big things for businesses that are trying to take on Lightning.
Yeah, absolutely. I mean, one of the prototypes we had internally for a long time is basically a system that is truly highly available for Lightning nodes. And Val recently published a system that very much looks like it, where you have a set of boundary nodes and a virtual node behind it. And that is definitely something that we are looking into, because this reliability and availability is paramount for big businesses. Imagine that if Amazon was unreachable 1% of the time.
Right.
All the money they would lose by just not being able to process payments.
Or 100% of a time, they would still have a huge problem.
And this kind of innovation is something that we definitely need to look into. And we've come a long way. We very early on had failover. Eclair had an implementation of failover that could take 30 seconds to recover, if I'm not mistaken, which is good. I mean, 30 seconds, that's quite good. We can now basically reduce that to a couple of seconds failover, and with high availability setups, we can ensure that no single payment gets lost. Because if any particular node is offline at the time, the sender will basically retry through a different route. And as long as any of these is online, then you can still process payments. And that also gives you operational flexibility, because it means that you can basically just restart a node or upgrade a node and do operational management of the node while still being overall available.
Yeah, that's something that we didn't kind of appreciate going into LDK. We kind of built this thinking about kind of the mobile world and thinking about like people who want to integrate, especially integrate Lightning into existing on-chain wallets. You know, you want to hook it into your existing chain sync and your existing key store and blah, blah, blah. And that's kind of where we came at it. And then, you know, Cash App came to us. We didn't pitch them really. We explained what LDK was, and they came to us and they said, hey, we want to use this. We have a ton of, you know, Cash App's a little unique. A lot of Bitcoin exchanges are more kind of standard infrastructure, and they're set up to run a lot of daemons and interact via RPC. Cash App's not. They're a big company with, you know, separate services for everything already in place that they already use for all of their existing web and whatever services. And so they came to us and they said, you know, we want to use LDK with this. We think it makes sense. And so they ended up building a lot of that stuff using their existing platform, right? So they already had high availability stuff and failover and all that kind of stuff. So they built a Lightning node custom with LDK doing kind of all the Lightning specific stuff into their infrastructure and as a core part of their infrastructure instead of kind of having a daemon they talk to. And so then we have like the high availability stuff that we've shipped, that they've looked at testing. Turns out once you start adding too many route hints in the QR codes just blow up. And so we need Bolt 12. We need the onion messages so that we can request an invoice, or because it doesn't really, you get too big an invoice for a QR code, or LN URL. I guess both work in that kind of server assisted setup. Yeah, so that's something that we didn't anticipate, but turns out LDK has worked fairly well for them, or at least they're pretty happy with it. So.
Awesome.
I don't know how to read this clock. It went to 0 and now it says
Looks
1 minute,
like,
but
yeah. It's going up.
yeah, it's not 11:30 yet, so I think we can keep going for a minute.
Okay.
Let's take another minute and talk about the future of kind of the spec process, the bolts process. You know, we talked a little bit about kind of having a common core and these things that all the Lightning nodes implement, and then having users kind of experiment using those different kind of building blocks that exist within Lightning. How does that fit into the future of how kind of the bolts evolve? And then there's now this new blip process to standardize some of these extensions. How do we see that process evolving over the next few years?
Well, I think we have to, see how it goes, right? We just started using, blips and all that. And I think that gets more and more important as we get more and more activity, and more and more innovation on Lightning. Trying to have a method and a process gets be very important.
Right. Yeah, I mean, we've already seen issue, things getting exposed to users where it's like, well, you want to receive a payment, okay. Now you have to pick, and you have to negotiate with the sender. Do you want to receive on-chain? Do you want to receive Lightning? And now there's, some apps have added, you can pick LN URL, and then you can pick Bolt 12, and like the user has to know these things, and they have to select the one that the sender can send, and like, so there's a certain value to standardization, but then kind of how do we balance that with experimentation and letting people run wild, and we don't know what the answer should be, so how do we balance having a standard that people can rely on with enabling people to experiment and try new things so that we can find a solution that works better in the market than.
So it's always been sort of this process of expansion first during an experimental phase, and then contraction as we learn what works best and what doesn't, and then followed by a new expansion phase. And that's been true from the very get-go for the Lightning specification. I remember when we first met in Milan 2016, we all had different implementations. We all were experimenting on different things. And we basically sat down and hammered out all of the different trade-offs and came to what now is the Bolt process and the set of documents that we have for the Bolt process. And so I'm pretty happy with the way it works. So basically giving everybody the ability to experiment.
You're
and
the
then
only
learn
one
from
who's ever expressed happiness about the way it works. I've heard people think it works poorly for very different and divergent and opposite reasons, but you're the first person I've ever say, oh, this works great.
Oh, I definitely have my pet peeves too, but overall the process works.
Well, I mean, we're building and things are getting built, so it can't be that bad, right?
Yeah.
But I'm curious, you're talking about this expansion and then consolidation. Where do you think we are right now in that?
Probably just about to start the next expansion.
Okay.
So with all the excitement going on, with all of the different use cases that are being presented, with all of the different ways to achieve the same thing, we are now sort of seeing what this will eventually look like. And from these learnings, we can then go back to the table and basically say, okay, this is the way we are going to do it because of these trade-offs that we've learned while experimenting with it.
And what, so I mean, obviously the big debate is the invoice format and the payment formats and payment protocols being a key example of that. Are there other ones that you're thinking of too here?
Yeah, I mean, part of that discussion is the use of whether we want to use the Lightning Network itself to do negotiation of payments. So the whole onion messages process over the LN URL stack of protocols is definitely something to be looked at here. We are looking at replacing the gossip protocol. We were just talking about this before, that we had this gossip protocol that grew organically for the last couple of years and has shown its age by now, with several different implementations sort of interpreting it slightly differently as well. And so it's time for us now to basically go and try to find a new protocol that sort of encompasses all of the good and leaves all of the bad behind. So inter-message dependencies should be dropped.
So you'd say we're kind of at a different place in some of these different protocols is like we're...
Yeah, absolutely, yeah. So it's definitely different lanes that expand and contract in different times, yeah.
Awesome. So I think we're getting waved off. I still don't know how to read this timer, but so yeah, thank you guys.
All right.
Thank you.
Thank you.
Greetings, everyone. Welcome to the Roll Your Own Crypto panel, where we have a bunch of cryptographers or people that work on signature libraries, and they're kind of unsung heroes when things go right. And if things go wrong, they end up like Sony, completely pwned. So I'd like to first get started in what is a signature, how does it work, are we using DocuSign here in Bitcoin Core, what's going on? How do signatures work, Jonas? What are the functions, what's needed?
Mm-hmm. Okay, so what is a signature? A signature is something that in Bitcoin authorizes the spend of a coin, such that the person who received the Bitcoin can spend the coin and no one else. And this idea that no one else can spend the coin, we call that unforgeability. So we say the signature scheme is not forgeable, and that means no one except the person with a secret key belonging to a public key can create a signature over a certain message. And in the case of Bitcoin, the message is usually some variant of a transaction hash.
Got it. So how has that maybe changed? You know, we recently activated Taproot. There's a bunch of new interesting signature interactivity stuff I'll like to get into eventually. But what's the difference between ECDSA and Schnorr? And can you briefly touch on, anyone here, can you briefly touch on like the discrete log problem?
That might do it. Go, I'll take that. So as part of the new Taproot upgrade to Bitcoin, we have a new signature algorithm called Schnorr. The previous algorithm that was used in Bitcoin was called ECDSA. And so as Jonas just said, right, the point of a signature algorithm, you take the message, which is your transaction, you mix it up somehow with secret data in a way that anyone can verify, and the idea is that you have this unforgeability property. So only the person who has access to the secret data is able to sign the transaction. And if any part of the transaction changes, the signature is no longer valid, right? And the specific way that that's done is by an algorithm called ECDSA, which uses a whole bunch of crazy moon math involving elliptic curves and complicated algorithms and stuff. And in the Taproot upgrade, we have replaced ECDSA for Taproot outputs with Schnorr. And the difference between the two is actually fairly subtle. They both use elliptic curves. They both use a sort of linear-ish equation. They both have a very simple algebraic expression, which if we were doing like a math talk, I could write them both on the board, and you'd almost wonder what the difference was. And the difference ultimately comes down to history, I'd say, which is that back in 1989 or so, when EC Schnorr was first developed by Klaus Schnorr, who is still a professor in Germany, by the way, he developed this signature scheme. He put a number of patents on it. One, that was the number. And he then tried to collect royalties on the signature scheme, and because it wasn't widely used anywhere, it got no use, right? Nobody wants to start using a cryptographic scheme that you have to pay to use, basically. And that's always been true, pretty much for the history of modern cryptography. So nobody used this. So then a few folks at NIST, in particular Neil Koblitz, I think, developed ECDSA, where they took the Schnorr signature algorithm, they rearranged it a little bit, and they made it just different enough that it no longer violated the patents. And so this then became a standard, both because there was a big standards body behind it, and also because it was patent-free. And that was kind of the design, right? It was supposed to have all the efficiency and security and all those good properties of Schnorr, but not be encumbered by this patent. But as it happened, well, in practice, that is true. In practice, it accomplished all of those things. But Schnorr's system, by being kind of designed for cryptographic, with cryptographic goals in mind, is a fair bit more elegant. It has a security proof in a theoretical model, which is much more plausibly related to real life. It also has a bunch of algebraic simplicity, and that's the big thing that I think we'll get into a bit later, that makes it possible to do all sorts of cool advanced tricks like multi-signatures and threshold signatures and adapter signatures and all these different like new signature types. You can build those on top of Schnorr, and it wasn't really practical to build them on top of ECDSA.
So what is the difference between multi-signature and threshold signature?
Yeah, so kind of what was alluded to is one of the things that is much simpler to do now that we're using Schnorr instead of ECDSA is that you can have, so I think most people who use Bitcoin are used to having like a public key, and that's like an address. It's where your funds are stored. And then your private key is like the secret you know that then you can generate a digital signature in order to spend those funds from that address. And now you can kind of have shared ownership of a single pub key. Most Bitcoiners are, well, some Bitcoiners are probably aware that you can have shared ownership using a Bitcoin script. It's usually called Multisig. And that's kind of enabled by just putting multiple public keys on chain. But what these kind of new protocols enable is a way for multiple people to share just one public key that kind of represents all of them. But everyone who isn't involved doesn't need to know that it's multiple people. It just looks like a normal public key. And then multi-signature is when you have, say, like 2 people, and both of them need to kind of work together in order to generate just one signature for their one key. And then threshold, as the name suggests, would be something more like you have 3 people, but only 2 of them are needed in order to generate.
So it's like a subset of the parties involved in making that.
Yeah, so in some sense, threshold is kind of this general thing, and multi-signatures are just the special case where everyone needs to sign, which is kind of confusing because object multisig, like the way that we previously had of doing multisig on Bitcoin, or what's called multisig, is actually a threshold signature. But yes.
So I think it's a different state of mind now to perceive like the change from like a multi-signature to now what's more like an interactive aggregate signature. Can we briefly expand on how it works, the combination process, like what are these rounds I hear of?
So right now in Bitcoin, if you want to create a multi-signature, you use a check multisig opcode, or in the Taproot world, how it's called, check sig add. And the way that you are able to spend a coin is that you need to, so everyone who is involved in that setup needs to agree on a message, which would be some kind of transaction in our case. And then they just sign with their secret key and send the signature to some person that will aggregate the signatures and then broadcast the transaction to the Bitcoin network, for example. Now, if we want to use the tricks that Nadav mentioned, doing a real multi-signature where even though it's multiple people, there is only one public key involved and there's only one signature, the setup becomes a bit more complicated because now we call this signing process interactive because there are now multiple rounds involved, which means that the potential signers first send some data around, then they receive the message, and then they sign, and this way we have like a 2-step process, you could say, in order to create a multi-signature.
So are there some challenges, I guess, like if I had like a key in a safe, or do they need to all be online, like in certain instances? Like how does this like look for like the average person?
Yeah, there are some challenges definitely, which is why when designing these things, we try to remove these challenges as much as possible, but unfortunately they cannot be removed entirely in our universe, in our laws of nature, as far as we know. So just yesterday, we published a Bitcoin improvement proposal draft on the Bitcoin mailing list that contains a standard for how to create these multi-signatures. It's a 2-round variant as kind of the state-of-the-art research that we did. Previously, it was 3 rounds, and it tries to explain all the different footguns. There aren't that many, but you still need to understand, if you want to implement this, I'm not talking about users or anything, I'm talking about implementers of this specification. There are a few things that you need to be absolutely aware of. You need to read certain parts of this Bitcoin improvement proposal. I think if you boil it down, it's just 2 or 3 things. But if you follow them, you will be able to create a Schnorr signature, so a signature for a transaction that spends a Taproot output.
Got it. So what are some attacks? You know, I hear this thing called rogue key attack, or some guy named Wagner. Like, what is?
All right. Yeah. Do you want to take this?
Yeah. I'll take the rogue key one, and then I'm gonna make you talk about Wagner. That's a hard one to explain. So the way that these signature schemes work, both ECDSA and Schnorr, is that you have this what's called a linear equation, where you have some secret data, you have a message digest, you have basically an ephemeral key that we call a nonce. You put them together into a simple equation, you add all the pieces together, and you're off to the races. And when I say add there, I mean like something a little more technical than familiar addition, but still it behaves algebraically in the same way, right? If you add three things together, it doesn't matter what order you put them in, you can rearrange them, all that good stuff. So what a rogue key attack is when you take one of these multi-signature schemes that Nadav and Jonas was talking about, where you combine three keys from three different parties, say, however many you want. Let's say you have three parties, they all combine their keys into one. So the goal is you have one key, one signature, but you have three people behind it, right? And the goal, of course, is that you want the one key to actually represent the three people, right? Like, certainly they should believe that, but also it should be a true belief. So what you can do during setup, if you're participating in this, say that we wanted to do like Vivek and me and Jonas. We're all doing one of these setups. So the idea is that we would each throw a key in the pot, we would add them all together, and then we'd have our combined key. And then later when we're signing, we would each do a signature, we'd add the signatures together, and then we get a single signature. And we actually have to do that in two stages, right? We throw some nonces in the pot, add them up, we throw some signatures in the pot, add them up. Everything's great. The rogue key attack is where what I can do instead is I can wait for both Vivek and Jonas to give me their keys. And then what I do is I make a key, and then I subtract their keys from my key, and then I put that in the pot. And so if you've been following everything, what gets mixed together is my key minus Jonas plus Jonas, minus Vivek plus Vivek, and what's left is just me. And so all three of us contributed something, and we added up something from all three of us, but I kind of ginned things up so that everyone else's contributions would be canceled out. And now, if I want to go move the coins without consent from either of them, I can go ahead and do that, because ultimately the final key is just me. So that's a rogue key attack. And the way to avoid it is to do what's called re-randomization, where when we mix the keys together, we need to rather than directly adding them, we need to first multiply them by a random factor, and you have to choose that random factor in a way that whenever I try to change what my contribution is, it changes the random factors for every other party. So I can't wait for everyone else to do stuff and then contribute my thing. We have to mix. We have to mix contributions from everybody. And so if I try to gin things up, my act of ginning it up will change the randomizers and thereby undermine my gin. So that's the rogue key attack. So that's one thing that we've had to address as we've developed these multi-signature schemes. Wagner.
Okay. First, perhaps just to be clear, these attacks, they don't apply to the BIP that were proposed yesterday. We're talking about this, I think, because these kinds of schemes, they have a history, and these attacks were discovered on the way to the standardization of these schemes. One of these attacks would be a rogue key attack, but there are also other attacks. Perhaps you are aware that given some byte string and a hash function, let's say SHA-256, it's very hard to find a pre-image or an input to that hash function that hashes to a specific output. That is hard. However, what not many people are aware of is that if you have a sum of multiple hashes that should sum into a value, a specific value, then finding the pre-image for that sum of hashes is actually not that hard. And in order to find these inputs to the hash functions, you can use Wagner's algorithm, but there are also more efficient algorithms out that have just been discovered last year. But this attack actually appears quite often in crypto systems that we are interested in the Bitcoin world.
So I'm not sure if this is going to be helpful. This is a very technical thing. But one example of where that would appear is when you're trying to do a multi-signature, what you're combining is a linear combination, of course, of secret data, but also the hashes of the transactions. So if you can find a number of transactions whose hashes all add up to the hash of another target transaction, you can potentially get signatures on a bunch of good transactions where the good ones were chosen such that those signatures could be added up to get a signature on a bad one. And so that is, actually connecting this to a real system gets pretty hairy and technical, but because of this linearity property that I haven't defined, but I'm going to keep coming back to over and over, you can use this very abstract sounding Wagner attack and actually produce forged signatures using it in some some previous iterations of this kind of research.
So now that state-of-art research is out, what are some efficiencies gained? Like, I like to sync my full node and really brag about it. Is it faster now? Like, what's going on?
So it won't change past transactions, obviously. So the kind of current sync time isn't all that affected by Taproot. But new transactions, if people are using Taproot, are going to, Schnorr itself is just faster to verify already on its own by a little bit. But then with kind of the new standardization process, you can also now kind of aggregate a bunch of signatures that you want to verify together in a way that then you can verify them all at once in a way that's faster than verifying each signature individually. And that'll lead to, it will mean that as opposed to the universe in which we didn't implement Schnorr, we're faster than that universe in syncing.
So I can essentially verify maybe one signature for a whole block or one signature for entire 15 multisig, something like that?
Well, all of them do have to be Schnorr signatures. So people who are still using ECDSA, you still have to verify each of those individually. But I believe, and I guess correct me if I'm wrong, that you can kind of just batch in as many of these Schnorr signatures that are using the same standard together and kind of get benefits that grow with the number of signatures that you're verifying at once.
So there are two pieces to that, just to clarify. So one is this notion of batch verification, where if you have a whole pile of signatures in a block, and they're all Schnorr signatures, you can verify that much faster than just verifying each one in a row. And if you've got 3 or 4 of these, you can probably verify it twice as fast, but if you've got 1,000 of them, you could potentially verify it something like 8 or 10 times as fast. It's not a simple curve. I can just give you a multiplier, but it gets better the bigger your batches. The other cool thing, though, that we'll see with Schnorr signatures is this, because we can do this multisig kind of constructions, oftentimes you won't even have so many signatures to verify. And I think that's probably in practice where we're going to see the bulk of the savings is in the signatures that aren't even on the blockchain because they no longer need to be.
Yeah.
I think one of the more immediate applications of this multi-signature technology is opening and closing Lightning channels, because there you are already in the setting where you have a 2 of 2, and the Lightning network already is a very interactive and stateful process, very different to hardware wallet signing in your using your bank vault or whatever. And this would, I think, benefit Lightning quite a bit, because right now you need to write 2 public keys to the chain as well as 2 signatures when you want to close a Lightning channel. And with multi-signature schemes, you can reduce that to 1 public key, 1 signature, which would make it cheaper to use Lightning.
Are there any other cool applications with these? I know Nadav works on DLCs. I know there's also a pre-image or hash reuse along the path. What's possible now?
Yeah, so one really exciting application that is made much easier by Schnorr signatures is a variant that I believe Andrew came up with called Dashjr signatures.
Oh, yes.
And they kind of allow you to, say, bake in some more logic into your signatures than just kind of saying, yes, this person can spend this. You can kind of make it a bit more complicated. So essentially, what DLCs do is we utilize Dashjr signatures in order to make Bitcoin payments that pay different amounts depending on what, say, an oracle says happened in the real world. So say, like, if someone won an election or something like this, then there might have been multiple candidates. People can put money into a Bitcoin address that will pay to a different person depending on who wins that election, or all sorts of variants on this kind of thing. And I believe this also affects Lightning. You can essentially perform Lightning routing in a much better way than previously, or than it currently is done, using these adapter signatures. And one of the main benefits of this is that you don't have to use Bitcoin's native scripting language. You kind of bake it all into the math of the signature itself, and it all kind of just looks like normal signature activity on-chain, but it kind of makes it so that only the people who need to know kind of do the math and do all of the contract logic and everything else. Really, you only use the Bitcoin blockchain for the actual transfer of funds, which is what it's best at.
Yeah. So one thing that we've been dancing around through a lot of this conversation is that there's not just a scalability benefit here, that there's a privacy benefit as well. So one place that the privacy comes from is just from using multisigs directly. That already gives you a privacy benefit if you've got one key that potentially represents multiple people and potentially represents some complicated policy where it could be a threshold or some other arbitrary set of signers. In the Lightning case, things get a lot more interesting because, as you say, with these adapter signature constructions, you're able to start embedding some kind of non-trivial logic into the signatures themselves. And adapter signatures themselves, what they are, one way to think of them is a form of verifiable encryption. And what I mean by that is that I can take a signature, I can encrypt it in some way where I can prove that the data that I'm encrypting satisfies some algebraic property that let me hook it into some other crypto system somewhere or something. So ordinarily, the point of encryption, right, is that you basically completely scramble your data. And if the idea is that the intended recipient can decrypt it and get the data out. But until they do the decryption, if they don't have a decryption key, there's nothing they can, they can't even tell that it is encrypted data, right? It could just be noise. With verifiable encryption, you can, provide some more substance to that. So in particular, when you are using the Lightning Network, the way that your payment channels work is, the way that Lightning works is you're actually chaining multiple payment channels off of each other, and you have these paths through the Lightning Network, and you're routing money through all this. And along a certain path, you have to maintain this kind of fixed identifier. I think it's an invoice ID or something in the UX. But what it is in the current Lightning invocation is it's some hash, just some random hash of some data. And this hash is put into the scripts in all the payment channels, and it has to be the same, and that's how the payment channels are linked. The idea is that when you update one payment channel, it causes a pre-image of that hash to be revealed, and the revelation can then be used in the previous payment channel, which then, and every one before that. With adapter signatures, rather than using script to require that your signature has to come along with revealing this hash pre-image, right, you can use this form of verifiable encryption. You can say by signing, you can say my signature itself is an encryption key, or a decryption key, more importantly, it's both. So by signing this update to this payment channel, I am now revealing a decryption key in the form of the signature, and that decryption key can be used to reveal some secret data, which I can then take and use in the previous payment channel and chain it forward. And even cooler is that you can actually re-randomize that at each step. So now, rather than having a whole path where you have the same random ID in each one that somebody who had a God's eye view of the network could tell that it was all one path, you now have this re-randomization where even the people in the path itself might not know where it starts and where it ends because there's re-randomization happening at the hop after them and the hop before them. So there's a privacy benefit there even within the Lightning Network. So it's
interesting.
Pretty cool.
So we have about 15 minutes left, and I'd definitely like to discuss scriptless scripts, Multisig DN, or perhaps even CISA. And then there was a recent paper put out, and also some libraries from Jesse Posner regarding a threshold scheme called Frost. So let's try to rush through this.
Well, scriptless scripts generally refers to the use of adapter signatures,
Right.
so I think we've covered
Yep.
that one.
I think so. Well, I have one more minute.
Okay, yeah,
Let me-
go for
I'll
it.
be quick, though, I promise. of that on another panel a couple weeks ago, and I gave a 28-minute answer to the question, how long have you been writing software? So, but I'll try not to do it. I'm sorry, I'm doing it now. To finish my spiel about adaptive signatures. So adaptive signatures give you this kind of this verifiable encryption property, which you can use in the Lightning Network just to feed data through there. But what you can also do is encrypt other signatures, for example. So you can do arbitrary forms of atomic swaps and stuff where you have, say, 2 transactions on 2 different blockchains, for example, and you want to swap, right? You're trying to trade some Bitcoin for something worthless, right? And the worthless thing has its own chain, right? That they do, usually. And so you want to do the swaps fairly, right? You don't want one person to give their money away and then the others just take it and then walk away. So the way that you do this is you set things up so that when the first person signs to take their money, that signature then decrypts a signature that gives the other asset away on the other side. So you get this atomicity in that form. Another more general application of this would be something called a zero-knowledge contingent payment, ZKCP, thank you, where what you are encrypting, rather than being another signature or something, is basically some arbitrary piece of data, and you provide this extra object called a zero-knowledge proof. And a zero-knowledge proof is a very general, very powerful cryptographic object, they're very slow to create. They have weird security models. Like there's lots of questionable things about zero-knowledge proofs. But the cool thing here is we don't put them on the blockchain, and we don't need them for long. They're kind of an ephemeral thing here. So what I could do is, supposing, say, that try to come up with a non-contrived example, right? I have some satellite imagery, okay, and I claim that I found some oil deposits, okay, and I'm trying to sell those to Chevron. And I don't want to just give them the satellite images, because then they'll take it and run away. And for some reason, they're really into like high-tech, like bleeding-edge cryptography and want to play games with me, even though that's really not what they do. And so what I can do is I can take this satellite image, I can somehow describe the evidence of oil in a verifiable, computationally verifiable way, and produce a zero-knowledge proof. Well, I'll take the image, I'll encrypt it. I'll produce a zero-knowledge proof that what I encrypted is a satellite image which satisfies these criteria, which Chevron agrees actually indicates evidence of oil. And now we do a zero-knowledge contingent payment, where the two of us jointly create a transaction where in order for them to take my money, I have to sign a transaction, and my signing of that transaction, well, I know it's going to give me the money because that's the transaction that gives me money. My signing will then decrypt the image, which Chevron knows will be what they would expect. And so we can execute a transaction that way, even if the two of us don't really trust each other. And even if nobody should trust either of us, the zero-knowledge proof will step in there. So this general framework of playing games like this with adaptive signatures is what we call scriptless scripts. So.
Got it. So we're going to take a step back, actually. No more music DN. I think we got our ZKP crypto catnip out of the way. Let's take a bit more applicable thing. Like I know you and Tim Ruffing also work on half-ag, music too. What are these advantages and efficiencies potentially gained for things like lightning gossip? Can you touch on this?
From aggregation, you mean? Okay. I think would make first sense to distinguish what we call signature aggregation from multi-signatures or threshold signatures. And for us, the main distinction is that in multi-signatures or threshold signatures, you only have a single message. In the Bitcoin use case, that is dependent on the input that you're spending, or dependent on the coin that you're spending, which means you have some set of people and they have shared ownership over a single coin. Now, when we go to the signature aggregation world, there are multiple signers and each with different messages, right? So this corresponds to a transaction with multiple inputs, and this transaction must have multiple signatures, and each signature will be over a different message because the signature is used to authorize the spend of a different coin. So we call these schemes signature aggregation. what they are doing is they really aggregate signatures, and this doesn't have privacy benefits, in general at least, but it has scalability benefits because a big part of transactions right now are actually signatures. So we could try to aggregate these signatures into a smaller signature. And there we again basically distinguish two different types of schemes, mainly half aggregation and full aggregation. And full aggregation is a bit simpler to explain because that works by, or the output of the full signature aggregation algorithm is a single signature. So in an ideal world, every Bitcoin transaction would have a single signature. Unlike today, where there's a signature for every input, basically. But creating these signatures has similar interactivity properties than multi-signatures. So it's not so easy to do, and how to exactly do that is still an open research problem. For half aggregation, we don't get the benefits of having only a single signature in the end. We basically are only able to aggregate half of the original signatures together, but this process is non-interactive, so anyone can do that. And that would be something that could be added to Bitcoin consensus, perhaps, at some point in the future, but it may have also implications on protocols on top of the Bitcoin network, such as Lightning, because Lightning, at least right now, gossips a lot of signatures around to prove that nodes actually have open channels. And these signatures are just bare single signatures. So what could happen is that instead of each sending a single signature in order to do a single proof that a channel exists, some party, could be anyone, could just aggregate these signatures into a single half aggregated signature then in order to reduce the size of the messages that need to be sent around in the Lightning Network.
Fascinating. Hopefully we'll get that sooner than later. All right, Nadav, what is Frost?
Well, Frost is a specific proposal for threshold signatures on top of Schnorr. I believe it stands for flexible around optimized, what's the S?
Signing signatures.
Something threshold. Oh, Schnorr threshold
Schnorr,
signatures. There we go. Yeah, so essentially it is, so it's a two-round proposal, meaning that, well, I guess there's a pre-computation you can do so that it kind of looks like there's only a single round, where that kind of looks like normal signing, where you just do something once, like everyone generates their part of the signature, and then someone puts it all together. But really, there's also kind of like a setup round. So there's a setup round and then a signing round is maybe a high-level way to think about it. Essentially, what you do is everyone kind of has their own private key, is how you could think of it, or secret share. And then together, they have one private key. It's not as simple as just adding all of those keys in a pot, but you do a little bit more math, and you end up getting a key which then could, in theory, be derived by any, say, 2 of 3 participants, or 3 of 5, or T of n. But then rather than actually doing that, because you don't want people to just know what this private key is, because then they can sign for the group, so what you do instead is you collaboratively, any 2 of 3, or 3 of 5, or whatever threshold you want, of all of the people can get together and collaboratively generate each person generates a partial signature using their own secret share, and then it's all put together. And if you have at least T people, at least 3 of the 5 people, for example, then you generate just one normal-looking Schnorr signature for the one kind of group key. And it's kind of done in a simple enough way that it works well with a lot of other things that you might want to do. I don't know if it works with adapter signatures. I imagine that you would be able to hack that together if you wanted, or similar approaches could.
Adaptive signatures mostly only work with 2 of 2 setups, so
see.
there's not room to do a threshold in
Right.
2 of 2.
Right. Okay, yeah. Well, it kind of is similar in nature to how multi-signatures look, but it's done more generally. And I guess if Jonas wants to talk about the trade-offs between using something like Multisig and Frog.
We can have a bonus round about blind signatures or ring
Or
signatures
that.
if you'd like to.
I think one thing that's also interesting to get across is what are the different stages that these proposals are right now, because people in the audience might be interested to use this eventually. And so what we're mostly talking about right now is only the lowest level that you're really interested in, which is the cryptography part, right? But there are more parts before you can actually use this in your wallet, right? There needs to be standardization first of the crypto scheme. And for multi-signatures, we are, as I said, we published a standard yesterday. For Frost, I would say there it's a bit more early, but there are also standards progressing that will be eventually usable with Taproot and tweaking and whatnot. But then there is also the other layer of how does this integrate with wallets, really, that you can have multiple wallets independently implemented from different vendors that work together and create such a signature. And that is, I think, a really interesting thing in the future, how to exactly do that. That might be more difficult for some schemes than for others, right? For multi-signature, which is a more specific scheme, N of N, that might be a little bit more, a little bit easier to do for wallet implementers than something, for example, like Frost. And you asked about blind signatures?
Blind and ring, whatever you think we can kill a minute 30 with.
Okay.
I say ring. Do ring.
I'd say blind signatures.
Let's do it.
Yes, blind.
Okay, so what blind signatures are, they are basically a client and a server protocol where the server signs some message that came from the client without knowing what this message is. And also such that the signature won't be correlated with the message in the future or even the signature in the future. And how is this used? This can be used, for example, for federated eCash or eCash in general, which is, I think, one of the interesting direction that the Bitcoin community is looking into, where you have much better privacy guarantees than anything you could achieve with blockchains or Bitcoin in particular, but you have other trade-offs. And these blind signature schemes, they don't need to be part of Bitcoin consensus, which means that we can use more exotic schemes that don't have the trade-offs of interactivity that we discussed with multi-signatures or complicated setup like in threshold signatures, but we can have more exotic cryptographic assumptions and then have a scheme that is simpler to implement and harder to mess up, and also that has properties like threshold blind signing, where you have a whole federation that would require a signature on a token or whatever. Yeah, so that's I think the way how you could use blind signatures in Bitcoin.
And this is essentially mini mint or similar applications.
Yep, exactly.
Well, I guess that's pretty much it. I'd like to conclude this panel. Let's get a huge round of applause for Andrew Poelstra, Jonas, and Nadav Cohen.
Thank you so much for joining. And Lisa, thank you for coming in last minute as a co-moderator. I want to start off by, I would assume a lot of people here don't know what covenants are. I myself have never even really studied covenants really deeply. I know about them, obviously, but I want to take this time where we can all learn. You can essentially teach Lisa and I about covenants. This can be an educational panel, so then the audience can learn with us what are covenants. And I want to start with, when I first started doing research, I said, what was the first covenant? And what came up on Google was the first covenant was between God and Abraham, and the way this covenant is satisfied is Jewish men got circumcised.
Confirmed.
So I want to know how does this relate to Bitcoin? Maybe we can start there, work our way from a few thousand years ago, and work our way here to Bitcoin. Just kidding, but like I said, a few minutes on the clock. Let's do very quick introductions, 10 words or less kind of thing, and let's get rolling into the education. So we'll start with Lisa.
I'm Lisa, also niftynei. I work on
We need mic for Lisa?
I'll introduce myself in the meantime while we figure that out. Hi, I'm Jeremy. I like Bitcoin and I like covenants, and I hope Bitcoin can one day have covenants.
Amazing. So my name is Burak. I'm a Bitcoiner and Bitcoin dev. I think I started in Bitcoin like 5 years ago, or more or less. Initially exploring and building around mining, wallets, payments, and I finally ended in this covenants rabbit hole. So it's a really interesting place. Exciting times.
Yeah. Hello, I'm Sanket, and I'm excited about covenants, and like Jeremy, I want to see covenants in Bitcoin.
Cool. And you want to test the mic?
Hello?
Okay.
Hello?
I think there's feedback.
So Nifty, if you want, for now, if you when you have a question, we'll just repeat. And then in the sake of time, maybe we just kind of skip a little bit of the 2,000 years of history of covenants and just kind of jump in it for the sake of time. So where are we at right now? How do we get here? Like, what is a covenant in terms of Bitcoin, Jeremy?
Yeah, so one of the things that I use to explain covenants is that Bitcoin UTXOs, which hopefully we know what those are, that's like a coin that you have, is a little bit like a treasure chest. And when you open it up, usually, you get some coins out, and you can put those into whatever new treasure chest you want. And that treasure chest could have whatever locks you want to have on it. A covenant is like when you open it up, and then instead of gold coins or something, you see it's like Jimi Hendrix's guitar, and it says, please only put this into a guitar case in the future. And you're like, okay, so if I open this up, then you're going to leave a little note maybe that says, yeah, when you open this up, please put it into a guitar case. Maybe after it's been opened 10 times, you say something like, take it to the guitar shop to get tuned. That's a covenant. It's like you open up these treasure chests, and then you find something that maybe has some additional restriction of what you can do with it. And that's maybe a little bit heady, but you could imagine in Bitcoin, we would have something like, hey, open this up and then move it. And then after you've moved it, you have 6 months before some other action can happen. Once you take that action, you have a 2-week grace period, that type of thing. Because we're only thinking about Bitcoin, you can't transact Jimi Hendrix's guitar on the blockchain.
I like that analogy. You have to put a guitar in a guitar case. That's kind of like provisioning it. Did you?
Hello?
Test?
Hello? Can you
There we
guys hear
go.
me? Oh,
Yeah.
great. Oh, sorry. Okay, cool. Should I do a quick? I'm so sorry.
Do a quick
All right,
intro.
Yeah, I'm Lisa, also niftynei. I work on Lightning at Core Lightning at
Cool.
Blockstream.
And I didn't really do an intro for myself, so we'll be asking the questions here, trying to learn with you guys about these covenants. I'm Michael Tidwell, work at Saudi as an infrastructure engineer. And what you missed is Jimi Hendrix guitar case. The analogy here is if I give you this guitar, then you have to put it in a guitar case. I can't say that word today. Is that kind of?
Yeah, like you have a special object, and you've got to preserve something of it's got to be in a guitar case. You have to keep it under some sort of special rule, and rather than just gold coins that you could take out of your treasure chest and put into another treasure chest of your choosing. You've got to keep it in something that has a special format.
So is this? I think most people have heard of NFTs, which are non-fungible tokens, right? So how are you gonna take Bitcoin and make it look like a guitar? Like, you know, like why, you know, the nice thing about Bitcoin is every Bitcoin is a Bitcoin, right? Like you can exchange one Bitcoin with another person. We call that fungible because you know that when you get Bitcoin, it's the same as like any other Bitcoin, and all Bitcoin is like pretty much equal, right? So I'm willing to transact on Bitcoin because I know that I'm gonna get Bitcoin in return, right? Like if you're turning Bitcoin into guitar, like how does Bitcoin become a guitar, one? And like two, like, yeah. Isn't that like, are you making like NFTs then? Like,
yeah, so we're just using the guitar as an example of something that has some additional restriction. An example of Bitcoin that's more like a guitar might be Bitcoin that you intend to give to your spouse when you die. And you might want to have an additional covenant on that says, well, if you claim access to this because you're claiming that I'm dead, maybe there should be some timeout period where I can say I'm not actually dead. And that would be more like, you know, there's some restriction on that.
But why aren't you giving your money, your Bitcoin to your spouse, Jeremy? Like,
I don't have a spouse.
I see.
Otherwise, my spouse would have all my Bitcoin.
So let me ask kind of like a higher level question. Do covenants currently exist in Bitcoin?
I can go with this, and the answer is we don't know. Like Bitcoin script is like complicated. We have this opcode called opcheck_sig, which allows, which is most fundamental opcode to Bitcoin, where you check a signature that the transaction has valid signature with respect to the given public key. And by its nature, this opcode relies on some data from the transaction itself. And in some way, the data from the transaction is available to the script. And given all the different opcodes we have today, there may be covenants may be possible. We just don't know how to do them yet. Good way might be to cleanly add support for covenants, but do we have covenants today or no? I don't know. Like for example, Andrew Poelstra has a good blog post on if you just had opcat, which looks like a simple opcode where you just add to, like concatenate two elements on stack. And with that, you can have covenants. Like, yeah, just the nature of Bitcoin script itself is like, we can't answer this question.
So I would actually take the side of saying that and this is maybe an important second topic, is that we do have covenants that like a lock time, check lock time verify or check sequence verify, in my opinion, are a covenant because it's saying here's a coin that you can only spend after a certain amount of time. So it's something beyond just who the owner is about how the coin can be spent. I would consider that a covenant. The thing that we're talking about when we say we're not sure, and we usually shorthand covenants for this, is covenants that really restrict where you can spend the coin to, not just the how. And that, yeah, we don't know. As far as I can tell, we don't have them at this point, but maybe somebody would find something where we do.
Right, but by the definition that we're kind of talking about, it seems covenants, by definition, have some kind of condition on how they're spent or how Bitcoin is spent. Is that okay as a layman term definition?
I think you just want to add more so than something like a simple list of signatures.
Okay.
Because that's kind of like, that's just who owns it.
Because that's every Bitcoin.
And you can say that's a covenant, but that's just like who owns it. It is like an additional restriction.
Okay. And Burak, did you want to add anything?
Oh, I think we don't have NFTs on Bitcoin yet, but UTXOs are NFTs when you think about it. And I think, yeah, Jeremy's guitar analogy is, you know, the UTXO stuff. Yeah, you can constrain UTXOs in how they can spend, right? And yeah, and you can do covenants with some additional opcodes like check, schnorr tricks, but the entry barrier of doing that is extremely high, right? But you know, covenants in short is pre-committing to a transaction in advance of creating an address, right? In short, and I think from what I observe from the community, I think we'll get there at some point, right? But the question is really in what capacity. We are seeing many competing ideas and proposals, and more to come, right? But you know, each proposal have a different level of complexity and flexibility. You know, each have their own trade-offs. But it will be interesting to see which ones pave the way for Bitcoin.
And can we talk about some of the proposals for covenants? I know in 2013 or some Greg Maxwell made a post back in the day. There's been, I don't know if that was quite a proposal, more of just an idea, but what proposals currently exist today that are covenant proposals, I guess you could say?
Is that for me? All right.
Anyone that wants to answer it.
I have a favorite one, which I'll tell you about last. But there are a lot of, I think one thing that's important to understand when we say the word proposal, it means different things. So there is a BIP, which is a Bitcoin improvement proposal. And that is a proposal that is like very structured. And they can be at different levels of readiness. And so when you talk about a proposal, there's also a sort of idea, right, of, hey, what if we did this? So there are a lot right now of what if we did thises. And as far as I'm aware, there's only like one or maybe two things that are kind of more on the side of, like, here is a concrete thing that we could do. So in the scope of things that are like, here are ideas, people are talking about what if we added like a language that itself in scripting was maybe, you know, like a Lisp or some sort of like actual programming language to Bitcoin, then we could compute any arbitrary covenant we ever could want. We could say all the possible covenants we could express. That's something people are thinking about, but nobody has like a code sample that you could run and try with. And then there are some maybe like application-specific covenants that are like, rather than this big general purpose thing, like, what if we just had a covenant that let us manipulate a tap script and manipulate the tree that we've seen? There's one called tap leaf update verify that people are getting maybe a little excited about. There are some other ones people have talked about as well, but all those things are kind of in the space of, hey, I've got a cool idea, don't know exactly what it would look like. The two that have some potential for covenants that are in the more concrete phase, where it's something maybe that could be considered for merging and activation at some point in the next like year or two, would be check template verify, which is the proposal that I work on, and any prev out, which is one that is in the Lightning community primarily, but has applications for covenants that are not, like, if you said we can remove covenants from any prev out, the Lightning community probably would do it because they're focused on it for different applications, just sort of a side effect. And so for check template verify, I like covenants, and I think that generally covenants, you know, are something we should explore. But a lot of people in the community, like Greg Maxwell in this original post where he shared it, had a lot of reservations around, are covenants good? Are they bad? Can they have bad things happen? And so when I designed CTV in 2019, I said, can I make a covenant that is the simplest possible thing that basically, if you don't want CTV, then you will not want any covenant system ever, at least in terms of functionality. Maybe you'll disagree from a product management point of view. But if you say CTV is bad, here's why CTV is bad, then we can rule out all covenants forever. But if you're like, CTV is good, like, well, we'll get something done maybe, and then we can talk about the more sophisticated things.
So it's like CTV is like the smallest unit of covenant where it's like, hey, if we can prove that this is bad, then we know covenants are bad. But if this is good, there might be more opportunity.
Yeah,
like,
I think that's how I would describe it. And just in terms of, you know, like the doneness of the proposal, it is in a form where, like, you could merge, activate, and release it, you know, starting now if you wanted to. So it's more in the category of product management decision rather than there's still an engineering question around how would we actually implement this thing.
I think those are all really interesting things about how we like kind of move Bitcoin forward, et cetera. And you know, this covenant proposal, covenants will have to go through that process at some point. I think like as a person who works on Bitcoin stuff, though, I'm gonna be honest, like I'm not totally. I think covenants are cool. Technically, there's a lot of really cool stuff I think that they enable, but I'm not totally sold that we need to make Bitcoin more complicated and add more ways of making it harder to spend Bitcoin. So maybe I think there's two things here is like, you know, there's a bunch of different proposals about how to do covenants. I think maybe we could talk about like how accessible are these, like how, like in terms of like, you know, like are these things that like everyday Bitcoiners are we going to make it easier for is this going to make it easier for them to like secure their Bitcoin? Is it like, I don't know, yeah, like if like why what about covenants is like,
so let's start with like the major like beneficial use cases maybe where y'all can talk about like one that you're interested in, for instance, is security. Like how does this benefit us?
I think I have some favorite proposals like CTV. I think it enables many use cases. I think the primary one, my favorite one, is channel factories, so that you can open thousands of channels in a single UTXO, and you don't necessarily need to close them because they can source you inbound liquidity later. But also, also tap lift update verify also can potentially bring channel factories as well, so that you can open. It's a shared UTXO model. You can open like thousands of channels as well. But I think when you want to close them, you only close the channel you are interested in, as opposed to CTV when you have to declare all channels first to close them. But anyway, I think one other interesting use case of CTV is vaults. You can as well as channel factories again. But I think overall, when you look at covenants, everyone can benefit from it. Like if you're a Lightning enthusiast, you can benefit because you can bring L2 to channel factories and non-interactive channel setups. If you're a self-custody guy, great, it's for you. It's great for you. I mean, you could bring vaults to Bitcoin and I don't know, some sort of advanced self-custody. If you're a Bitcoin scaling nerd, it's good for you. Maybe it could bring later on some point snarks to Bitcoin. Maybe trust those SPV sidechains. Who knows?
Yeah. So, first responding to Lisa's question, where like why are we adding this complicated stuff? So like definitely it should be defined by what use case you're adding. So in this case, we have some scaling benefits by proposals like coin pools, where one UTXO would be. This is not specific to check template verify or any single proposal, but with some covenants, suppose we could have coin pools where you have one UTXO which is controlled by multiple parties. Like if you imagine Bitcoin scaling to the world, we need some sort of coin pool proposal. Then secondly, vaults. And I'd like to distinguish between CTV vaults and more powerful vaults. And I think at least for me, covenants are kind of like the end game. We need to have some sort of self-custody solution more powerful than what we have today. I would not be comfortable storing huge amount of Bitcoins in what we have in the recommended security setups today. For example, in covenants which were suggested in the original paper by our favorite professor, we had a design where even if you lose your cold keys, you could still get in a race with the attacker and try to burn your funds. So that offers a new level of security which we currently don't have with any form of covenants, or even with CTV, we don't get that form of security. And so there are these new use cases which covenants enable that we don't get if we don't have them. Secondly, it is opt-in. That's the most fundamental part. If people are using covenants, and if you're not using covenants, then it doesn't affect you. New proposals, sure, they do affect you. You should care about a few things when new proposals are suggested, is your full node doing more work than what it is getting, are there any denial of service concerns about it? Maybe, you could do weird, funky stuffs with covenants, but when we suggest proposals, we should make sure that, those concerns are addressed properly. So,
before, just to kind of rephrase what we're talking about, I mean, we've talked about channel factory, so opening up thousands of channels in one transaction. Right now, if you open up a channel on Lightning, that's one transaction, right? So we're talking about general scale. We're talking about vaults, which enable security. You even said right now you don't feel comfortable with what's available. So you would actually, you feel uncomfortable being a Bitcoiner right now with the current technology is what you're saying. And you would feel more comfortable with vaults and covenants that enable those things. So those are some of the. Did you want to add anything?
Well, I was just going to add maybe 2 quick points.
Sure.
One is that I hope in the next couple of years we're able to add tens or hundreds of millions of more Bitcoiners. And even if we're coming up with better things in the long run, I would really like if the story that we have for every one of those users coming on is that we get them started with something that's more secure or more scalable. And I think that that's why I, at least, people critique that I say maybe urgency, but I try to do these things with urgency because for every user coming in, I want to give them the best that we know how to do. And the second point that I would make, which is should we be adding more complexity, is sorry, the complexity is already here and people are doing these things, but either in more centralized, trusted, trusted means not trustworthy, maybe a linguistic quirk, but using a trusted party ways, and these things I think are just concretely worse. So if the market's already adopting solutions like that, we should do something that reduces the amount of trusted parties required for things people are already doing.
So now, are you convinced?
I mean, it sounds like we're making a trade-off here between complexity and some amount of like security or like functionality, right? So, yeah, I don't know. I don't know if I am totally convinced.
It is opt-in though, right?
Well, actually, just on the specific word complexity, the protocol, for example, for opening up Lightning channels with covenants is simpler than the protocol for opening Lightning channels without covenants. And so that's something where actually by having a slightly better technology, we can reduce complexity in other parts of the stack. So the overall complexity goes down.
So I have a question for you, Lisa. Is there, and maybe there's another way, but how can you open up and scale Lightning in terms of opening up a ton of channels without covenants? Is there another way?
Right now, every channel is represented by a UTXO. Which I would say that's kind of simple in terms of like when people are in a channel, they understand what they own. It's a shared UTXO, right? So maybe the complexity in opening it is a little hard, but the simplicity of what you own when you open a channel is very straightforward, I would say. So like it's an it's an on-chain thing. You can go look it up on a block explorer. You can see where your channel funds are. Yeah. So like. The limit on that then is that every channel open must be represented by an on-chain output.
Is this like dichotomy, or is this like trade-off here, complexity versus scale? Is that kind of how we would see this, or is that a bad simplification?
So one of the things that I try to emphasize is that when you create a channel, let's say that there are like the maximum is something around like 20,000 people trying to open channels in a given block. Like it's probably a little bit less than that, probably more like 5,000 people trying to open up channels in a single block.
Probably like 4,000 or 5,000.
Yeah, that would be like the maximum, right? And then what's interesting is as soon as you have 5,001 people, you will now over a long time have an infinite list of people trying to open channels. And so you end up in a world where everybody who wants a channel is now not going to have a channel. They're going to have to go to like a trusted service that says, yeah, we're not going to rug you on opening this channel. And then that you can't look up in a block explorer either, and then you might say, oh, well, we can only support this many users. So I would rather have a pathway to supporting a larger number of users where they have to do something slightly different than say we're bounded by this constraint of Bitcoin and we can only support top tier users at this amount. And I think we can still support people who are willing to pay for that 5,000 per block space if they want it, but now we're able to grow the pie and support more users overall.
So the humanitarian Jerem Rubin wants even poor people to use Bitcoin.
I'm for the plebs, man.
Okay, understood.
Yeah, so again, like,
thank you.
That's it, right? This is opt-in, so you can still do what you are doing today. Like, and as long as what other people are doing with their UTXOs, you should only be concerned that it does not increase your verification costs, which can be evaluated per proposal.
It actually should decrease your costs, because like if there's 5,000 people, presumably like half of them are probably okay with using the more scalable thing that it doesn't decrease block space demand, but it like lets you have more priority for if you really do need that space for an immediate open.
Yeah, but I guess like so it sounds like if we're adding all this, but then you're changing the model then, so it's not one UTXO per channel, right? It's something else. So now you need like more tooling and more like ways to see like the visibility, et cetera, right? So I think like adding covenants is more like you need more. There's going to be more. We're going to need more infrastructure for these things, right?
Yep.
Is kind of what I think.
We need more tooling for these kind of use cases.
And I think that this is sort of the, and maybe this is like the magic of CTV as a covenant solution, is that the thing that CTV expresses is purely just a list of transactions that would get played in the future. And so there's no sort of really complicated infrastructural need. For something like a Lightning node, all you have to do is say, okay, we're aware of these things that are pending transactions, and we're able to see that they're CTV so we can prove that they would happen in the future. And then you would just count those as fully confirmed, rather than just sitting in the mempool unconfirmed. And that's the only difference. For the more interpretive things, like even things based in like any prev out or like those types of channel factories, well then you've got to like be like constantly like rebinding and scanning and things like that. And those have a lot more infrastructure requirements. But in terms of like an immediate migration path, we can like probably get something working pretty easily and then do the more complicated stuff in like the span of like decades or whatever.
I kind of want, oh sorry, go for it, sounds good.
Yeah, so like in terms of like I know we are discussing CTV a lot, but I'd just like to highlight one of the things where I'm sort of trying to address to the crowd who think that governance, or in particular, some form of governance are dangerous. And CTV in one proposal is like motivated by the design to avoid certain set of governance, which we call as, we don't have the time to get into it, but recursive governance or unenumerated governance. I think rather we should, as a community, like regardless we should have CTV or should not have CTV, we should try to address those concerns of people who are against like recursive governance because they enable new use cases. Then CTV, it is independent of the issue of CTV, but I don't want the motivation for CTV to be, oh, look, we are trying to avoid these dangerous things. The motivation can be, look, this is simpler, that's why we should do it, it's fine. But there are a lot of people who are advocating this because they want to avoid something, seemingly the dangers of recursive governance. And if you refer back to the post from Greg Maxwell, you'd see that he does not say that there are dangerous things. He actually, in some way, challenges everyone, like, what dangerous things can you do with governance? So yeah, I can't get into the technical details right now, but that's just
I kind of disagree. We're already over time, and I say we just keep going until we get kicked off, because I think this is kind of
We got rugged on time. So.
Yeah, so I mean, if y'all are cool with it, I mean, if the audience is cool with it, I think this is super important to talk about, because I was actually wanting to bring that up, the recurse, like, let's play devil's advocate just a little bit here and talk about maybe some potential security issues with covenants, maybe are addressed with the idea, with CTV or with other ideas. What could go wrong with covenants? Is there potentially a bounty? What I mean?
So I think one thing that, look, I actually believe in doing this process to get towards as much covenants as we can do. So I'm on board with that. I think I just want to be a friend to the people who are more conservative. And I think a fair thing that they can ask is, okay, it's not enough that you can say there's some argument that these things aren't bad. Please prove to me that it's safe. And until we get to that level of sophistication, I think that a more conservative approach is ultimately what the community wants. And I am trying to cater to the community more than I'm trying to do the thing that I want, even though I might want something more personally. Overall, I just want something that's going to let us do at least half of the cool things.
Okay, so I kind of disagree. I kind of disagree with this over here. Let's, for example, take the example of, this is not a good analogy, but just for argument's sake, let's take the example of Taproot. If we just tried to address a subset of community which said that this is not quantum secure, and we modified Taproot to do something dangerous and try to get everyone in, we would not have this proposal that we have today. Instead, what we work towards is addressing concerns of people look, quantum computers are going to come tomorrow, and even if we have them, we have bigger problems, right? So it's not a fair critique, because that would also make a complicated solution, whereas CTV is simpler. So coming back to the point, I think we should suggesting the community a wrong idea might might backfire in future. Maybe earlier people believed that Bitcoin is free and had businesses built on top of it, and maybe today people think that recursive covenants are not secured, and that's why we are supporting this. I think I agree that CTV is simple, and that is a good enough merit, but we should also address the community that, look, this is not dangerous, and maybe we need more time for it. That's okay.
Yeah. So I think one thing that's kind of interesting about that is that you can agree or disagree, but at any point in getting the community convinced on the more complicated things, there will be a checkpoint where you pass people being comfortable with CTV's functionality.
I agree with that.
And then if that's true, the question becomes, once we've surpassed that threshold, how much time till we get to the point that we actually might want to go to, and then how many users come on board with less secure custody solutions in the meantime between those two things?
Why would people be uncomfortable with this recursive stuff? What's the discomfort that we're talking about here?
So let's.
Good question.
Yeah. So this recursive governance in particular, they allow you to wall garden your coins. Maybe you can get into a covenant that you cannot escape out of, and this this sounds dangerous, right? Why would you put your coins into something which you cannot get out of?
We're not trying to make Bitcoin like Ethereum.
Yeah, or maybe you, one of the concerns is just the US government goes to Coinbase and says, put all your coins in this covenant, and it's a recursive covenant, so whenever you spend those coins, you need the signature of like a CC, and whenever you want to transact, you have to send a copy to them, and now they have everything. Why are we building this technology to help? That's a valid question, right? And that's why people are scared. But the bad news is they can already do that today. They can just do it with what we call multisig.
But I think, well, I was going to say, I think to address the question, I think it's like the idea of the recursiveness, it's like you pretty much have like a deadlock on that contract, which does what? Does that break Bitcoin, or does that just break that transaction? What does that actually do?
Yeah.
You know what I mean?
So I think that recursive is just like a little bit of a stand-in for like hard to analyze. And I think we're okay with any covenant that we know how to analyze to show that it's safe or that it's good or beneficial. And that I think is why, like, for certain purposes, something like CTV is okay, because it's very easy to analyze. So we're saying, okay, the analyzability of this is very basic. So we can say we know all possible state transitions, we're good. For me, the concern with recursiveness is that when you have these more flexible things, like you just might not have properly proved that the covenant is actually correct, and there might be some sort of like, Ethereum has these things with like, recursive reentrant, contracts where you call the thing and then you call into the thing and then the number doesn't get updated properly and then you burn all the money or you steal the money. And those are at least from my perspective, those are the types of issues that our ability to prove and reason about these things, like we would need a lot better tooling and infrastructure to do it safely.
So no loops are like enabled? Is that like an easy layman way of
no loops.
Okay,
you got to
no
know
loops.
the entire.
You know the whole span of the tree of possible states.
And that's a huge trade-off to get that analyzability. There are other things that also might have some similar analyzability but are more flexible. But on all the choices, I just did conservative for this. And I do think the conversation and defining the properties and not just having like one big stand-in of recursive bad, is really important. But it's the analyzability I think is really the thing we need.
Yeah, so we can have analyzability in like particular smart contract basis. If user just want, like if they want to shoot themselves in the foot, they can do that today with.
They should know if they're shooting themselves in the foot. That's I think the thing, right?
Yeah, if you are dealing with these type of things, you should know. Like for example, there are could be things in Lightning contracts which you can mess up, right? So like
you wouldn't though.
Yeah, right. So whenever you're dealing with scripts, you can mess up. It's just the thing sounds scary is like if you mess up, your coins are gone forever. And there are also similar like risks associated with smart contracts today. So it isn't that we are adding some new thing which was not, like some new attack vector which was not present today. And as I mentioned, like for example, using maybe just a single signature today with music, maybe covenants are already on the way. Like we just don't know.
I think the thing with Lightning is actually kind of interesting because like if you think about multi-signatures as being a type of covenant where the enforcement is done by people, like Lightning is already kind of a recursive covenant of sorts, just with people enforcing it. And if you've got automated things running this, it's just a question of like, is it the Bitcoin blockchain shooting you in the foot, or is it the automated services you have that are doing it? And I think for an end user, it might not be terribly different. The covenants, and this is similar to what we said earlier, it would just be like, well, we're shifting it to something that requires less signatures.
I have like sort of do we have time for like a...
We're going until they kick us off.
Okay.
Yeah, if you're in the back and you're like, we need to kick us off, we're going until
when they cut off the mics, we'll walk off stage.
Okay, sounds good. So my question is like, this kind of has, maybe this is like totally not related, but I'd really like to hear. So Lightning Labs just released this thing that they're gonna add to the annexes of Taproots, which is like a whole new UTXO tree and like a whole new scripting language. This thing called Tarot. Is that a covenant? Like maybe this is too, I know it just got announced yesterday, you guys haven't had a chance to look into it. Are those covenants? Is like coloring, it's kind of like coloring Bitcoins, right? Does that count as covenants? Has like Labs like basically launched covenants on Bitcoin already with their Tarot stuff and their colored coin things? Or is this stuff that we're talking about covenants-wise like totally different?
I have reviewed it, so I don't know if you guys have had a chance.
No, I didn't.
Okay.
So Jeremy, you haven't been doing any talking on this panel. Why don't you go ahead and help us?
I know I've talked too much, so like that's why I'm like hopefully one of you had read it, but I've read it. So I would answer that it is not Bitcoin validated covenants. It is client side validated covenants, which means that you're free to, if you own one of these things, you can definitely burn all the coins, and that will escape because you've just messed it up. But if you're running the software, you will generate artifacts that somebody else could verify. And that, and also just a technical note, they're not in the annexes, which is important for something. But anyways, they internally can have their own covenants and things, but there's always a top level clause which says basically, well, you're free to mess it up if you want to. And so Bitcoin does not have covenants, but in their system, it is kind of a covenant, if that makes sense.
So if you can do covenants that way, why do we need to change the Bitcoin script itself if we can
You could not build a vault with Terra.
I see. So one of the benefits of adding covenants to Bitcoin, like as of inside like the Bitcoin infrastructure itself, is that now we can express things about Bitcoin, like your Bitcoin hoard, so to speak. Whereas adding stuff like the project that Lightning Labs announced doesn't give you that level of control, is my understanding. Okay.
I'd say that's a correct understanding.
I just want to kind of put a cherry on top of, in terms of the devil's advocate stuff for CTV or whatever, I just want to include Burak here, just a little bit here. I know you're currently using Blockstream's product, Liquid.
Yes.
What is something like CTV potentially missing that you would want to see, or how are you using covenants, or how are you using Liquid where it's maybe not even going to be satisfied by some of this stuff?
Oh yeah, I think we can.
I just want to.
Yeah, we can already, I think, emulate CTV to some extent in the Elements opcodes, but I think with a CTV, that emulation would be more efficient because you can do like the channel factories, for instance, in 1 byte, as opposed to hundreds lines of bytes, right? I think Elements opcodes, right, are less controversial to maybe some of them to pay the way for Bitcoin because they are pretty much not battle tested yet, but they're being tested. And Elements is based on the Bitcoin core code base, and I think are less controversial to my observation, like things like checksig from stack for checking arbitrary signatures and cats, like data manipulations, and maybe some arithmetics, right, could maybe potentially come to Bitcoin. But I think CTV, is really simple, right? And from what I observed, like from the community, people don't really, Bitcoiners don't really want these highly expressive, very complicated proposals, right? They rather powerful yet simple proposals. And I think, when you think about it, covenants, this whole thing is really a spectrum, right? I think CTV fits really in this middle of the spectrum, right? Whereas, you could have very expressive stuff on the high end of the spectrum, but it doesn't really make sense to, merge into Bitcoin.
Thank you. And in 60 seconds or less, what does CTV need to cross into Bitcoin? What does it need going forward? Maybe you can talk a little bit about that very quickly.
Yeah, so there's a website, utxos.org/signals. This is kind of the best effort that I'm doing, which is just like making sure more people in the community want it. And if anybody doesn't want it, they express in a coherent way what their opposition is. Right now, there's like 130 people and organizations who have been like, yeah, seems good. There's like 2 people or 3 people who've been like, I don't want it because I think we have enough to work on with Taproot. That's been the main, kind of complaint. I think there are other people who might say they don't want it for various reasons. I would really like to see more people give one of these things like, oh, we don't want Taproot because of quantum things, so that we can actually rebut the arguments. If you don't make the argument in the, right forum, then it can't be rebutted. And then beyond that, I just need to do like a binary release and pick some parameters, and that's it. And it's like then the community can decide to signal for it. We'll do a soft fork just like Taproot.
Lisa, did we learn anything?
I learned a lot. This was really informative.
I learned a ton as well.
Yeah.
I really quickly want to go through, Shill, how people can contact you, your Twitter, whatever. Lisa, we can start and we'll work.
Yeah, I'm on Twitter at niftynei, niftynei. Also work on Core Lightning. That's core_LN. So find us there.
I'm at Jerem Rubin on Twitter, and you can find me there.
Yeah, I am Burak, like simple as that, Burak, B-U-R-A-K. You can find me on Twitter and Medium. You can also check out Bitmetrics on Twitter. It's a covenant-based AMM on Liquid.
Hi, I'm Sanket, Sanket1729 on Twitter. And to final shout out, if you have any complaints or concerns against recursive covenants, feel free to find me and DM me at all platforms. I'm always available to address those.
And I'm Michael Tidwell, and Mike21 spelled out with a 1 on the end. at the worst username ever. Thank you all so much for coming. Give a round of applause.
Thank you.
All right.
All right, so what's this lightning thing you guys work on? And you want to give a brief introduction of who you guys even are?
Yeah, I guess I can start. So hi, I'm Matt. I have worked on various things in Bitcoin over the years. I now work on the LDK project as a part of the Spiral team at Square. I guess we're Block now. So we have, I guess we're unique in the Lightning implementations here. We're not actually a Lightning node. We are a toolkit to build a custom Lightning node. So we support various people building different Lightning nodes using LDK to do a lot of the hard work.
Yeah, hi, I'm Chris. I've been in Bitcoin for 1/3 of my life, I just realized, since 2009. And I'm now working for a Blockstream on Core Lightning, and of course the specification, which is probably why we're all here.
Definitely. Hey, I'm Olaoluwa, co-founder and CTO of Lightning Labs, working on Lightning for a while now too, kind of like involved in some of the early stuff on the spec side. I'm like the lead developer of LND, which is the implementation of Lightning. One cool thing about it, it kind of like runs everywhere. You can do it on mobile, iOS, Windows, FreeBSD, random other BSDs you've never heard of. And obviously, we participate in spec stuff as well.
Let's actually quickly get a round of applause for Lightning Labs for their recent huge round of capital that they just raised.
Thank you, thank you.
So what's exciting now, what comes to mind for me is Bolt 12, route blinding. What's new in Lightning? What do you guys care about these days?
Bolt 12, obviously. I mean, we all got hats.
Yeah.
So that's
Look at
what
mine.
makes
Cool.
decisions around here is we just go by the hat.
And it's just the hats.
Just the hats.
Right,
just the hats.
Oh, yeah.
The technology, we're not
no
gonna
tech
go
behind
that.
it.
That's hard. No, yeah, I mean, Bolt 12 is awesome. It has a few different parts. So like Onion messages by itself is cool. So the potential to be able to do, we have this great network. Obviously, it's not set up for high bandwidth messaging, but being able to use it to provide some privacy for senders doing stuff like requesting invoices, right? You have like LN URL is really great if you want to know the client's IP address, but sometimes you don't care and you don't want that information. So stuff like that. And then route blinding, so improving privacy across the board there, plus Taproot with PTLCs. Like we have a lot of these kind of small incremental privacy upgrades coming down the pipeline that are all going to be pretty great. And then hopefully a bunch of UX improvements on the side with that from new messages and other stuff that we can build using them.
Absolutely, and one of the more exciting things that I'm seeing in the near future is the update of the Gossip protocol too. So the Gossip protocol has been growing organically for the last couple of years. We've seen a couple of places where we could improve it and try to improve it, but now the protocol is pretty much a monstrosity and needs to be overhauled completely. And while we're at it, we can add a lot of new features. For example, we can decouple now or there's plans to decouple the on-chain footprint from the actual channel, which should help us make the entire network much more private. And in combination with some other things like route hints, we can actually make this network much more compact and much more usable for the end users as well.
Definitely. Yeah, I say things I'm excited about are kind of like generally just Taproot related stuff. As far as like being able to use Multisig 2 and also kind of like actually make certain components a lot more compact basically, and certain things around kind of like making HLC a little bit easier to handle as far as like not even payment hash. I think one other interesting thing would be kind of like the actual transition to Taproot, because like say we have like 80,000 channels, 3,000, 4,000 BTC or something like that. So obviously everyone close channels all at once. That would be kind of like so many on-chain transactions as well too. So I'm working on some ways to basically allow people to like do that on the fly basically. So rather than kind of like everyone like open and close a channel at once, it's kind of okay. Well, we'll kind of like have another spend off chain and defer that. So we still need two transactions eventually. We can at least kind of like defer that a little bit further out, right? That'd be really cool because then people can just update and all of a sudden they're able to use Taproot stuff. Then the bigger thing obviously is like the PTLCs, which actually fix a bunch of issues as far as like privacy in my network. Because today you actually have like the same identifier in the entire route. So therefore I'm in two different places. Within the route I basically know what it is, but now it's actually going to be randomized, and PTLCs composed of things like DLCs as well too. So I think this year is going to be a lot of stuff, working on the spec side. And I think that's one of the things. There's just like so much stuff at the end of the day too, and everything is almost almost immediately implementable as well too. So you kind of like have to say, okay, maybe some restraints, see what we're going to do, whatever else, how we can like allocate our resources as well too. Because at the end of the day, like even though there's things a lot bigger, there's still a few people that really know this stuff very intimately. But obviously we're trying to make that a lot more widespread. I worked with Andreas and Renee on the Mastering Lightning Network book as well too. Definitely get that. If you haven't got it already, it has a bunch of really good information about as far as the boats as well. Because the boats are kind of like written for people like us basically, and you need kind of like a little bit more accessible thing. Okay, like how do the feature bits actually work? How do like writing work, things like that as well too. So education is getting a lot better, and just generally a lot of the developer education is getting really good these days as well. So.
Yeah, and how could I forget, of course, splicing, which we've now built the groundwork using with the dual funding proposal, which basically allows us to collaboratively create a transaction among a number of peers. And looking a bit further on, I think we are all waiting on L2 being a possibility. Of course, it had to be me mentioning L2 here because I'm known as the L2 shill.
Yeah, he's got to get it in.
And any prev out is required as like a soft fork for that, correct?
So any prev out is a soft fork that we need for Bitcoin on chain. Though there are other mechanisms that we could use, opctv in combination with checksig from stack or tx hash and checksig from stack. Both achieve the same goals. So we were pretty much just sitting and waiting for either of these to happen and to give us that capability of doing some really interesting channel stuff. Like, for example, multi-party channels, where any number of participants can basically share ownership of a single UTXO, giving us a couple of more orders of magnitude on top of Lightning.
Definitely. TLDR, we all have about 5 years worth of engineering roadmap planned out, and we'll start delivering this stuff, I don't know when we get to it.
Soon,
yeah, sort of the head of what we're planning to do is getting further and further away from us. And
yeah, the to-do list keeps growing. Like, that's
right.
And I think one cool thing about Lightning is like, there's certain things that can improve the protocol that aren't necessarily like kind of like protocol level changes. For example, like in the past year, we've seen a lot of people actually working on things like pathfinding, which is a big thing for improving UX as well too. And it's one of the things where like the spec says, get from A to B, doesn't really tell you how to do so, right? So we've all been kind of like filling in the gaps. When some people do like, some newer kind of like probabilistic approaches as well too. And I think that's gonna be really cool because like, once we can move larger amounts of payments and also like payments reliability gets a lot better. Because like the worst thing is like someone tries and obviously it fails, right? But I think we're getting a lot better now. People are also getting like really widespread deployments with like Cash App as we're getting a lot more data. Now it's like, okay, like people can actually use Lightning now, which is also really great for like developers and companies because now it's okay, well, I actually have distribution, I actually launch my application versus, picking from like 5 different wallets that, all are a little bit different. So I think that's a really good thing as far as maturing user experience, with kind of like things at the edges, like people can just update protocol-wise, algorithm-wise versus protocol-wise as well.
And then more research across different types of routing, because there's different things you want to optimize for, whether it's like speed of the payment, or maybe you want to optimize for lower fees because you're like rebalancing or doing something in the background. Maybe you want to optimize for privacy, which is somewhere that like how to do good private routing is not something that's had really a lot of research. There's some intuitions, you can throw some ideas around, but no one's really kind of taken a formal approach. So there's even angles where like we need more academic research in that sense. Like academics have shown that a lot of the routing algorithms we have today are very non-private, but how to fix it, a little less so. So there'd be a lot of room to improve there too.
Definitely.
Yeah, there's just so many different venues where we can actually make progress and try to start experimenting. And it makes me a little bit giddy because it sort of is this huge playground where we can explore new trade-offs and sort of try to improve. And that's one of the achievements that we got by basically lifting off of the chain, by no longer being on the consensus layer where every single change has to be approved by the entirety of the network because it is a strong consensus algorithm we have to run on the base system. But by lifting off of the chain, we can actually get this freedom to experiment and basically get different parties try different trade-offs, and then sort of come back to the table and sort of discuss what worked best, what didn't work, and sort of come to a more cohesive picture of what we should do going forward.
Yeah, there's so many problems in Lightning. It's easy to get like nerd sniped, just kind of like go very, very deep in a particular problem. I think one of the cool things obviously the past maybe like 2 years or so, there's been like a lot of academic papers now like actually doing Lightning stuff. Like I have like a Google Scholar alert, and like every day I see a new paper basically, and like I have like a little research channel I post in there. It's really cool just like seeing people kind of like recognize that this is like a thing to be working on, and all the kind of like interesting sub problems. Where okay, I can do pathfinding, I can do kind of like graph analysis, I can do like channel selection, I can do optimization. There's so many different problems we're working on, and it's like you're saying, it's so fun to be able to like pick and choose all this different technologies and like kind of solutions to take a look at.
So it seems like all the hype is currently Taro. Can you talk about shitcoins on Lightning?
I don't know if I phrase it like that. I mean, people can free to what they want to do. But something that I was working on for a few months now, kind of like inspired by like, okay, what can we do with Taproot, right? So kind of like starts from the realization that, okay, well, Taproot has like a script tree, so you can commit different paths. Okay, maybe there's like a multisig, there's like a time lock, something like that. So okay, well, what if we committed other data in that tree, right? So okay, well, now that we have that other data, like how do we actually structure it? It's kind of the thing where it's like, this enables you to basically have like, you can hold assets within kind of like a single Taproot output, basically. So I have like my Bitcoin, but then I can potentially have like, 1,000 different assets. Maybe I have like a, holographic Beep Start card, baseball card, something else like that as well too. And the cool thing about it is like, it's like very kind of like, Bitcoin-like, right? It's like rather than kind of like try to create like entirely new VM or things or whatever else, kind of like reuse the existing Bitcoin script VM itself. So you effectively kind of like have this like virtual transaction graph which is embedded in the Taproot script tree basically with a similar kind of like asset witness and output format. Uses some things as far as like Merkle symmetry, different ways to do like efficient proofs. But the idea is like once people just upgrade basically, and the cool thing about it is like it doesn't actually require any base layer level changes, right? So once it's rolled out, people can actually just upgrade and start using it, on their own. And the cool thing also is that like because it's actually based on like the Taproot script tree, like if we have some like certain type of covenants, maybe like the Taproot update verify, that can actually constrain transitions basically, because if you can recompute the entire commitment basically, you can recompute the script tree, and you can basically say, okay, well, it must look like this, right? So I think it's really cool where it's like even if Bitcoin doesn't actually know about it explicitly, covenants can still eventually kind of like manipulate the thing that's going on there, right? And the lightning part of it is that like given that it's actually based on Taproot and also has like a scripting layer in the actual system itself, this is what we're kind of like proposing doing is kind of like having the assets at the edges basically, right? So rather than like the network upgrade basically, you have a bunch of questions as far as like routing, liquidity, blah blah things like that as well too. It's like only if the sender and receiver are updated, you actually need to do this thing. This is really cool because now you actually retain all the network effects of Bitcoin in itself because now everything's actually crossing through Bitcoin the entire time, right? So maybe like a router is okay, well, I don't know what's happening, but I'm getting a lot more activity, I'm getting a lot more routing fees, I'm getting a lot more revenue. So I think it's a really cool kind of like feedback cycle as far as the network effect where like more demand at the edges basically means more capacity, which means more routing activity, which means more energy, which means more activity as well. So really excited about that.
So you can shitcoin, I can route your shitcoin, and we can still be friends.
Exactly. You can keep your hands clean if you want to, right? But it can be like other stuff. I can give you cool points. I can give you beef bucks. I can give you whatever. So I think that's the cool thing where it's fully opt-in basically. If you don't want to touch it, you don't have to touch it or whatever else. But indirectly, maybe it's going to like actually improve your routing node and actual routing revenue as well too. Because you can say, okay, now with this, maybe we can start to position it against like more directly like credit card or something like that, right? Because maybe people still want that fiat balance. Maybe they want kind of like other currencies, something like that. But now it's okay. Well, Bitcoin Lightning can be the massive crossing network for everything else. Kind of be the monetary backbone. You can do whatever you want to the edges, and the core of the protocol just stays Bitcoin fully, and that makes it a lot simpler as well too. You don't have to worry about other things, as far as like crossing different chains in the internal network, time locks, forks, things like that. That's all a nightmare.
So it's the strike pitch, but not centralized.
Yeah. So in theory, someone could take this and build a strike-like thing as well. And I think that's a beautiful part about like, protocols. And it's going to be like an open protocol as well too. And we published some BIP drafts. Some of them are more complete than others. Definitely working on filling some additional details. But the idea is anyone can basically start to use this thing and build the strike in Nigeria or wherever else they really want to. So it's kind of really the cool thing about open protocols where people can just start to use it and improve it, and then it goes from there.
What's going on in LDK land? I remember you and Andre were lecturing me at Socratic last year about waking up mobile wallets when they're needed, async await. What's new, man?
Yeah. That's kind of loud. So yeah, our whole pitch is kind of to improve the ability of mobile wallets to integrate Lightning, where you have all these existing on-chain Bitcoin wallets. They're great. They have all their logic to download the chain and sync and store keys and do all that kind of stuff. But now you want them to add Lightning, and there's not really an option for them. They can start re-implementing Lightning from the ground up. We just talked about how we have 5 years of stuff to do, and all of us have teams of 3, 4, 5 people full-time maintaining a Lightning implementation, keeping it running, and adding all the features that we want to add. So obviously, that's a pretty big ask for most mobile wallets. Our pitch is kind of like, here, we're going to do all the hard work for you. You can integrate this. You can run it. And our pitch being on mobile means we have to fix a lot of the issues with mobile on Lightning today. And anyone who runs a big Lightning payment processor today knows that a lot of your payments fail because they're going out to a node that's on a mobile phone, and it goes out, and then the phone is not currently on the internet, it's sleeping, the app's not open in the foreground, or the phone's locked, and all of a sudden the payment bounces. Because turns out these phones are super, super battery life conservative. Anytime the phone's not on, it disconnects the wireless, it disconnects the LTE modem, and you can get no CPU access. So this is a major problem. You have payments that just fail. You can't actually receive a payment unless your phone is currently open and on the app. Depends on the device, but that is obviously a pretty unusable user experience. So that's, we were talking about exciting things about, onion messages, and I think there's, as far as I know, the only proposal to do relatively decentralized, or at least trustless, offline payment receipt in Lightning was something I proposed kind of loosely a few months ago, but it depends on Taproot and Onion messages and LSPs. So this is, it depends on these things that we have that are probably a year or two out because we have so much stuff to get done. And then we can start fixing these more fundamental problems that a lot of people are facing today that really hurt the user experience of Lightning, that really destroy it for a lot of users. And so yeah, we have a lot of work to do. But that's, so things are going well. We have Cash App shipped with LDK. We were sitting there talking about mobile, and then Cash App said like, well, we have all this complicated backend infrastructure. We want to integrate our Lightning node super tightly with that. And taking LND or Core Lightning off the shelf and running it is cool, but like we want it actually really, like we want the logging to go directly to our logging service, and we want the database to go to our database service, and we want blah, blah, blah. And so they built a node, from scratch using LDK, and that wasn't too hard for them. You just kind of plug the things into the right place, and they've been pretty happy with it. It seems to work pretty well.
That's awesome. Christian, what's up with Core Lightning and plugins? Can you talk about this CL boss thing I always hear about? What is Greenlight?
Can we still call it C Lightning, by the way? Or
yeah, I keep slipping up and calling it C Lightning, but no, Core Lightning it is. So
hardcore.
Yeah.
Hardcore, yeah. So yeah, Core Lightning has always been sort of the bit of the Lego block kind of node where you can switch out individual parts, or at least that has always been the goal. And we started building out plugins, and some of the functionality that ships with Core Lightning itself is actually a plugin. So the pay command, for example, is implemented in a plugin, and you can swap out the logic relatively easily. And we've gotten some feedback from researchers that are looking into how to optimize payments. And they could just take the pay plugin and re-implement it with their routing logic and basically experiment with that quite easily without having to have all of the knowledge to actually assemble a full node. And we're going a bit further with that now with a new project called Greenlight, where we are actually taking the node and exploding it into a bunch of different parts and sort of reassembling it, running it on different infrastructure. The main node itself running on our infrastructure, but the keys are kept on the user side, and the front end is kept on the user side. And sort of this is a different trade-off from what LDK does, in that we don't try to bundle the node with the app itself, but we try to have every user have one node and sort of remoting in, which allows you to have a multitude of interfaces. And the way we approach the issue of being able to accept an offline payment is that you can have any number of front ends, but you can also have any number of signers present. And as long as any of them is present, you can still receive a payment, an incoming payment. And so I think that this is an interesting setup where we can sort of redistribute the competencies, and sort of we specialize in doing what we do best, and app developers don't even have to learn about how to run Lightning nodes themselves. It's one trade-off, but I see a multitude of different ways to sort of redistribute these parts in the future, making more interesting setups possible, where we can actually tap into a multitude of different use cases as well. And this has been ingrained in Core Lightning for the longest time. We've already always had the HSMD as a separate process, because we were eventually hoping to make it a hardware security module. And now we're doing that step of going in that direction of actually splitting parts out and redistributing responsibilities.
That's a great segue, actually. The next thing I wanted to ask you guys, no one ever shuts up about WASM. I'd like to go around and ask how you think WASM is useful in your implementation, and how you approach remote signing, as Christian was alluding to.
Cool. I guess we can go over this way. So WASM is definitely very cool. So we actually used it for this new project that we had called LNC Lightning Node Connect. Basically, the idea was, okay, like, we want people to have to kind of like have like a web application and kind of like securely connect that out to a Lightning node. So I think before people had like these like giant QR codes sending right macaroons, all sort of else. So we kind of like devised this, protocol kind of like devised off of something called PAKE, so like password authenticated key encryption. So you just basically put in this kind of, like pairing phrase basically, and you have like a secure tunnel from your node into the browser itself, which is really cool because now you can kind of have like a more native experience as far as building web applications things like that as well. So what we ended up doing with WASM at that point, we actually compiled like most of LND into WASM basically, because we had a bunch of crypto as far as like ECDH things like that as well too, and all that's actually now in Go, right? So we actually have a bunch of like we have like a full gRPC client in Go. We have all the TLS stuff in Go. We have all the PAKE stuff as well too. So I think it's a really cool way to kind of like be able to distribute things. It's kind of like this intermediate, you can say like IR or binary layer basically, right? So it's kind of cool because you can basically have an even language compiled into this kind of like single slightly modified interpreter or VM and kind of like distribute that pretty easily. For Go, it's kind of like a little bit larger. You have to like because like you actually link the entire standard library. The WASM blob is a little bit larger, but we have a thing now where we're kind of like doing like a just-in-time load of it, where you can kind of have your own load as well too. Things really be flexible as far as like being able to like do more things on the web. I think the dream is kind of like basically have like a fully WASM node in the browser itself, have like a light client. Because now at that point, it's okay, well, user kind of like have like a very like sleek onboarding experience. They download maybe a Chrome extension, boom, they get started. They don't need to worry about where their node is, move on for else. So and obviously maybe you don't want to put your life savings in that thing. A small amount, maybe do some tips or something else. But I think once you have that, you basically have the potential to do things like streaming payments on the web itself, stream for video, do the upvote thing, destroy paywalls, things like that as well. So I think it's going to be really powerful moving forward.
Yeah, so we're definitely looking forward to having some parts of C Lightning running in WASM. Core Lightning, sorry. Keep slipping out.
It's bound to happen.
But what scares me about WASM is basically that now it's possible to build to have a full node run in a browser tab. And do we really want to get into the habit of suggesting users to enter their seed phrase into a browser tab that might be just impersonating your actual wallet? But then again, like Rosebeef said, it is basically a requirement for us to have something like a browser extension or something like that. So yes, we will probably not run the full node inside of a browser window in the form of WASM, but we're definitely looking into having sort of the client libraries talking to Core Lightning and the signers run in a WASM context, be that a browser extension or a browser window. Such that you can still remote into your node, whether that's self-hosted or we manage it for you, and that's definitely something that we need to do if we want to reach all the users that we want to reach in the end.
Yeah, so Olaoluwa said that the dream is to maybe eventually have a Lightning node run in WASM. So we have that. It works. You can take LDK. You can run it in WASM today. We've tested running some nodes in the browser. It's super lightweight. It doesn't weigh anything as long as you're not downloading the full graph data. So if you maybe have a smarter way of doing routing, and you're not routing a lot of payments, you're just like a personal node sending and receiving things. It's super lightweight. It costs nothing. The WASM binary is pretty small. So yeah, it works great. LDK doesn't take any stance on whether people should do things. We just provide the tools that they can do them. Certainly there are, obviously, having your keys for your Bitcoin in a website tab is pretty sketch. Having your keys for your Bitcoin in a Chrome extension or in a React client where it's actually a JavaScript web platform, but a separate application on your computer is maybe a very different world. So yeah, we do that. We support it. You can take the whole thing and run it in a web browser if you want.
Cool. How do y'all handle like Bitcoin access to P2P network? Is that kind of like an RPC thing in that context?
Yeah. So LDK does not. We have some pre-built things that you can sync the chain via like Bitcoin Core, but we otherwise just have a general interface for like, hey, provide us graph data. And there's actually two different interfaces. There's one that's more Electrum-like, and then there's one that's more kind of like Bitcoin Core or like full node-like. So you can kind of like however you want to sync the blockchain. We have an API that's like pretty similar to the way you're already syncing the blockchain, and you just kind of feed it chain data, and then we tell you what you need.
Can you serve it over DNS yet?
Full blockchain data over DNS, no, but you can download the headers over DNS. I do run a service to do that, so that's also fun. Or over wireless. So I don't know if NVK is here, but he's been doing like Bitcoin stuff over ham for a while, so you could do that too. That might not run in a web browser though.
Yeah.
Ham radio is going to be hard to run.
How do you get the web browser tab to talk to your satellite dish?
Yeah, that might be hard too.
Need a dongle. One cool thing about like kind of like layering like high-level protocols, people know about the neutrino protocol. It's kind of like a way to do like clients on Bitcoin. And the cool thing about it, it's like actually kind of like stateless. Like the older protocols kind of like had you kind of like communicate with the node and kind of like match these filters and interactively. But this like basically download a filter, right? So now like one cool thing you can do with that is okay, well I can put that on like a CDN, maybe HTTP2. I can download the headers, the filters on the blocks, basically just over this HTTP system itself. So that's really cool because now like the browser already do HTTP and like it's kind of harder to do kind of like more advanced like you don't really have like raw TLS or TCP sockets or something like that. So instead I can basically kind of like have that and download all the data over HTTP. It's going to be super cache everywhere CN-wise, so that can be like a cool way to kind of like kind of like navigate some of the trade-offs security-wise. Where okay, like we don't want people just to hidden some massive API like MetaMask or something like that. They can actually get the data. And the cool thing about POW is like it's objective. You can verify that you can verify the hashes, run the numbers, things like that. So it's a little bit better as far as security models compared to like everyone using one centralized API that can just lie to you because there's no really assurances with some of those other systems.
Yeah, I also provide the BIP157 header chain via DNS.
If you
nice.
I
Want to download that over DNS, you could do that.
Yeah, I forgot about that.
Yeah, I mean, I find it really interesting how we sort of started out with this really small set of transport protocols, and by the way that the Bitcoin metadata is structured, we can actually just swap out the transport layer and offer different services on different kinds, be it DNS or HTTP. Or the Bitcoin protocol.
Yeah, and and the PTP protocol today in the Bitcoin, it's kind of like evolved that way, but there are other ways to do it. Like for example, Matt's done a bunch of work in the past as far as like improving block propagation, things like that as well too. So protocol work is it's super fun. I mean, there's just so many things you can do. It's just kind of like all these puzzle pieces.
Gotcha. So I think we all are grateful to where Bolt 11 got us. But there's a major shortcoming. But some of the application developers have even taken it into their own hands with certain things like LNURL, Lightning address. I know right now there's a priorities contention going on between Bolt 12 and AMP. Can you summarize AMP and maybe when or if we have a spec for it and the trade-offs?
There's a spec? I mean, yeah, there's a spec. It's just kind of a little bit dated. It's actually pretty up to date now, but AMP is basically, people probably heard of keysend, which kind of where you like a spontaneous payment, you basically push payment over, right? That works by kind of including a pre-image in like the onion payload, which encrypts the nHop, and they basically decrypt, and then they use that pre-image to settle the actual payment itself. AMP is kind of like, you can say like the multipath analog of that. Multipath payments is basically a way to kind of like split payment up in different pieces. This basically uses kind of like something called secret sharing. So basically, I take the pre-image, I kind of like extort into a bunch of different shares. I send you all those shares, then only after you have that final share can you extort it back to basically get the pre-image and settle everything else like that, right? So it kind of gives you, push payments in like a multipath fashion, right? And the one thing it has as well too, given that the actual sender is the one actually going to make the pre-image, you can have like a static invoice that's kind of like fully enclosed, right? So basically, you give me the invoice, I can just pay it over and over again. So it works by kind of like having other identifiers. So you have like a payment address or like a payment secret basically, something called a set ID. So this is like now your main identifier, and then every single new payment actually has a new set ID there, right? So it basically gives you spontaneous push payments, but also kind of like a reusable invoice around itself. And obviously there's Bolt 12. Bolt 12 has a lot of other stuff with it as well. So AMP was kind of like okay, doing payments or whatever else. So I think Bolt 12 it's kind of, to me, it's kind of like an invoice negotiation protocol, right? It has a bunch of other things as far as like negotiating invoices, all of this like optional refund stuff. You have a new format, things like that as well too. While this one is something that can be deployed today because it's kind of like just mostly at the edges, and obviously like maybe an address change in Bitcoin took a while to actually work properly. So maybe the Bolt 12 stuff like has a little more of a barrier, and there's other things that kind of like have similar functionality, LNUR, whatever else. But I guess it depends on kind of like the trade-offs. If you want something that's more opinionated in the protocol, or if you want something that's a little bit more at the edges that people can maybe do what they do, because things like LN address and whatever else, people can update those on the fly and just release a new version versus kind of requiring larger changes as well too. But Bolt 12 has a lot of cool stuff into it. But I feel like maybe we can break it up and kind of do it a little more incrementally, and then see exactly how the use cases turn out, and talk to the people, the wallet operators and services as well to see exactly how things can evolve in the future.
Is it true that the main differentiation is AMP doesn't have like a proof of payment? That's what I often hear.
Yes. So I think To me, I think the whole proof payment thing, it depends on what you mean. Because I feel like, I've been using Lightning for a while now. I've never had a thing where a service asks me for a pre-image. Does the user even know what a pre-image is? Is there even actually like a standardized format as far as like, actually serializing what a proof payment is itself? So I think it really depends what you want there. But that is true where like, I know Boat 12 has a way where I think there's like a sender key and you can use that key basically to like sign something to basically prove that you paid it. While with AMP, because it's spontaneous payment, there's not kind of like a way to like give you that capability. But once you add things like PTLCs, there's actually a way to do that because then you can actually like have a key in the invoice and kind of like add that to the payment that you're sending there as well too. So it's kind of a thing where it's like, this is better for maybe something like a donation where I'm kind of like, pushing you money, maybe kind of like a streaming thing, but maybe if I'm doing something where, I want recourse, maybe like, I need like a shipping number or something like that, maybe you need that as well too. But I feel like at this point, I think this course is kind of like missing that. I haven't really seen, anything like that. Because I feel like, say, people
There are some other,
people probably ask you for an invoice number, right? And then you can go from there.
If you want to do an external signer, a verifying external signer, you need proof of payment. So actually AMP and KeySend are basically break stuff like Greenlight in like a secure model, or if you just want to have a hardware wallet that's doing the actual signing, you need to not have that pre-image in the onion. Otherwise, you have to like do more hops to have the onion decrypted on the thing. It's a lot more painful there.
Yeah, I feel like for me, proof payment is one of the things where I think us as developers think it's cool because we actually have a thing, but then I feel like practically I haven't really seen people really demand it that much just because there's that extra step of, okay, how do you serialize it, how do I interpret it, versus just telling them, what's my invoice number, which is probably what you're doing anyway. But I think it's definitely cool. For me, I feel like we need to like, mature the concept basically and just like say, okay, what exactly do we need? People know Connor Fremnick, who used to work on Lightning stuff, he had this like massive matrix basically, basically the different types of proof payment, right? For example, like, if I have the pre-image, that proves that like someone paid maybe gave me the pre-image, that doesn't really prove that I uniquely paid. You kind of like maybe need some digital signature scheme along that as well. So it's okay, well, I have the pre-image and I have the signature that proves so I can pay as well too. So I think there's kind of like, a gradient as far as, okay, well, proof payment as check the invoice is paid, versus proof payment, okay, there's like a cryptographic proof basically that no one else could actually forge or produce. So definitely some nuance there, I think.
There's also just very different, like, what are you trying to accomplish, right? There's like, are you trying to do donations? In which case, like, KeySend, AMP, Bolt 12 are all options. Are you trying to do payments to a store? Well, KeySend and AMP aren't really, like Bolt 12 or like LNURL or Bolt 11, but no one wants Bolt 11, are options. Are you trying to do a payment to like a non-custodial mobile? Okay, now you need like Bolt 12 and then maybe some extensions on top of that, and like LNURL and KeySend and AMP don't do anything for you there. There's a lot of different there's a lot of different potential things you want to pay and different ways you want to pay and from different clients to different clients, and Bolt 12 forms a good base to build basically all of those, but then there's also more immediate term for different specific use cases. There are good solutions like LNURL is great if you're paying someone who runs like an HTTPS server, like a web store. KeySend is great for donations. AMP is cool, but I'm going to say something a little controversial. MPP doesn't actually really matter. Multipath does not make a big difference for payment success, for payment.
I don't know about that.
Your bigger concern is network flow.
But I mean, but you can say like there's certain payments that you can make with MPP that you couldn't.
That is true.
Right?
That is true. Those are I mean, are you donating $10,000?
Or just someone has fragmented
interested
channels.
in doing a payment for $10,000.
Yes, you might be, but specifically in the donation context.
In the donation context, I do have a point. I do have reason to want a proof of payment. By the way, I want to be able to prove to my tax office that I donated.
This is all different. Another complication. But for the most common values of Lightning payments today, MPP doesn't really make.
I think for smaller amounts, and I think it's always an interesting thing where we had MPP, then we had one boat. Now you have like really big channels there. You have like one or two BTC channels as well. So I'm sending one Satoshi through like a 200 million Satoshi channel, probably going to work as well too. But I think the interesting part of MPP is people are starting to do kind of like more complex kind of flow analysis as far as trying to have like the optimal route of particular things like that as well too. So I think that's really cool in that domain. But sometimes maybe you can probably just try it if it's a very small amount. But I think once you get like much larger amounts, basically, people are doing like one BTC plus, maybe they're doing things like Loop and like moving larger funds around. That I think maybe matters more. There's kind of like a theoretical thing where you can say, okay, if you can split the payments and enough liquidity exists, in theory you can get there eventually. But eventually maybe isn't good UX wise.
So the bigger problem is the flow is the question.
The whole idea of doing min cost flow from Rene is basically based on as you approach the minimum cut in the network. When it comes to liquidity, you have to get more optimal. If you have a min cut that is basically like 3 Bitcoin and you want to send 10,000 Satoshi, why do the work?
Right.
But if I approach that min cut, you basically are forced to become really clever.
The problem is if you approach that min cut, suddenly it doesn't, like your individual payment doesn't matter, it's the total flow through the network, right? You have so much flow through the network that the relative gain of doing something more complicated for an individual payment is substantially less. Like your payment has to be a small fraction of the total flow, and thus you don't really, and because it's a small fraction of your total flow, you don't have to be quite as optimal on the individual payment.
Yeah, that's true, but interestingly enough, your own capacity and the capacity on the recipient's end is usually the actual min cut.
Right.
So if you had a negotiation mechanism, onion messages, where you could sort of gossip this information back and forth, you could potentially figure out quite quickly if a payment is possible at all, because it's either you or the recipient who is going to limit your capacity. So,
So suddenly you're MVPing just based on your channels.
Yeah. But I think as Matt said as well, payments have a lot of different parameters. So maybe depending on the payment size, depending on latency as well. I think there's going to be in the future probably different algorithms people will choose based on maybe the payment size or kind of their own parameters. And it's kind of a wide open thing where it's you can do whatever you want basically. And I think the cool thing is incentive-wise, as new algorithms are developed, maybe the routers themselves which is more or less depending on the client's getting smarter. So is the edge going to get smarter, or kind of are the internal routers going to get smarter as far as manage the liquidity better, do the balancing as well. Definitely still really wide open I think, and really cool to see more research in this area, because this is kind of thing I can say probably has the most leverage, increasing payment UX basically and speed and latency. That just makes it work, and that's what makes it seem magical.
So as Matt was pointing out before, there is a wide spectrum of different preferences users might have when it comes to payments, right? If I'm standing in front of a point of sale, I really do care about latency. I don't want to be there waiting for a minute or so until my payment goes through. If I'm interested in just doing some exploratory probing, I don't care about latency. If I care about getting the cheapest possible payment, I might spend some more time actually computing the optimal route there. Or if I'm just interested in making sure this payment goes through no matter what, then I might use a different algorithms. And there's not just the algorithm side, but also how do we expose that to users in an understandable fashion. So for example, we always took the stance that users shouldn't care about fees too much. We for each payment we give the routing algorithm, we give it a budget, and it's free to do whatever it wants to do inside of that 0.5% budget we give that algorithm. And part of that we actually use for obfuscating our routes by increasing CLTVs, by allowing ourselves not to take just the cheapest route, because cheap routes are easy to predict. If you see a partial payment and oh, that's probably from this guy because I am his cheapest path. So you're leaking some information there.
Yeah, I think that's an interesting point as far as cheap payments and privacy. For example, there are kind of these zero fee nodes, not base fee, completely zero fee. And I think the interesting thing that is they're kind of a black hole because they cycle payment attempts, right? But if I was wanting to kind of monitor payments, wouldn't I just have a completely zero fee node as well too? So maybe you should want to avoid them because it's okay, skin of the game. I want to pay you to have some signal that you're not just collecting my stuff.
Shall we go negative fees maybe?
Yeah, are you selling my data because it's zero fee or something? I don't know.
I mean, yeah, I expect chain analysis to properly cost what my payment anonymity is worth to them, and if they pay me enough, I will de-anonymize myself to them. I need them to pay me. So
I would just stream my logs to them.
Well, how does that affect the channel DB? Because if there's zero fee, you're doing more payments, right? If you're logging all that info.
I mean, you're getting forwarded more probably.
Yeah, exactly.
Or get more forwards.
There's nothing in Lightning that you need a sufficiently sized disk, but it's a small amount of information per channel state update. And there's nothing, and the total size of the things you need to be actively dealing with as you update the state is constant size. So there's no real scaling issues there in terms of history and Lightning.
Funnily enough,
there are some application issues that need fixing, but sorry.
Funnily enough, the more limiting factor here is having to touch the disk at all.
Right.
Having to basically just flush out to disk and make sure that all of this data is actually written to disk. even on a relatively quick SSD nowadays, that takes time as compared to just operating in RAM. And that is one of the reasons why Onion Messages was created, because the Onion Messages do not have to have the node touch the disk at all. You can basically forget all of the information that an Onion Message told you. Maybe a reply might fail if you're restarting in between, but basically just removing that extra load that is currently used if you do communication via keysend or similar protocols is a huge win already for us.
Yeah. And I think one open question with Onion Message stuff is like, some people are saying, okay, well, should it be free? Should it be priced? How to be like rate limited as well too? Because like at least like attaching HLCs, there's kind of like some cost. Obviously it's not the most efficient thing in the world, but it's kind of the thing where it's like, okay, like do I want to be forwarding all of these like images or videos for free basically? Can I like charge for that? And if you can charge for me, that's interesting because now all of a sudden I can basically like make money off of routing revenue, but also make money off like forwarding bandwidth as well too.
Let's not add bandwidth as a cost to Lightning.
Yeah. But the cost is already there. Every single payment is 1.3 kilobytes already, right? So
the main
trivial.
The main problem with basically saying that keysend has a cost, it has a cost, but the cost is borne 20x by the network itself.
The cost is mostly the wear out of my disk.
Yeah. So it's not like imposing a minimal cost to the sender of a keysend message makes it so much better than an Onion Message. Because the cost that this keysend is having on the network itself is much greater.
Yeah.
And part of that is having to touch the disk. Part of that is disk wear. Part of that is having to keep state across over time until the channel is closed.
Yeah, at the same time, you can raise like your min HLC if you say, okay, well, I want to do one more payments alone and things like that. But I think it's just worth at least kind of like weighing some of the trade-offs and like the inherent costs, where it's okay, like free forwarding of messages, like maybe we should try like see incentive-wise, can we rate limit them maybe with like kind of like some congestion control algorithm, or can we actually charge for that from the get-go? But if you can charge for it, maybe that's just like supplemental income as well too. Maybe you kind of like get this whole new internet thing from like Silicon Valley along the way.
Oh, we need that compression algorithm.
Yeah, exactly. Yes. Middle out, dude.
That'd be nice.
Well, I think that's all, folks. We're done.
We ran out of time.
That's where the timer is. I didn't see that.
Yeah. It is still counting up.
Yeah. I guess before we head off, it seems like the whole Lightning network is mainly just Umbral people. Do you have one thing you want to tell them, if anything?
What do you mean? You like the plebs
Umbral node runners, yeah.
Hey, we love y'all basically, right? Like, I think it's really cool to kind of like have like grassroots community of people helping each other out, kind of like spreading different knowledge. And I think it's kind of like a cool hobby. It's like, oh, I'm like doing my part basically for the network compared to kind of like just like maybe something that isn't really contributing at all, or if that's just kind of like more like speculative or something as well too. So it's cool.
We need a world where we have a lot of those to balance out the fact that we're getting increasingly more of these large, custodial sort of like Cash App or whatever running very large nodes. Like we need lots of plebnet to balance that out.
Yeah.
So keep doing it.
Definitely, feedback from plebnet has been awesome, and we need more of that. This is what gets us going. This is what basically helps us develop Lightning further, and this is the feedback that will get us to a place where all of this is actually stable and not siloed into some weird big company. So keep on doing it.
Yeah, the users.
Cool.
We're here for the users at the end of the day. So.
Yeah. Well, awesome. Thanks, guys.
Cool.
Everyone, we're here to talk about defining the standards of Taproot and Multisig. Why don't we start by doing a quick introduction for everyone across the stage. Let's start with Keith.
All right, my name is Keith Mukai. I'm a contributor to the Seed Signer DIY hardware wallet and the Spectre Desktop open source Bitcoin wallet software.
I'm Jameson, Lopp, co-founder and CTO of Casa. We help people be their own bank using multi-signature aspects of the protocol.
Hello, everybody. I'm Stick. I'm co-founder of Satoshi Labs, the creators of Trezor, and I occasionally contribute to Bitcoin Core as well.
Hi, I'm Ollie. I work at Lightning Labs on infrastructure stuff and LLD.
And I'm Afsheen. I'm the VP of Engineering at Unchained Capital, a collaborative custody financial services firm. All right, so the reason we're here today is that all of us separately have an individual need for multisig in the products that we offer to customers and to software users. But all of our needs are a little bit different. And Before Taproot, there was a pretty standard way for implementing multisig using op-check multisig and op-check multisig verify. Now that BIP 340, 341, and 342 have been activated and Taproot and TapScript are live, there's a sort of new way of doing things. Actually, there's several new ways of doing things. And there's no real hard standard defined. There's a bunch of different recommended paths. And as all of us were evaluating which path to go forward with, each of us encountered a different set of trade-offs. And we want to talk through the trade-offs that we experienced, that we ran into, and how we all came to a sort of consensus, if you will, on the way forward for implementing multisig on Taproot in the absence of a standard. Actually, let's talk about that for a bit, the absence of a standard. There's, like I said, 3 BIPs, 340, 341, and 342, that govern the Taproot TapScript upgrade. There's nothing in there per se that draws a line in the sand and said, this is the Taproot way of implementing multisig. Do you think that was an error or an omission? Does it make sense to have a BIP? Does it not make sense to have a BIP? What are the pros and cons there?
Yeah, I mean, that's...
Keith?
The only way to go is the BIP approach is for when everyone needs to agree for this thing to work. But in the Taproot world, we're adding so much flexibility that it doesn't make sense to say this is the one and only, or the one of the 3 only ways that you can go. Without getting too technical, it's like the old world was, it's a train. You get on at a stop, you get off at a stop, but it's on rails, and we all know where it's going and how it works. And now in the Taproot world, it's more like if you flip to the public transit tab of Google Maps, and it's like, oh, you can walk a mile, take bus 10, hop on this train, and get your destination. Or you can ride a bike 3 miles, get on this bus, right? There's so many different ways that you can go, and there's no way for any of us or the core developers to say, this is the one way that you need to go. And so all we can do is figure out, for each of our individual use cases, what's the best way to go, and make sure that we don't lock people in to a dead-end path they can't escape from.
I mean, this is the reason why we're here, I think, is because we're seeing parallels, at least I am, with our users, where if you were around and you were building during the SegWit activation period, there was a rallying cry from a lot of users like, win SegWit, win SegWit, win SegWit. And that was fine because I've seen developer teams at multiple different multisig companies implement SegWit version of multisig with a handful of developers in maybe 1 or 2 weeks. And it's straightforward. Really, it's like from a script perspective, it's pretty much the same as doing old school legacy P2SH. And so now, what we're seeing, of course, is users with the rallying cry, win Taproot, win Taproot, win Taproot. And unfortunately, it's just not the same straightforward path as we'll get into with a deeper dive here. This additional flexibility that Taproot gives us is great. But whenever you have additional flexibility, take, for example, extreme example of like EVM smart contract style languages, that extreme level of flexibility creates a huge design space. And when you have a huge design space, that means there's also going to be a lot of foot guns and ways to implement things poorly. And we want to prevent people from running into too many pitfalls.
Right. I think you captured that very nicely, Keith. And why I'm here is that we had this discussion earlier with Jameson and other people from Ancient Capital that we want to get into the room together and try to figure out what are the best options for everybody. I mean, the organizations that need multisig for their businesses to thrive, and hardware wallets creators so they can be used in this complex setup. And it wasn't very straightforward to see which options to choose. And what I really like about Bitcoin in general, that there is this not this approach of design by committee and everybody's just using what the committee came up with, but there are these discussions. And one of these discussions is happening right now. So, yeah.
Yeah, and the result will probably be just a list of new BIPs and proposals, and yeah, so will just grow.
Yeah, and I think I'll add to Keith's statement. It would be nice to have a BIP in theory. In practice, just the process of going through drafting a BIP and getting consensus from all the different stakeholders would have taken a tremendous amount of time with no clear path forward. I think any BIP that we would all come together on, even if we were all in unanimous agreement, would be status informational. There are several different ways to skin this cat, and I want to dive into that now, actually. I'm thinking first off the trade-offs that Jameson, you must have been thinking through at Casa versus Ali with Lightning. For those of you, I mean, it's easy to think of Lightning as payment channels and a gossip network, but at its heart, it's multisig. It's a construct between yourself and your counterparty. Casa is the same way. You've got your customers and you've got Casa. I'm interested in talking through the different trade-offs that you encountered and the migration path, because you both have existing products and existing customers using multisig. How you envision the path forward for them and enabling Taproot for your users.
Yeah, so Lightning, you're essentially getting a 2 of 2 multisig smart contract, and these are generally between two different parties. Obviously, one party on each end of the channel, and it's a highly interactive type of protocol. You're generally expecting the other end of that channel to be available and communicative, and so you can send messages back and forth with each other. However, in a vaulting solution, something that's more cold storage, where you're going for an extreme level of security at the expense of convenience, then you can't really have the same high level of interactivity. Basically, when you have more interactivity, that means you're probably going to have to be going back and forth between either the different entities or just the different key holders in that particular vault. So one example of a problem that we would run into with interactivity and a larger multisig quorum, say something like a 3 out of 5 or higher, is you may not know when you start to sign a given transaction which of the other keys are going to be participating in that transaction. And if you don't know which keys are participating, then if you start going down one of the potential design paths for TapScript, which is trying to be more efficient and more private and creating all of these other logical branches, you have to know exactly which one of those leafs, like all the way down that logical path you're going to be going, because you need to be signing that data, and all of the keys need to be signing that exact same data. So if you change your mind after signing with 2 of the keys, now you're in a lot of trouble, because you now have a partially signed transaction that's not going to become valid. You have to go back, start all over, and get that different TapScript path, and sign with however many keys that quorum requires. So that's just one of the potential considerations, which it's not going to be a problem for something like Lightning, because if you have to start over again, it's not a big deal. We're talking milliseconds, maybe seconds of lag time.
Yeah, exactly. As you already mentioned, the situation is pretty given in Lightning that you have these 2 parties that communicate anyway. They're supposed to be online to establish the channel. So you can just add this nonce exchange, a few new messages, or maybe not even new messages, but just new data in existing messages, and you can come up with music multi-signature pretty easily. In fact, there are already quite concrete proposals out there, either mailing list posts or even pull requests to the Bolt. Oh, sorry. Yeah, okay. So there are pull requests to the Bolt spec, and basically the decision to go with Music 2 was an easy one. So there are a few places in Lightning where this can be applied. The most obvious one is the 2-of-2 multisig for the funding transaction, but there are other signatures in the protocol for the gossip, for example, and also some of the revocation paths could be music2 setup. And there, I guess the main goal is to get some additional privacy, because you no longer have to reveal what keys were participating, and you also get a nice benefit in the size. So for example, in Gossip, there are currently 4 ECDSA signatures that could potentially be cut down to 2 or even a single one, depending on the use case. Yeah.
So what I'm hearing from you, Jameson, is the liveness and availability and coordination issues made Multisig not the preferred option for you. Whereas since these aren't an issue necessarily for Lightning counterparties, Multisig made a bit more sense, right?
Yes, exactly.
I had a whole thing about how the other consideration with Multisig was that it hadn't been standardized yet, and this morning a Multisig2 draft BIP was submitted, so that's out the window. I guess we'll have to review it after we get off the stage.
Yeah, and that's basically it, how the Lightning development stage looks like. It's basically waiting for music to be finalized, waiting for music to be implemented, and then I guess things will move forward from there, yeah.
Mm-hmm. And I'm curious, Pablo and Keith, did music factor into your software development or hardware development plans at all from the start? Did you decide to take a different route when you were evaluating things?
Yeah, maybe I can start. We had this discussion with Jameson, and he already hinted at it, that the main problem with more complex schemes is interactivity, and the problem with the hardware wallet is this usually offline, and it can be connected for a limited amount of time. And if something goes wrong with the setup, maybe you just change your mind and you want to use different set, then you need to start again. And especially if your hardware wallets are not located in one location, but they are spread around the world, then this might become a problem. So the most straightforward option is to use the simplest OP checksig add using K of M keys, which is like a straightforward upgrade from what we've been using earlier. And the other option is to use second option described in the BIP 332 document, which describes how to use several K of K multisigs, but then you have to choose which K of K setup you want to use, and then there are a lot of user experience challenges. So if the setup is too complex, you need to present it in a way that the user understands what they are choosing from. And also, again, if you change your mind, you need to start from the beginning. And there are also ways how to use music, and there were other implementations of music that uses deterministic nonces, and this also was an option. But it seems the world is getting into music2 option, which still can be used with hardware wallets, but under certain conditions. For example, if the hardware wallet is the last signer in the chain, so it sees everybody else's commitments and signatures, that it can participate, but that's not probably the use case for businesses like Casa, where somebody needs to start the chain of signatures. So yeah, these are the considerations.
Well, I think at the end of the day, the hardware wallets are going to have to support all the options. We may be able to prioritize on the easiest, which is replicating the K of N world, in the TapScript world, but that's the least satisfying option. I mean, that's just taking what we already have and just doing it a slightly different way, but not really getting any of the benefits that we were all excited about for Taproot. Like for Seed Signer, the goal is always optionality. So we don't have a single user in mind. We don't have a single use case in mind, and I think that's probably likely for all the hardware wallets. So while we will have to prioritize which approaches we support first, I think in the long road, we just have to support all of them. And there's no free lunch. Like, if we want some of the benefits, there's going to be a part of the user experience that's just worse, just because of the nature of it. So, like between Seed Signer and Spectre Wallet, with this discussion of picking the right K of K path for this option 2, we could have the wallet software send all the paths that you participate in, and you just sign all those paths. But if that takes 2 minutes for your little $50 device to sign, and then on Seed Signer, you have to hold it up to the camera because it communicates over QR codes. So like, if I need to show 500 QR codes back to my laptop, I'm going to get a tired shoulder. But if that's the way to do it, that's going to be the pain. But it'll be up to the user to decide that that level of pain is worth it for them. And then the same thing with Multisig, where if your seeds are buried in different countries, and you need to do 3 rounds, like, I either get a lot of frequent flyer miles, or that's not the best use case for that approach.
You touched on something there that I want to dig into, if you don't mind. So theoretically, Seed Signer, Trezor, they're both hardware wallet devices, hardware signing devices. But under the hood, you're running on top of a Raspberry x86, and you got a PCB and a bill of materials to worry about. What's the difference between the software development lifecycle and hardware development lifecycle, and what impact did that have on your implementation of Multisig on Taproot?
Yeah, so at first we thought that the CPU power might be the limiting factor, but it seems that's not really the case. We use USB communication, so we don't have to deal with the problems with, like you mentioned, with the stability of the QR code transmission. And so that's why we can focus mostly on the usability side of things, how to present it on the computer. Sorry, and I got lost in train of thought. So can you please repeat the question?
Sure. So Keith gets to run his code on x86 standard software. You actually have to get printed circuit boards and bake your code into silicon and deal with a supply chain that Keith doesn't have to worry about. I'm wondering about the trade-offs that both of you had to deal with when choosing what method of Multisig on Taproot to implement, and the shift time between when you made the decision and getting it in the hands of your customers.
Yeah. So like I said, we initially thought that this might be an issue, but in the end, it turned out that that's a non-issue. That even our processor that is maybe 10 times slower than Raspberry Pi still have plenty of power to do that.
So this doesn't require an addition to the hardware itself. It's also just the firmware that can, like, music can just be implemented on top of the existing hardware then.
Yeah, and also we have this advantage that we can ask for the data again and again and again. So the memory limitation is probably not that big of issue, because we can stream the data, hash it, maybe compute a Merkle tree, and then if we need it again, then we ask for it again and compute the Merkle tree if we were served the same data. So we can circumvent that problem by asking it again, which is not a problem since we are using fast connection. On the other hand, you at Seed Signer don't have the problem with RAM because you have plenty of RAM, so you have other things to worry about.
Yeah, we're running on what used to be a $5 Raspberry Pi Zero, and now they're impossible to find in the market, so sky's the limit for what they cost on eBay now. But we're also looking to expand to alternate hardware profiles, because if you can't source a Raspberry Pi Zero, you can't build a Seed Signer. So all the work I'm putting into it, isn't helping anyone. And I don't think our approach to Taproot would affect our hardware choices. I think it's more that the hardware that we end up supporting will affect the user experience. And if you're a user that can only source like a really weak chip that we support, then you'll just have a bad experience. You'll be waiting a long time for computation, but it'll work. And I think it's just, like I said, optionality. If you can buy the Cadillac processor, good for you. If you can't, it'll be spinning a little while longer.
I guess kind of related to hardware, have you played around with, or are you familiar with like what are the actual bandwidth limitations when it comes to the animated QR codes? I'm sure like the quality of the screen, the quality of the camera. I mean, a screen is only going to be able to refresh so often.
Yeah, so, and it goes in two directions. So far, the Raspberry Pi camera has proven to be really good. So Inspector, for a big PSBT, it shows an animated QR code, and however many frames it takes, it reads in the animation. But to prepare for doing demos today, I printed out the QR code as a single static image, and so it's much bigger. It's like I don't even know how many QR blocks across it was, and the Raspberry Pi camera could still scan it in. It was like a 1 of 2 spend to 3 recipients with change coming back and 2 self transfers in this PSBT, and it could scan it. But then the problem is crappy laptop cameras. The built-in cameras are garbage, and so we hold up this little 1-inch screen to the laptop camera, and people are just like trying to find the right focus distance. And before we had a brightness adjustment, the only way I could get my brother-in-law to scan the screen was to hold a pair of sunglasses in front of it to cut down on the glare,
Cool.
and that finally worked.
Yeah.
I took a picture of that and tweeted that out as kind of a, at least we got it to work.
I remember we had the same issue when we were trying to show the QR code on Trezor, that the contrast of OLED display is just so high that these crappy cameras, they just can't focus on it because everything is just so blurred. So one of the ways how to fix it is actually increase the brightness. So I assume we were doing the same thing.
I mean, the solution was instead of rendering white and black QR codes, we render shades of gray and black. So that's a lower contrast.
Yeah, it's a similar approach,
Yeah, so I mean, multisig is obviously more complex than single signature. A couple of years ago, I did a number of tests on different hardware to see like how well it could handle not only just multisig, but like really, really absurdly large multisig setups and transactions with many inputs and so on and so forth. And now what we're talking about today is just ramping up the complexity, potentially even by orders of magnitude if people start to get more creative. So you can only imagine like where we're going to start to see bottlenecks, where we're going to see parts of the user experience start to kind of crumble under larger data payloads, more computational complexity. And it's actually kind of funny because in the grand scheme of things, we're still talking about fairly tiny Bitcoin transactions. Like compared to most other computing, general internet-related computing stuff, this is a drop in the bucket. But it's still, it's reliant upon so many other moving pieces that something is probably going to break.
You just touched on something that I want to dig into with both you and Ali, actually, which is that multisig, one of the great benefits of it is that it provides users with peace of mind. You remove a single key from being a single point of failure. So the thing is, if you've got a working multisig setup, if it's not broke, why fix it? I know a lot of your users are asking you when Taproot. I'm sure you're asking yourself, why Taproot? And what's the path forward? How do you get from here to there? Let's talk through how you work through those decisions.
Yeah, so we've been evaluating, and in the perfect world, our users would have access to using Multisig and basically have aggregated signatures so that from an on-chain perspective, you would have the best level of privacy. You would also have the smallest on-chain footprint, which is also going to have lower transaction fees. That aggregated signatures is like the holy grail, I think, for any multi-sig type of setup. But because of some of the aforementioned reasons, we don't really see a straightforward path, at least in the near future, that is going to allow us to retain the same user experience and be able to add all of these other benefits. So we prioritize security, of course, above pretty much everything else, and then we're generally prioritizing user experience. And then the things like better privacy or smaller on-chain footprints they're nice to have, but it's more important that people can be confident that their money is going to be there and is going to be accessible than that they might be able to save a little bit on fees or have better privacy against certain surveillance actors on the network. So I think it's most likely we're going to be going forward with the naive way of basically re-implementing the current M of N check sig type of functionality just because of simplicity. And simplicity, the KISS principle, keep it simple, stupid, that's how we prevent as many foot guns from getting introduced. And I, as a wallet engineer who have seen many people shoot themselves in the foot over the past decade, that is what I'm generally more afraid of than I am of various types of attacks and people stealing Bitcoin.
Ali?
Yeah, I actually have a huge respect for the challenge of doing that in a hardware wallet setup. So I see how much complexity that adds. So on the Lightning side, it's comparatively easy, and as I mentioned before, the plan is more or less laid out. There are many steps to go to a fully Taproot, Music, PTLC enabled Lightning network. But the main challenge there is probably that because there are so many steps and you touch the same code so many times, it will take a long time to get there. And these upgrade processes with compatibility, backward, forward compatibility will just be a lot of effort. But the advantage is that the user experience doesn't really necessarily have to change because, as I said, that the communication is already there between the peers. So the user basically gets free upgrade in terms of better privacy. You can't actually see the public keys anymore, cheaper transactions because the signatures are smaller, and also less traffic on your node because fewer signatures are sent on the gossip network. But yeah, to get there, it will be a multi-year journey, and we'll probably learn a lot of things on the way, and maybe something that we think now we'll do in a certain way, we'll do completely different because we're just collecting experience with these new protocols, and the design space with Taproot and Music 2 is so huge and large, and I mean that's why we're here. But fortunately, as I said, in Lightning the plan is more or less there, and now just need to attack it and actually start implementing, and that's a pretty exciting phase, to be honest.
Yeah, I mean, I think in general, you should expect that all Bitcoin development, not necessarily just protocol level development, but even people building on top of it, they're going to take a measured and conservative approach because this is financial engineering. You should really approach it similar to something like aerospace engineering, where it's a mission critical system. And it's more important that you are methodical in how you go forward, evolving, whether it's the protocol or the wallet software or even other layers on top of that, because one mistake can be catastrophic, and we want to avoid catastrophe.
Okay, I want to talk through how Pablo coordinated with everyone on the different options for how Multisig would be implemented on Trezor and what the pros and cons for each of us would be. But before we do that, you raised something, Jameson, that I'd like to dig in with everyone, which is foot guns, potential gotchas or booby traps with the new implementation. Was there anything that jumped out at you when you were reviewing the BIPs and talking to the standards that you were wary of or concerned you, whether it's let's say, seed phrase recovery or whether PSBTs and descriptors were adequate to handle the new multisig construct, anything at all that jumped out and said, hey, I have to think about this, there be dragons here?
Well, I gave a whole talk at MIT a few years ago, which I believe was focused on what I consider to be one of the bigger foot guns in the design space, which has to do with recovering wallets. More specifically, it has to do with how do we describe the spending conditions for a wallet. And I think everyone in the room is probably familiar that you have a seed phrase, you keep that backed up, and you can always recover from it. That's all you need, right? Maybe a derivation path, maybe a script type, but really if you have the seed phrase, you should be okay. Like you should be able to figure out some of the other parameters and essentially like even have to semi-brute force recovering your wallet. I've done that for countless people. It's not too difficult to do. However, if you start creating non-deterministic script locking conditions, by which I mean putting like random or semi-random numbers or other data. The most specific example of this would be like time lock related data into your scripts. How are you going to be able to recover that? It's no longer data that can be deterministically like re-derived from a seed phrase or really anything else, or at least nothing that we have a standard for. So wallet descriptors, I think, are a great path forward and a standard that I hope that all wallets will eventually adopt. I think only a handful of them currently support importing and exporting those descriptors. But wallet descriptors are not necessarily enough unless we all agree to like only use the current wallet descriptor language and we never evolve it any further. So while we hear, I think, fairly often from customers asking for things like, can you help me time lock my coins? I want to do like a 20-year trust or whatever, make sure that I'm never, ever going to be able to be afraid and like panic sell or anything like that. And it's an interesting idea. However, I think when you start analyzing it from a security perspective, it actually has a number of downsides. And one of those downsides is how do you recover those funds if you don't know, the exact locking conditions? So I don't know, maybe we even need like another V2 of wallet descriptors or a way to describe semi-deterministic data. Maybe you could have some sort of script template that says, okay, I'm going to do time locks, but I'm going to minimize the design space. I'm going to minimize the potential values of those time locks so that you could kind of grind all of the possible values, in a few seconds on a CPU and be able to find, I guess, the right path to recover your coins. But like this is a whole potential area of exploration that I haven't really heard anybody even talking much about.
Yeah.
Yeah, so first let me talk about how we implemented the protocol in Trezor. Like, obviously, if you want a hardware wallet, you want to connect it to a computer, and Trezor was created in 2013. And we came up with our own protocol because it was years before there was such things as wallet descriptors or PSBT. And part of that protocol was also Multisig protocol, which worked out for us. But then the other hardware wallets came out, and they came up with their own protocols for single sig and multisig. And for single sig, it's probably not that of issue. But for multisig, you don't really want to have a multisig wallet that has to speak like 4 different languages if it wants to communicate with 4 different hardware wallets. So then when Andrew implemented PSBT to create like Esperanto of these hardware wallet languages, and slowly it got improved by the PSBT version 2, which removed some of the flaws that PSBT version 1 had. And when the Taproot got activated, I just had this urge to talk with people at Casa and Ancient Capital. Let's get into the same room and try to figure out how to do multisig so everybody can use it and we don't repeat the same mistakes that we did in the past, that everybody invented their own protocol and their own ways how to use multisig. So that's when discussion started last year. And we came up with the idea that already we have mentioned that first, let's start with this naive way, then consider implementing K of K, but then you would need to share which subtree do you want to work with. Unfortunately, PSBT version 2 has a way how to communicate and share that. And I think that's really the way forward. Of course, we would need to improve the wallet descriptor language as well. And there has been some unofficial extensions as well. But I think it really makes sense to have a lot of discussions in that area as well. Because ultimately, we are balancing this security, usability, and privacy things. And we cannot compromise on each other if we are going to forward. So yeah.
I think that is a good example of like why standards are helpful, at least from a developer standpoint. Any of us who are building wallets and also want to support as many of the hardware key management devices as possible, it was a lot more effort for our engineers to integrate the Trezor's own API and Ledger's own API and so on and so forth. And these days, with new hardware devices coming out that already support PSBT, that already support the animated, the UR spec, we've already done it. So like, there's almost no work for us to do when we're going to add a new device now if they're supporting those standards. And that makes it a much more tenable proposition for us as a company to add support for these things, because we no longer have to ask ourselves the business question of, well, are enough people going to use it that it's worth the engineering hours and so on and so forth. So this is I think it's great for all companies in the space. You adhere to the standard, you're more likely to get adopted.
Yeah, so maybe we have a chance to actually get adoption across a lot of devices faster, because we already have something like PSBT and PSBT version 2, we just now need to find out how we call these new fields, what they contain, and find consensus on that. But at least like the transport protocol, you could call PSBT, is there and is in use and shouldn't really fundamentally need to change. And also on the libraries are there, so I hope at least on that front we have some head start.
Yeah, and from the software side for like Spectre Desktop, it'd be great to initially offer the different flavors. These 3 approaches we've been talking about today. It's not the full-fledged madness flexibility of a full tap tree, but we could say, hey, do you want flavor 1, flavor 2, flavor 3? And at least in the beginning phases of this, like we all know what that means. We'll have, most or all the hardware wallets can support those different flavors. But then beyond that, if we want to support fully flexible, decide your own complex script however you like, as a Bitcoiner, it's hard for me to say this open source Bitcoin project should put limits on what you're able to do. Right? That just sounds wrong. That's not how we do things. But if we want to throw open the doors to full flexibility, it's going to be foot guns 80% of the time. So I don't know how to solve that problem.
Yeah, I mean, Casa is kind of the opposite in that term, because we intentionally do not expose quite a few aspects of the Bitcoin protocol to our users, because we decided that there's too much potential for something to go wrong. So I kind of see it from a software development standpoint, I see it as what we need to do. First, we have to decide on standards. We have to figure out what best practices are for various things, and then we need to build those into the software. And I see it as actually building the user experience as like guide rails of like because we're so deep into this, like we see all the pitfalls, but the average user, they haven't been in the space that long, or they just don't have the time to get that nerdy to think of everything that can go wrong. So instead, we build the software so that they can't veer off in one way or another, and like that is, I think, is the best way that we as developers can protect people, even in a system like this that values freedom, and along with freedom comes responsibility and comes the potential for screwing up. There's a lot that we can do to guide users on at least somewhat safer paths.
I think you can do that as a company offering a service, right? And you're trying to offer certain guarantees that you can support. But like I said, I think it's difficult for something like Spectre Wallet, something like Sparrow, Blue Wallet. If Bitcoiners want it to happen, it's open source, right? If we say no, fork the project, somebody else makes it happen. So it like I said, I don't know what's going to happen in the next couple of years.
Yeah, someone mentioned this morning in the context of Lightning, that there's always a phase of a lot of new possibilities. So the design space grows, expands, people are trying out stuff, and then at the later point you can see, okay, what are people actually using, what works, what doesn't work, and then you have this contraction and back to defining new standards. And it seems like we're in this expansion now because we have this kit of new possibilities, toolkit. We can just do whatever. But of course, if we already have some ideas what we definitely should and should not do, that would help as well.
So one of the things we've been talking about and talking around is the importance of building open source and building for our users and building towards a standard in the absence of a BIP. I'd like to actually talk through the nuts and bolts of how that process worked with Taproot and Multisig, because I think it'll be instructional for Bitcoiners in the future. This is not going to be the last time that we run into this issue where there's something that all these different stakeholders need to coordinate on and provide value to their users with in the absence of official firm technical guidance. For me, at least, it started with reviewing BIP 342, going through it and wrapping my head around TapScript and saying, well, okay, OP-check multisig and OP-check multisig verify are out. And I think about that time, I got a GitHub notification from Pablo. So take it away from there, Pablo.
You mean, should I recap what was happening from
Sure, just
from
do a quick from the top. Talk about, well, what were you thinking? What were your concerns? And we can talk through.
Exactly. So, so first I had the discussion within my team because there are people that are much better with cryptography as I am. So I was like telling them we should have a look how this music works and how these different schemes work. What are the implications? And at that point, we realized that the music, there are like several music standards, and we were a little bit confused because I always assumed it's just one thing. And then we realized that there are different caveats to each other, and some of them were not being developed anymore. And then the music too was, it seemed like it's the way forward, but it was not finalized at the time. It was just finalized yesterday, I thought. Yeah. Drafted, sorry. So as you can see, there were a lot of moving parts, and we didn't want to be the one to say, all right, we are going to go this path forward, because ironically, we don't even have the multisig in our product. I mean, the Trezor suite, we just support multisig on devices because we want Trezor to be used in institutional organizations. And that's when we realized we should have a discussion with Jameson from CASA and technical guys from Ancient Capital, because ultimately this is or these are the environments where Trezors are being used in Multisig, and we wanted to know what were your thoughts about it. And we already had this hunch that interactivity might be a huge problem, but at the same time we wanted to hear if there is any solution we are not seeing that.
And at that point, I think it lands on Jameson's desk. Jameson, take it from there.
Yeah, well, whenever we get pinged by hardware manufacturers about potential changes, you always just freeze up for a second, especially because as a multi-vendor, multi-sig wallet software, we have a lot of different dependencies. And as I alluded to earlier about now it being a lot easier to add support for new hardware if they're supporting the standards, there are still additional complexities where once you're taking on the maintenance and support of that hardware, if anything changes about how it just operates on a regular basis, then you may need to make changes just to remain in compatibility with it. So we were wanting to make sure that we're all on the same page, and hopefully, a worst case scenario would be like if Trezor decided to go down one standard and Ledger did another and Coldcard did another, and because then we would be kind of reverting back to now having all of this conditionalized logic on our end that's going to be even harder to maintain. So always happy to work with people just to try to keep some semblance of sanity.
I also feel like this is a little bit of an easier challenge to tackle. Like you said, like what could we learn from this for future coordination issues? I feel like if you put 20 Bitcoin engineers in a room, it'll be fairly straightforward to agree, like, hey, these three options make sense. This level of priority makes sense. Okay, maybe the priorities are different for the Lightning case, but it just doesn't seem like there's anything hugely controversial about putting your flag in the ground.
Yeah, and I mean also, I think there may have been some questions early on of like, do we need to actually do a BIP? Do we need to write something formal? And I don't think this really rises to the complexity that's required for something formal. What we're almost really more talking about may turn into something in the future, maybe like sort of like script templates or best practices for common use cases, common Bitcoin scripts. I could see that becoming a thing if we start to see a lot more crazy experimentation where it's only a matter of time before some people do some really awesome but ultimately stupid things and lose coins. Either they get stolen or more likely they get locked up in perpetuity because of some poorly constructed script. And that's great because we're going to learn from those experiences, and hopefully they'll get incorporated into our kind of common knowledge and best practices. And then perhaps if this space, this design space, continues to evolve, then we'll get to the point where it will make sense to have maybe a better version of wallet descriptors or just a sort of library of recommended script templates. I mean, it's kind of like hearkening back to the whole like EVM smart contract space. They have standardized some of their like more common types of smart contracts there because their design space is so hugely complex that there have been innumerable catastrophes. And if you're going to roll your own smart contract, that's almost as risky as rolling your own crypto. And that's kind of what we're talking about here when you're constructing more complex scripts.
Yeah, almost have like a taxonomy classification. Like here's our basic script. Maybe you fiddle around the edges with it, but we kind of understand that species of it, and then have the other species documented, and at least to give a kind of a common language and a starting point.
Mm-hmm. Yeah, I really like the idea of sharing these, best practices, because there is a lot of work being done, but not shared, I would say, and a lot of experience didn't just somehow, die somewhere. And I think this is something that should be really done.
So we have less than 4 minutes left on the stage, which is a shame because I really want to grill Ali on Multisig 1, Multisig 2, and Multisig DN just for my own benefit while I had him cornered. But instead, I thought, why don't we go around and share what you're most excited about Taproot Multisig and what you're most, I don't want to say concerned about, but what you've got your eye on, the good, the bad, and the ugly.
So just also catching up the previous question, what our plans are or how we approached it. So basically we have in L&D a bit of a different situation because we're not going to use the SecP 256K library because we need everything to be in Go for the reproducible builds. So we went ahead, Lalo went ahead and actually implemented the whole Taproot validation in BTCD, which we use as a library in L&D. And then he also created a PR for the Music 2, which, was by our draft now. And then we went ahead and end-to-end integrated these functionalities into L&D and offered them as an RPC to the developers. So with L&D 015, it will be possible to use tab scripts, sign for tab scripts, and also Music 2. So we want to put this toolkit into as many developers' hands as possible so they can also try out and then help formulate these standards, because we might just not know yet what these standards all will look like. So that's why I'm very excited about Taproot, because we can actually give it to a lot of devs in a very hopefully touchable manner soon.
Yeah.
Well, one potential construction that I've been thinking about for a while is kind of building escape hatches. Like we said, you can create this arbitrarily complex tree of logical branches that you can go down to figure out how you want to spend your coins. Well, that means that now you're no longer locked into a single security model or architecture that is just like, these are the keys. Instead, you can put in conditions that will only activate in other conditions. So like a relative time lock that's like, if several years have gone by and these coins haven't been spent, then perhaps we'll activate some other spending conditions. And it's both exciting and scary of how you might be able to screw that up or make your security worse. But I think that there probably is a safe path to go down there to give people some additional peace of mind and other ways for them to be able to recover from certain catastrophes.
I'm going to piggyback onto that for my one good thing and one bad thing. The good thing, I think, is what I'm looking forward to is increased privacy. Right now, it's a little bit too easy to look on-chain and differentiate a open Lightning connection or a Casa multisig or an Unchained multisig. The idea of having the happy path being completely indistinguishable from any other transaction and the escape hatches, you called it, being more visible, at least for now, when CISA. That's really what's most exciting to me. What's concerning to me is the same thing that you raised. This is aerospace engineering. If it's not broke, why fix it? We have a tremendous duty of care to our customers to make sure that funds aren't lost, that they're not just getting the most benefit out of the latest technology upgrades, but that they have the same peace of mind and security and stability that they were able to depend on from OP chip multisig verify.
What I really like about what's happening right now is that this opens so many new options. And like you said, the design space is so great, so great that a lot of people are now thinking out, all right, so if the design space is so great, so how do we work in that new field? Because earlier, when these updates were incremental, it was like, all right, so I just changed this little small thing here, and now it works out. For example, we had these XPubs, which didn't encode how you should derive from them, so we came up with different prefixes. But now, like, this doesn't really make sense because it's so much more complex, so the wallet descriptors were created, and we can't afford to do these small steps anymore, and we just need to hold back a little bit, back to the drawing board and design new standards, how we could effectively operate in these new options that we are working on. And PSBT2 is one of such things as well, because we have to start doing things right, because the monkey patching is not helping us anymore.
I'm just looking forward to the UI challenges.
Yeah.
I've spent the last 3 months trying to explain Bitcoin to a potential new user on a 1-inch seed signer screen, right? Like, what information do I need to convey? What can I hide? How do I explain it? And I think the complexities that we've all been talking about, both having the UI on something like the Spectre desktop side, and then how that talks to and what you see on screen on your hardware device, I think it's going to be incredibly difficult and just tons of fun.
All right, and that is well over the time we have. I want to thank all of our panelists, Keith, Jameson, Pavel, Ali, and I want to thank you, the audience. You've been great.
Maybe you should clarify. Hi, I'm Peter Todd.
Hi, everybody. So this is a panel on preventing attacks on Bitcoin, and we have a nice group of people here with us. Luke Jr., the infamous core dev, Bryan Bishop, the former CTO of the bank, as he calls it, and Jameson Lopp from Casa.
The real Peter Todd.
No, okay, we'll stick with Peter Todd, infamous troll. So I guess, to start, we're going to talk a little bit about the development process of Bitcoin Core, obviously as the foundation keeping all of this running and working. There is potential for shenanigans there, and arguably past examples with things like Gavin Andreessen, Mike Hearn, and the whole Bitcoin XT block size wars that culminated in 2017. So I guess to start, go this way, and what are each of your thoughts on a way where you could see somebody involved in the development process kind of trying to pull a fast one and make things go wrong?
Well, we saw it last year when the Bitcoin community had decided to go with BIP8 to deploy Taproot, and then some developers decided, no, we're going to do speedy trial instead, and basically ignore what the community had come to consensus on.
So if that wasn't clearly audible to anybody, you're talking about the speedy trial deployment with Taproot last year and the complete refusal to consider BIP8 in the deployment?
Especially after the community had already come to consensus on it.
So kind of like arguably developers stepping away from community consensus, arguably, and kind of doing their own thing in defiance of that?
Right.
Okay. Bryan, what's your best brainstorm on how to kill Bitcoin?
Well, in the development process specifically, I'm quite interested in deterministic builds and build signing and things like that. I think that's a really interesting area for preventing some attacks on Bitcoin, certainly not all. But essentially the idea is that if you are a user of Bitcoin, you have to download the Bitcoin software somewhere. How do you verify that you're actually getting the real Bitcoin software? How do you verify that this is the one that everyone else is using? If you just download something from the first ad you see on Google, you might be getting something quite different from what everyone else is getting. So with both deterministic builds and also build signing, and specifically it's multi-party build signing, you're able to verify through techniques such as web of trust and others, whether the code you are running is actually the one that you think you are running. I think that's a really interesting method. If you don't do that, there are all sorts of interesting attacks that can be done against you. For example, you travel to a country, not the United States, you have a hotel, you have Wi-Fi, and you're downloading Bitcoin software. Well, if you are not using HTTPS, if you are not verifying hashes and signatures on the binaries that you're downloading, it is possible for attackers to intercept your connection and replace it with a version of Bitcoin that maybe steals your coins or does other nefarious things such as spy on you or something less drastic than stealing your coins, which are still problems. So that's one of the attacks I found on the development process particularly interesting.
Yeah, and kind of the whole point of deterministic builds is just you have each developer independently build from the source code what they assert is like the latest build, and everybody kind of just cross compares that and signs it so that you have all the independent machines used to build that software like cross compare, and if anybody has a result that deviates or something, like it's not just trusting one source or claim to something.
The fun part about that is knocking out areas of non-determinism in your build process. Because if you have something that changes based off of the environment that you're building on, for example, a different operating system or something, then the binary that you're going to generate at the end of the build process is going to be different. So you need to eliminate all the sources of variability in the build environment.
Peter Todd, how would you kill Bitcoin?
Well, I tell you how I'd kill Bitcoin. I'd sow discontent throughout the community, throughout the GitHub repositories. I would be so angry about every little thing that I would make people afraid to suggest even the slightest change. And then we would have to ossify, and we could no longer upgrade any of the protocols. So it would take a very long time, but Bitcoin would not be able to improve anymore, and therefore it would become stagnant, and people would move on.
Ossification, good or bad?
But I mean, that's defending Bitcoin. That's not attacking Bitcoin, Peter. That's defending it.
No, that is why it's the perfect attack, is because many people consider it to be a defense.
I mean, that kind of though ties into like Luke's concerns with speedy trial last year with the entire Taproot activation. I mean, how do you really ascertain in a situation where you have dissent, disagreement, and confrontation in the development process, like the difference between an attack on Bitcoin and just legitimate disagreement? Like, where do you draw that line? How do you assess that? And more importantly, how do you react to that? Like, if you can't really ascertain whether something is an intentionally malicious action, then you're kind of stuck in a rock and a hard place. Like, you engage in good faith and try to settle something that could be a dispute, or in your reaction, maybe actually inadvertently become the attacker yourself.
Can you steelman why you're saying speedy trial was an attack? Or Luke?
Well, I mean, Luke, if you want to take that one, or I'm just supposed to be moderating after all.
For the first part, it gives miners the ability to veto a soft fork, which has presumably already come to consensus within the community. And secondly, the community had already decided to move forward with Taproot with a BIP8 deployment, and the developers who were pushing speedy trial decided to essentially disregard what the community had already determined and come to consensus on, and just go forward with something else without even getting community buy-in.
That's right. We didn't actually start with BIP8 for Taproot, did we?
No, I mean, that's the entire process was really just arguing over activation once everything was finalized and nobody could agree. And I mean, to kind of throw the idea out here and how to mitigate that, if you view something like speedy trial as an attack, the potential for user-activated soft forks and the viability of actually coordinating that and hitting enough of a level of adoption that that's actually going to affect something. It's not just going to be a few people in the corner that everyone ignores. Like, what are your guys' thoughts on that going forward versus what happened in 2017?
Well, I mean, from your perspective, does an attack require malicious intent? Because I think in hindsight, you can certainly say that certain things were attacks on various principles that most of us hold dear when it comes to Bitcoin. But really, the problem was that just some of those attackers simply didn't hold those same principles.
Well, I mean, that's a sticky question. Look at Gavin Andresen. I mean, was he an intentionally malicious actor or just had a very different idea of where Bitcoin should go?
Well, has he disavowed the signature that he claimed was real? Has that happened or not?
I'm actually not sure. A lot of people just kind of quietly stopped mentioning that and didn't really come out and say they were wrong.
Well, that was an interesting attack. And you know, if you take the story at face value, the attack here was someone said that, hey, I can produce a signature for a certain key, and I'm going to prove it to you. And we're going to go to the store first and buy some hardware, and we're going to pick out a box on the shelf, and you're going to help there. And actually, I think part of the attack was that he was not there. It was just, hey, here's a new box of a new computer, a new laptop, and we're going to put in some software to do signature verification, and this is going to prove that I am in control of this key. Now, apparently, what happened was there was software that was installed on the laptop that actually, I believe it had a bug, a very subtle bug that when you look at the code and you're glancing at it, you're like, yeah, this is signature verification. But anyway, because of the way the bug in this code worked, the signature verification was always going to say, yes, it is a valid signature. And so that was a very interesting attack. And we haven't heard much since from that particular individual.
Yeah, I mean, I do believe that Thomas from Electrum actually checked the download logs from his server and found no downloads of genuine Electrum software when Craig supposedly showed this signature to Gavin.
Interesting. I didn't know he kept logs. Good to know.
Yeah, but I don't know. I think from a class of attack standpoint, it seems like social / mimetic / narrative have much greater potential, or at the very least, it's more difficult for me to reason about how to defend against them. It's a much bigger gray area, whereas we can talk about all types of technical attacks, and usually the defenses against various technical attacks are very logical and straightforward, but this much more fuzzy social attack vector is something you just sort of have to deal with as it comes.
You know, I was recently in Austin, Texas, going to some Bitcoin conferences related to like South by and everything. And I have to say, I was really impressed by the number of new developers that I met there that introduced themselves to me as anonymous developers. You know, they gave me their pseudonym, you know, and I asked them, oh, do you just use that? And they said, yeah. And the reason for that is, as a Bitcoin developer, maybe that's the optimal strategy. If people don't really know who you are and maybe you don't even attend conferences, maybe that helps protect you. Maybe that helps protect Bitcoin.
Yeah, that is something I hope to see a lot more of going forward. I mean, I know you wanted to kind of touch on this, but the insane litigation from people like Craig Wright, directed at a bunch of core developers, and the legal defense fund that Jack graciously set up recently. That is, without some kind of mechanism to finance legal defense against things like that, that could very easily just burn out and push developers out of this space, because are you going to want to be here and contribute to Bitcoin if you just have to burn money constantly to defend yourself against ridiculous litigation?
Well, that's an interesting point, because I think the the litigation against Cobra shows that even being anonymous is not necessarily protection against a legal attack. Well, you know, I suppose Cobra could have stayed out of the whole thing, you know, never touched any of the court orders or hearings or whatever. But at some point, I guess because they're operating a website, you know, that is a property that could be seized or otherwise
and
confiscated.
there's a name tied to it somewhere in the registrar, even if it's not public.
Yeah.
But I mean, yeah, like that is a huge way that I think you could slowly erode Bitcoin's ability to deal with, you know, the shortcomings that it has, like actually solve problems like privacy, scalability. If developers don't want to work on it because you have to worry about the crazy egomaniac just throwing millions of dollars at you in court, like that, you know, death by 1,000 cuts.
Well, that's partly the conundrum, which is Bitcoin.org, you know, is someone's property, and it's where people go to learn about Bitcoin. But at the same time, though, you know, maybe there shouldn't be a single place called Bitcoin.org where people can go learn about Bitcoin. But when you do that, the conundrum is suddenly there's all this room for fraudsters to attack people by saying, no, my website's, you know, the main Bitcoin one. Maybe I call it Bitcoin.com, for example.
Yeah, I mean, it's...
All I know is Bitcoin.page is the one and only official Bitcoin website.
Is that yours?
Could be anybody's.
Okay. I mean, you know, all of this kind of just keeps slowly sliding in the direction of like the social mimetic attack. Let's wildcard this and just shake things up. I'm going to ask you guys a question and hear your thoughts on whether or not this constitutes an attack, and if it does, like how do you think it should be dealt with? This growing narrative over maybe the last 2-3 years of Bitcoin isn't money. It's not competing with the dollar. It's just a financial asset or a collateral, and that's how people should look at it instead of looking at it as money. And like, is pushing a narrative like that an attack on Bitcoin? Like trying to just push and brainwash people into not directly using it, you know, as a native value transfer network, and trying to just keep framing this narrative and get people thinking like, no, you just park this somewhere with a custodian and get a loan against it in dollars. Or like, don't think about competing directly as a money or a payment rail. Just think of it purely as number go up, and that's it. Like, is that an attack?
I don't think I would classify it as attack. Even if you look at Bitcoin as money, that's just how these people are deciding to use or not use their money.
Yeah, I mean, I think it makes more sense if you're positive rather than negative about the narratives. So, you know, if you want yield generating asset or whatever, and that's your use case, then go for it. But if you start being negative and you're saying, no, you can't use it as a currency or as a money or whatever, I mean, the rest of the users on the network who do want that are just gonna ignore you, or perhaps swarm upon you on Twitter, you know, depending on if you're in the small minority. This is, I guess, the mimetic warfare and why social media can be a very negative place to hang out if you're trying to push views that are controversial. And they're going to be controversial if you're trying to tell people how they should be using Bitcoin.
So I won't answer your question, but I would say that Bitcoin has a very impressive social immune system that has been developed. And if you try to coerce Bitcoiners, try to change the protocol unilaterally, the immune system will spit you out and reject you. And that's just a really fascinating social phenomenon. You know, it's just really interesting to see that in process. It might actually be one of Bitcoin's great assets, really, is this just layer, this immune system of people that defend Bitcoin voluntarily, you know, and they're not coordinated at all. But it's all people who believe in Bitcoin.
is it an attack on Bitcoin to donate $5 million to Greenpeace with stipulations of exactly how it must be spent in performing a social narrative?
Yes, I would say so. You know, that's actually, if you want to get into that real quick, the last couple minutes, I see the potential for that very quickly to spiral into government lobbying.
Sure.
Legal bills, regulations, and you know, that kind of gets into a sticky territory of mining isn't just, you know, a couple GPUs on a rack somewhere or a laptop. If jurisdictions really just start dominoing in, say, the West and, you know, enforcing heavy regulation or attempting to outright ban mining, it's not that simple to just take that off grid and disappear, to do that in secret. I think it was a Chinese group of researchers, but I actually saw a paper last year. We're just looking at the modulation along the power lines from the grid to your house. They can see that you're running an ASIC just based on the unique signature of that over the wire. So how would we react in that type of situation?
There could possibly be a lot of mining. We're already on solar, not exposed to the grid. And if it got really bad, there are other alternatives like so-called optical proof of work, which may possibly be harder to detect on the electrical side.
I mean, does anyone up here on stage actually think we could pull off a proof of work change? Get consensus on that?
No, it's the current proof of work isn't working.
If the situation was dire enough, I think we could do a proof of work change. If the whole chain is halted, if there's some sort of catastrophe, if SHA-256 is broken, I think we could come together to figure out a solution. But it's hard, and you know, it's very unlikely that that would happen.
I mean, you have the problem of even if we wind up with consensus that something's wrong with SHA-256, then what do we replace it with? And that's the whole next can of worms.
Obviously, a quantum-proof algorithm that will make everybody happy. You know, there's going to be challenges over the long term. I'm sure there will be some insane attacks or just, you know, weaknesses that become uncovered over the decades. You know, kind of, I was joking about the quantum computing stuff, but it is likely that at some point in the far future, we will have to have discussions around what to do with the really, really early pay-to pub key coins, and like whether or not they should be somehow like protected, or whether we should just consider it to be like a new form of mining if people start to be able to crack them. You know, it's an interesting long-term issue. Uh-oh.
Uh-oh. Did the mic die?
You might also note that it's not just the very old pay-to-pub key coins anymore. All the new Taproot coins are also similarly affected.
Well, I mean, honestly, I don't think that should be looked at any differently than an exchange hack. If somebody gets those coins and they're able to confirm them in a block, that's really a fundamental, you know, quality of Bitcoin to go tinkering with, just because of being nervous that these many coins were just acquired by some nefarious actor.
That's fine. We'll find them when they start publishing their rap videos about how gangster they are. Seriously, check them out. They're awesome.
But that's why it's relevant that it also affects Taproot coins, is that this could potentially be nearly all the coins on Bitcoin at some point.
Well, you know, actually, back during the discussion on Taproot design, I was very hesitant when that first got pitched, just the raw pub key, But the reality is when you look at on-chain address reuse, and then also think about the fact that any kind of light wallet, yeah, I mean, even if you have a wallet you're connecting to your own full node, like there's still some network communication that could get played with that's just passing the master pub key back and forth in most wallets cases. So in some way or another, most coins already do have their public key exposed, either through address reuse or just the balance fetching mechanism on the back end.
But it's fundamentally different from an exchange hash where it's just a minority of coins that are affected.
But I mean, if you still have your coins in a raw pub key output from 2009, 2010, and you're not moving them at some point, those coins are lost. Those people don't have the keys anymore.
Possibly, though you never know what assumptions you may make. Though, kind of going back to classes of attacks on Bitcoin and related to this, is it an attack on Bitcoin if you build a wallet that intentionally does not follow good practices? Like, there are still wallets out there that are only one single address. They won't even do deterministic address generations. And thus, all the money keeps coming in and out of the same address, thus exposing the users to this issue.
Well, it's definitely an attack on Bitcoin users.
Yeah.
Mm-hmm. But didn't we decide backstage, though, attacking Bitcoin users is attacking Bitcoin?
To an extent.
All right, so I guess we're down to the last 20 seconds. Anybody have some smart-ass comments? Your one trick to guarantee Bitcoin's invincibility?
Bitcoin is the greatest bug bounty program of all time. Good luck.
All right. Cool, all right, clock started. Hey, my name is Olaoluwa, so you know me as Roast Beef. I'm the CTO of Lightning Labs, and here to talk to you about Taro. A few different Taros, so we'll get into kind of like this Taro, the one that we released a little bit later, and then kind of go from there. Try to explain kind of like the high level exactly what it is, the motivation, how things work, and also kind of like how it's different from other solutions. But now we can get into it. I don't know if the slide is clicking now. All right, boom. Here we go. So first, I'll kind of go into exactly what is Taro itself, how actors created in structures, and then kind of like how the transfers work, which is kind of like a bigger thing as far as the way it works generally, what a universe, and obviously the most important thing, kind of like how does it integrate with the light network itself, right? So the first, we'll start exactly what is taro, right? Here's the little shout out. So taro, it's actually a root vegetable with a taproot structure. It's eaten across many parts of the world, Africa, South America, Asia. It's actually one of the most like ancient kind of like staple crops going back thousands and tens of thousands of years. That biological is actually something from like the 16th century. It's a great source of manganese, potassium, and also fiber. So here, for the Bitcoin vegans, Bitcoin vegetarians. Actually, Nigeria is one of the largest producers of taro in the world as well too. On the right, you can kind of like see some different depictions. That's the actual taro plant. These chips here. And bottom right is something I eat, way back in the day. Like it's kind of like yam, what we call it in Nigeria, and egg. That's like a big meal, basically, like kind of like a very easy thing to do, and it's really tasty as well too. But I guess maybe you mean the other Taro, right? So what Taro is basically kind of like a new protocol we developed at Lightning Labs, over the past few months. What it is, it basically uses Taproot to kind of like allow individuals to issue assets, on the actual Bitcoin chain itself, right? And it does it in a cool way because, like, given that it uses the Taproot structure, whenever you see an output, you don't actually know what's actually, held in the asset itself. But also, it actually uses the Taproot crypt tree to basically allow you to commit to effectively an unbounded amount of assets in a single output, which is really cool. And one of the most important things, like the protocol is oriented, so it can actually be transferred over the Lightning Network, right? So for example, now I can in theory pay someone on Bitcoin basically with my own Lightning wallet. Maybe they receive, something like LUSD or USD on the other side as well too. So I think this is a really big step from kind of like, moving forward Bitcoin is actually, as far as kind of like Bitcoin being the massive project center for all of the other, currencies and assets of the world as well too. Because now all of a sudden, like everything is still Bitcoin at the center, but at the edges, people can kind of opt into these new protocols as well too. I think it's really going to bring, expand the network effects of Bitcoin itself, also bringing more and more people into Bitcoin, and also like allow them to kind of like, ease their way into. Maybe they're initially doing a stable coin, then beyond that they get into the core Bitcoin itself. But now let's start to dive into some of the details. So what is taro, right? So it kind of like has like a cool backronym, in addition to being, a nutritious vegetable. It's the Taproot asset representation overlay, right? So what's an overlay, right? So what we mean by asset overlay is basically it's based on something called embedded consensus, right? Embedded consensus. So rather than kind of like, including all the data exactly into the chain, like things like, Omni and counterpart, things like that, which kind of like goes to the chain itself, so we basically commit to kind of like a hash of data into the chain itself, right? And we say embedded consensus because we basically, okay, like we're gonna kind of like make up rules as far as how things work, and then interpret them and kind of like add additional validation logic alongside this as well too. So effectively, it's using Bitcoin, kind of like the most secure, decentralized blockchain in the world, as a publication system, basically, so that it commits the data to the chain that we interpret it ourselves. This is really cool because all of a sudden now we don't have to worry about double spends, or we don't need a consensus network, we don't need proof of stake, whatever else. We just use the Bitcoin as is today, right? And like, the one kind of like little trick, in Taro, basically, like rather than actually commit out to all the data on the chain outright, we actually instead commit to things in the script tree itself, right? And as you see in a little bit here, this is really cool because this kind of like has like a very nice structured commitment format, also allows it to be very extensible as well too. And so Taro supports two different types of assets. One is basically normal assets, like maybe things are divisible, so maybe these are things like cool points, beef bucks, or USD, Naira, whatever else. It also supports collections, which are kind of like like a limited edition, kind of like collectible asset. Maybe it's like a holographic beef start card, maybe it's a baseball card, things like that as well too. So you can basically do both of those things within the actual protocol itself, which is pretty cool. So people ask me exactly like, why Taproot? Is it actually needed for Taproot? Is it just like a marketing thing? It's actually, it's essential in my opinion, right? So something people had in the past, something called pay-to-contract hash, P2SH, right? And the way it worked, it basically kind of like you have like a key, then you have some data, and you basically, high level, you don't get lost in the math, or the easy stuff. Basically, kind of like commit to some data within a public key itself, right? This is really cool because the public key to a third-party observer looks like just like a normal public key. They don't really know what data is actually included with it as well too. So there was a paper, I think, by Timo Hanke in like 2013 or so, but it never really got used in practice. I think his use case is kind of like using it as like a receipt basically, where like you have like some like metadata, and you would use that metadata to derive Bitcoin address, and that would give you kind of like proof of publication. Never really came on as well too. But one thing about like doing something like this, just as far as kind of like P2SH alone or pay-to-contract hash alone, is that you kind of like intermingle the actual contract details or the asset details along inside the script itself, right? So let's say I was trying to commit to like metadata in the actual script. All of a sudden I need to kind of like have that directly off all my other scripts. That's also going to like bloat the information as well too. But the cool thing about Taproot is like Taproot kind of like gives us like a very structured commitment format, right? And like the way Taproot works is that like you can actually commit to several different things, but the things that you don't reveal don't actually need to be published onto the chain itself, right? So this is like, okay, like, well, what if we actually commit to other data within the actual Taproot tree itself? That's kind of like where the idea has been born somewhat, right? And the cool thing about this as well too, we can actually have like a separation of layers, because we actually have like a new asset script or kind of scripting language in the Taro system itself too. So first we have like Bitcoin script, and we have asset scripts as well too. This is really cool because, like, for example, I can have like an asset and maybe it'll require like a multisig or other information as well to actually properly move it. So it's definitely like a really cool way things are set up. So here's kind of like a high-level overview of the way things work, right? So it's basically this new data structure. I'm calling it new. Maybe someone has invented it. Maybe it's a Bitcoin token from 2012. I don't really know, but for now, we'll say it's new, right? So it's basically something called a Merkle sum sparse Merkle tree, right? And what a Merkle sum tree is, like, people have seen Merkle tree before. You kind of like have like a series of items. You hash them up pairwise, so you have like an initial root hash itself, right? But the Merkle sum property basically allows you to kind of like commit to what exactly is like a value, right? So now alongside like committing to a hash, I'm also committing to a value. So let's say I have like a series of elements that all have like a value of 1. The root of the tree commits to 4, right? Now all of a sudden I can say, okay, well, prove to me you have an element of the tree. You give me the actual hash of the data itself, but you also give me this value. Whenever I combine the proof up, I actually add that value alongside of it as well too. That's a really cool thing, because in the concept of Todd, we're going to be using this for things like, okay, I want you to prove to me that you have 5 beef bucks, right? You can basically prove that to me as well too. The other thing we use in Taro, this also lets me ensure that whenever we do transfers, there's not actually asset inflation going on, right? I want to make sure, okay, you sent me 5, you should have 3 left, right? You're not actually making anything out of thin air on the other side. Then the other part we have is a sparse Merkle tree. So this is kind of like another thing. Sparse Merkle tree is effectively like an index, over kind of like a key value set of data, right? So the way it works is like Merkle trees are kind of like a list. A sparse Merkle tree is basically a key value map, right? So what we do, we basically take a hash and we navigate down the tree going left or right depending on that 1 or 0. So if it's 0, I go left. If it's 1, I go right. And then we go all the way down 256 levels because it's 256-bit tree, and we get into like kind of like a unique location within the tree itself. This is really cool. The one other cool thing about sparse Merkle tree is the way it works is we can actually do like a very efficient proof of non-inclusion, right? So for in this case, like one other thing I skipped over just now is like all the elements are initially nil, right? So for me to prove to you that something's not in the tree, I show you a path down to a nil element, right? And that means, okay, well, it's not actually in the tree. This is really cool, because otherwise, if you're doing for Merkle tree, because it's actually like insertion ordered, I maybe would need to give you a bunch of other leaves aside and things like that as well too. The other cool thing about a sparse Merkle tree is actually history independent, right? Meaning that if you and I insert elements into a tree in like arbitrary order, we get the exact same root hash, right? So you can almost view it as kind of like being able to like maybe do like a git clone. I apply all my commits on top of it. We check the same head, and then we know things are correct like that. So this is how it kind of looks on the right over here. So in the top, you kind of like have my initial pub key with the script root. That's kind of like the way Taproot works. We have the regular Merkle tree, so you can kind of see I have like a hash for preimage, a delay or two, whatever else. Then we get into the Taro part, right? So the Taro part is actually now a series of other nested, sparse Merkle trees, right? So first we have the first level, and that's where we have like all the assets. So for example, I have 25 VBucks and 100 cool points, right? And so we'll have like kind of like an additional leaf for every single asset we have here. This is kind of where you get some of the scalability. Because if you look at other systems, whenever you're actually making assets, you need to kind of like manifest fully like a massive map of the asset onto the chain. So maybe you have like a million entries, you basically have a million items in the chain as well too. Maybe it's going to cost $100,000 to even make an asset in this case. But in Taro, it's basically one transaction. One transaction can move an unbounded amount of assets and also create an unbounded assets as well too. So once again, we're using this like very cool tree scaling property to amortize all of these transactions all into one. Then when we go to the next layer down, then we have like the actual, where the assets are stored, right? So that layer is now like using basically like a script hash or the asset key to store the individual values. So if you see that I have like, 10 VBucks and the 15 VBucks, and then when I hash those up, I get 25 as well too. And then the final layer is basically this like asset, tree or leaf TLV, right? So TLV is a format we made from the Lightning protocol. It's similar to like a protobuf. It's kind of like an extensible key value, system, so it's really cool from that point. And the way everything works is that like you basically need like an asset ID, right? So this is kind of like one of the tricky parts. I think we found a really cool solution to it. Typically in other systems, there's kind of like a global system, or maybe the contract system is actually aware of like a contract hash or an asset ID. But in Taro, we basically need all the asset IDs to be unique. So it's okay, well, how do we get a unique value? Once again, we basically use the blockchain itself, right? Something called BIP34 back in the day, they kind of like fix an issue in Bitcoin itself, basically make sure every single transaction is actually properly unique, right? And the way they do this, the combination transaction now commits to the height, of the actual block, which makes things unique. Don't need to get to that too far. But now because we're able to say, okay, well, we can use that first input, call it the genesis point, apply the asset tag, which maybe is like the name of the asset, maybe it's like hash or something else. There's some asset metadata as well too. And then all of a sudden we can basically use that to have like a unique identifier, right? And we can actually ensure this is like globally unique because we know the assets aren't going to be repeating. We know the genesis points aren't going to be repeating in the chain because you never repeated TXID. So that's kind of like how we do something to get global unique asset IDs. This is really cool. And there's some other things as well that you kind of manifest asset IDs in the similar tree, and also kind of do a thing where I can issue VBucks V1 and then V2, but I still have V1 and V2 be actually fungible alongside of each other. So one of the questions, okay, like exactly how do transfers work, right? So I mentioned a little bit earlier that things are kind of like Bitcoin-like, and they kind of like really take up from like Bitcoin design principles as well too. One of my goals, creating this new system was to make it very friendly to Bitcoin developers, right? It should be, it should feel very native. I don't want to like learn some new language or VM paradigm. I just want to like use all my existing tooling, and the way we set things up, basically everything can be reused for the most part, right? So like I was saying, alongside the TLV, we actually have like inputs and outputs, right? The outputs are kind of like my splits, similar to like a UTXO. They also have inputs, right? And the inputs themselves are actually like another version of like a witness, right? Depending on what you're doing, maybe you need kind of just to prove to me that you're part of something else, but high level, the basic inputs and outputs similar to Bitcoin is like a witness, right? So the one question is, okay, like exactly like, okay, if we're going to add programmability, what do we want to do as far as the VM? So it was like, okay, I feel like one thing I think happened to a bunch of other projects in the past, like they got a little bit caught as far as the VM design space, and that, okay, well, you can do anything, right? But I think one kind of like, kind of a good trait as far as the protocol design is try to like simplify as much as possible, make things, really simple to kind of constrain yourself to have something that's like a little more elegant. So what we end up doing, we actually have Taproot within Taproot, right? So first you basically have the top level Taproot key that's, showing everything and committing to the asset itself. But in the actual script, we basically make a virtual transaction, like a one input, one output, use a Merkle sum commitment of all the outputs and all the inputs as well. So verification just says, okay, well, these values should be equal, right? So I have like 10 over here and then 10 over here. So like if you give me like 10 and 15, I know you're inflating something, right? That's a really cool thing. Then we basically take that transaction and we actually run it through the regular Taproot script VM. So we basically gain all the capabilities of Taproot today without really having to writing new code, and we know this stuff has been very, very well reviewed as well too. So this is basically the version 1 system, version 2 depending on how you're counting it. But in the future, we can actually add new functionality. So we could add WASM, we could add an entirely new VM, or we can basically even introduce things like we can add covenants or even add new opcodes at the Taro VM layer, which is really cool as well too. So one other thing we want to make sure, that this thing's actually like very familiar to people and it's like very easy to use, right? So we actually have this address format. So if I was trying to send to you a Taro asset on chain, we basically use the BEC32, like the similar format that we use for separate addresses, and there's kind of like some information that's actually encoded in that like address itself. And this is all the information I actually need in order to recreate the script tree and then recreate the output key and then send that on chain as well too, right? So using the internal key, which is part of Taproot, your asset script key, which is kind of like exactly how your unlocking works, and also the asset ID, I can reconstruct the tree basically and then create an output and then be able to send you that output on chain as well too. This is really cool because it enables light client support. So one of the past features with some of the prior versions, they actually use something called opportunity, which when you have to actually scan the entire chain, kind of like looking for all these updates to see, okay, anything responding to me at all. But in this case, I can basically put that address into my my neutrino filter, which is this light client. From there, I can say, okay, well, I received an asset. Let me go and then get the final proof and actually be able to spend it as well too. So one other thing that we did to make things a little more client friendly as well too, like so every single asset kind of like defined by its proof. So as I mentioned earlier, it's kind of like a genesis point. The genesis point is basically what's used to derive asset IDs, right? So in this case, beef bucks are defined by every asset kind of like that's descended from this particular genesis point. Similar to today, where it's like Bitcoin is descended from the genesis block. Anything that doesn't have the genesis block in isn't the Bitcoin chain. Anything that doesn't have my out point in it isn't beef bucks as well too, right? So this kind of like lets you kind of like prove and also put provenance directly at the kind of like head of the protocol itself. So anytime I'm like sending something else, I can then use that to verify to make sure I have a legit asset. I'm not getting scammed, I'm not getting inflated or anything else like that. There's another component in the system we're calling a universe. Oh, cool, these are the updated slides, right? So the question is exactly what is a universe. So as I mentioned a little bit earlier, you actually need to kind of like bootstrap what's effectively my knowledge of like knowing that the genesis point is a particular asset, right? So this is kind of like actually like an on-chain structure that indexes into the set of spent out points and then maps that to metadata that is basically the proofs into the chain itself and then also the proofs of the witnesses as well too, right? And the way it works is that like within the BIP, you kind of like define like some special rules as far as how you, after you create the output, the initial asset minting transaction itself, where you require the second output of the next transaction to actually commit to the root hash of which is what the universe is itself. This is really cool because obviously now I can actually watch a set of outpoints on chain to know when new things are being created and minted alongside things as well too. The other cool thing about universe is that once I have this commute and I have the extra data, I can then audit. I can like audit the supply of like a particular asset. So I can say, okay, well, there's 1 billion beef bucks in existence basically, right? I can then use this to verify anytime something's being created and then make sure I'm not accepting 2 billion because there's only 1 billion with that as well too. So the cool thing is like, someone can kind of like maintain like a canonical universe. You can view it as kind of like a federated matrix server, maybe kind of like a Git repo. But at the same time, because SMTs are history independent, I can collect all the data myself and also make sure I'm verifying that we have the exact same hash. So this is kind of, okay, well, everyone can kind of run the number and actually audit supply all the assets in real time as well, which is another really cool trait about it as well. Then you can say, okay, well, I can also kind of combine multiple assets, multiple universes into a multiverse, which is kind of like, keeping track of multiple assets and maybe some of the history as well too. There's one other system in there, which is calling a pocket universe, which is basically a way to kind of like aggregate a bunch of proofs, as far as transfers off chain, right? So you kind of have like a federated system. Maybe someone's like making a game, and the game is close to us anyway. Like maybe we have like some trading card games that's part of the game itself. The operator can basically run this pocket universe. We can actually save a bunch of transfers because with a single transaction, they can do effectively an unbounded number of transfers within the system as well. There's different things I'm throwing around as far as making it possible to exit things as well, and then also different flavors as far as security model. So here's the big question: how does Tower work on LN itself, right? So, in the past, we did some things, around kind of like Litecoin swaps on Bitcoin and stuff. That was like way back, the 2 chains, people remember that. But, we're kind of taking a different approach here, right? So rather than actually having all the assets in the core of the network, the assets are basically fully at the edges, right? Which is really cool, because now, like, the core of the network doesn't actually need to update. They're still using Bitcoin as normal, basically. They don't even know this thing is actually updated, right? But instead, we actually push the complexities all the way to the edges and basically have, just Alice and Carol, and they're kind of like initial, first and last mile, being aware of the assets themselves, right? This is really cool because now we don't actually need an entirely new network for every single asset we're creating, right? We can basically use, the hundreds of $1 million, 3.7K BTC plus that's probably out of date already, on the network today, right? This is really cool because now we can actually, retain all the network effects, actually reuse all that liquidity. So now we have like more demand for transfers, which means more demand for activity, which means more free revenue, which means the network grows, becomes more useful. And now this is kind of like a very cool flywheel, basically. Once again, keeping Bitcoin at the center. So now this kind of positions Bitcoin as kind of like the global, crossing layer for any other value, right? I don't really care what's at the edge, but in any case, everything's actually crossing in Bitcoin. People in the internal network, are also actually getting all the routing fees in Bitcoin as well, and that's like a really dope part about the way things are set up. So the other really important thing is obviously multi-hop, right? Multi-hop is kind of like what changed everything when Lightning came out, okay? Because otherwise, before we get direct channel, it's not very cool. We want to be able to make sure we're actually routing across the entire network. So, if you recall, actually, Tower has like a scripting system within itself, so we can actually remap the existing HLC structure in the Tower scripting system, and actually then just have HLCs working normal, right? So now my multisig commits to a asset tree, which is basically mine and your balance. HLCs now manifest, both on the HLC layer, but then also on the Tower layer as well too. We then actually use this to actually handle multi-hop with that way everything works. And the way it works is kind of like you can do kind of like a little trick of like the invoice kind of like does most of the work, right? So today, like whenever you're using Bitcoin and maybe you're paying something on Lightning, like maybe it says like USD on the left side, but then you actually get a Bitcoin invoice, right? Someone quoted a rate, some conversion happened there. People would probably just pay it, they don't really think about it, right? But in the way this works is like, okay, now like if I'm sending from Dave and I'm Alice, Dave gives me an invoice. That invoice now has that USD amount basically. Now it's my job to kind of like route everything properly with the network in order to Dave. So if I send too little, Dave's going to cancel back. It's okay, I want a 10 set, you send me 9 set, right? So it's a pretty elegant way of kind of like pushing complexity to the edges and also making sure that everything is primarily on the wallets as well too. Really excited about this, and like so it's going to be implemented as kind of like a series of extensions onto the Bolt protocol, right? Maybe kind of like a blip format. We can kind of like add additional metadata to funding and also HLCs as well too. So it's kind of a really cool thing where people can opt into it. If people don't want to use it, that's fine. They can enjoy the increased transfer and the increased demand and activity from all these new tower transfer. But now all of a sudden we can do things like go up more directly after credit cards. Maybe if people can so in theory I could send BTC and the merchant receives USD on the other side. So now everything's fully onto the actual Bitcoin ecosystem as well. I think one other thing as well too, this is going to really dramatically reduce any of the cost of the on and off ramps, right? Because now all of a sudden it's already kind of like, in the Bitcoin land, right? They don't need to worry about like going to an exchange, doing all that stuff or whatever else. You can actually do a bunch of really cool things. The other cool thing about the way the tower works, because it's all like, fully Bitcoin input and output, we can actually kind of like have like non-custodial swaps of anything, on the actual Bitcoin chain itself. And what's a swap? It's a multi-input, multi-output transaction, basically moving things back and forth. And that's Taro. And if you think this is cool, we're hiring at Lightning Labs, many different positions, researchers, engineers, people on front end, managers, talent, engineering as well too. You can check out our job listings on the website and also maybe email us if you don't see anything that's on there that you think is cool and you want to kind of like get into. But yeah, that's Taro. Thank you.